and laboratories. Today, we are going to start the second session from our valuable professors with the eminent talks.
A position of eminence makes a great person greater.
Good morning to everyone present here. Now I welcome Dr. N. Suresh, Department of Physics, Assistant Professor, Department of Physics, to introduce our today chief guest, Professor Dr. S. Gunasekharan, sir.
A position of eminence makes a great person greater. I am fortunate enough to have this opportunity to read his profile at this platform. Most respected, Honorable Professor Dr. S. Gunasekharan, sir, Dean, Research and Development of St. Peter's University, Higher Education and Research, Avadi, Chennai, began his teaching career at the Pachippas College, Chennai, in 1978, and remains a dedicated teacher to this day. He is beginning electronics and microprocessing, but Dr. Gunasekharan, sir, was anxious to do more than just teach a syllabus. So he was promoting research activity in the department by raising funds to equip the laboratory with research tools. As research dean, he took support from the management of St. Peter's Institution of Higher Education and Research, and he has established sophisticated analytical instrumentations facility housed with advanced spectrophotometers. His area of research is the application of spectroscopy in various fields that are likely to yield results beneficial to society, like material science, medical physics, environmental science, and molecular dynamics. In fact, recognition the powerful tool that spectroscopy can be in physics research, Dr. Gunasekharan, sir, has coined the term spectrophysics till date. Dr. Gunasekharan, sir, has successfully guided 78 candidates who have obtained their PhD in material science, medical physics, environmental science, and molecular dynamics. He has to his credit more than 409 publications in reputed journals, and has H index as 36 and I-10 index as 142 with 5,676 citations. He has failed first patent so far. He is also extending his material service as being referee of many reputed journals. Dr. S. Gunasekharan, sir, is the founder, president of Indian Spectroscopic Association, SPA, started on April 23, 1998. It is the peak of a strong belief that enlightened minds and empowering them through spectroscopy and physical phenomena in the way for battling and eliminating social evils and uplifting society. ISPA is privileged to honor the notable services of the spectrophysics with a Lifetime Achievement Award to those who dedicated themselves in the spectroscopy research and still working on the respective fields. For young researchers who have made excellent contributions in the field of research, have been honored with ISPA Dr. S. Gunasekharan, sir Award during conference seminars organized by ISPA. Dr. Gunasekharan, sir, has also rendered greater service to the School Education Board of Government of Tamil Nadu by serving as a Master of Syllabus Revision Committee and Chairperson of Book Writing Committee. He also authored 14 books for higher secondary physics, secondary science, and environmental education in both English and Tamil medium. Dr. S. Gunasekharan, sir, has the honor of being selected for the post of Registrar, Periyar University, Salem, and this administrative post for the full term of 3 years from August 2008 to August 2011, providing that his administrative skill were no way inferior to his scientific skills. The sincere and dedication hard work fetched him many awards right from his post-graduation. Sir was honored with many prestigious awards. Most recently, in the month of July, August, and September 2017, Dr. Gunasekharan, sir, is honored with 4 prestigious awards: Tamil Nadu Scientific Award, Eminent Educational Award, Best Citizen of Indian Gold Medal Award, and Indo Global Research Excellence Award by Government of Tamil Nadu and various reputed organizations. He is conferred with Lifetime Achievement Award by National College Tiruchirappalli in February 2019, Lifetime Achievement Award by University of Madras in April 2018, and a Lifetime Achievement Award by Amet University in March 2018. In September 2016, he is conferred with Award of Research Excellence by Indus Valley Foundation, USA. In August 2016, he is bestowed with Bharat Ratna Rajiv Gandhi Gold Medal Award for his participation and contribution to research and society by Global Economic Progress and Research Association. Dr. Gunasekaran sir has bestowed with Arivali Kalanjiyam Award 2015 by Mailai Thiruvalluvar Tamil Sangam, Chennai. He was obtained Best Physics Student Award during his course at St. Joseph College, Tiruchi. Many awards have been conferred on Dr. Gunasekaran sir in the light of his dedicated service to teaching and research. To mention a few, Award for Excellence in the sphere of academic, research and administration in August 2013 by Sri Vidyamadha Arts and Science College, Kateri, Uttangarai, Tamil Nadu. He is awarded for the achievement in the final of higher education by St. Joseph College 2013, Tiruchi. Dr. Gunasekaran sir was conferred with Lifetime Achievement Award during National Conference on Recent Advances in Applied Physics. Sir was awarded with Best Teacher Award by Lions Club International and Pachipas College, Chennai. He was conferred with Eminent Scientist Award in 2010 by Sri Kanchi Kamakodipidam for his outstanding contributions to science and technology. He is awarded with Research Guide Achievement Award for the outstanding research in the field of spectroscopy. The Psychometric Education Service Award by the GCC School of Creativity, Intelligence and Research Foundation Trust for his valuable service and contributions to human resource development. A certificate of appreciation for the successful conduct of the unique technique seminar for PG and MPhil students at the 10th state level technique seminar in physical science in 2008. A certificate of appreciation by the journalist Spectrochemica Acta in 2007. It is very evident that from humble beginning, that Gunasekaran sir has come a long way, achieve all that he has, and if he stand tall today, it is the only through sheer dint of hard work, honesty, sincerity, perseverance, and self-confidence. As a result, his board of insight in the research has brought in a prestigious Tamil Nadu Scientific Award, TANSA, in physical science for the year of 2013. Thank you.
Thank you, sir.
Thank you.
Thank you, sir. Now
Thank
I
you.
invite Professor Dr. S. Gunasekaran sir, Dean Research, St. Peter's University, Chennai, to deliver his talk.
Good morning to one and all.
Brought in a prestigious Tamil Nadu Scientific Award, TANSA, in physical science for the year of 2013. Thank you.
Repeat avudunga. Okay. Good morning to one and all.
Thank you, sir. Now I invite Professor Dr. S. Gunasekaran sir, Dean Research, St. Peter's University, Chennai, to deliver his talk.
Okay. Thank you very much, madam.
Thank you, sir.
Good morning to one and all.
Brought in
Doctor,
for the year of 2013.
most
Sir,
respected.
repeat
Repeat avudunga nange.
This is technical, sir.
Good morning
Technical
to one and all.
people. Thank you, sir. Now I invite
Sir,
Dr. Repeat avudunga, sir. Nine and go back as a technical. Repeat
Sorry,
sorry, sir.
Okay.
Sorry for inconvenience.
Okay.
Good morning to one and all. Brought in for the year of 2013.
Most respected. Repeat avudunga nange.
This is technical, sir.
Good morning to
Technical.
one and all.
Thank you, sir. Now I invite
Sir,
Dr. Repeat. Sir, now it is okay, sir.
okay. Respected Dr. R. Arivichelli, HOD of Physics of this esteemed institution, the great Sri Vidya Mandir College of Arts and Science, and dear Dr. N. Suresh, who has given the nice introduction about me. In fact, which was written by me yesterday and sent to Dr. Arivichelli. Dear professors from various institutions, my good friend Dr. Jai Shankar, professor from Sri Venkateswara University, Tirupati, respected principal, vice principal, delegates, dear young budding scientists, ladies and gentlemen. Good morning to one and all. In fact, I feel proud to say few words about this department, because my association with this institution is not 1 year or 2 years, more than 20 years. That is nearly 2 decades. 2 decades. In the year 2001, in the month of during the month of January, I think so, I came to this institution as a member of affiliation committee nominated by Periyar University to give the approval for BSc Physics course in this esteemed institution just 20 years before. So this was my first visit to this campus. That time I had met the founder of this institution, that is Kalvi Pidamakan. Just 4 or 5 years before, Thiru V. Sandrasekharan Ayya, he was conferred with Kalvi Pidamakan Award by Indian Spectrophysics Association to remark the services rendered by him for promotion of higher education in Salem chapter. So we started with the BSc Physics course in this department. Now, the Department of Physics having a number of programs along with the BSc Physics, PG program, MSc Physics, then MPhil Physics, PhD Physics. Just half an hour before, I had discussion with your HOD, the convener of this conference, Dr. R. Arvichelli Madam. So nearly more than 150 scholars were awarded MPhil degree. More than 150 students have successfully completed their MPhil degree from this department. Nearly 15 people are pursuing research leading to PhD in this department under the guidance of so many supervisors in the department. Moreover, they are conducting a national conference, international conference, workshops, young science programs sponsored by TNSCST, then sponsored by Department of Science and Technology. I think
Sir,
so many programs they are conducting the program.
Slide is not moving, sir. The slide is not.
Yeah.
Slide is not moving.
Yeah. So conducting, because so I feel proud to understand that the Department of Physics of this Vidya Mandir College is doing an excellent service for promotion of higher education. I should congratulate Dr. Arvichelli and her colleagues with the able leadership of our founder and principal, vice principal, secretaries. They are doing excellent service for promotion of higher education in Periyar University chapter. As you know, number of young budding scientists are present, have joined with this program. You are all innovators, including myself, including senior scientists. I think we are delivering the talk on different titles. They are innovators. You must know the main difference between invention and innovation. The today's topic for this session is father of Indian science. That is tribute to Sir C.V. Raman. Tribute to Sir C.V. Raman. He is an inventor. You must know the main difference between innovations and invention. I understand that most of the delegates or participants, students are from physical science faculty members. What is the main difference between invention and innovation? Invention, creation of a product or introduction of a process called the invention. But innovation, making a significant contribution to an existing product is called the innovation. For example, you people are studying microprocessor. VP was invented by someone. That is the invention. Using the microprocessor, we are making so many devices, home appliances, industry control systems, like water level indicator, temperature controller, measurements, crane, and etc. etc. All interfaces circuitry are the innovations. I take Maxwell's electromagnetic equation. Maxwell's electromagnetic equation invention and the legendary polynomial in mathematical physics or in mathematics is the invention. Using Maxwell's electromagnetic equation or legendary equation, studying the propagation of the microwave signal in electronic communication system is called the innovation. And similarly, photoelectric effect is the invention made by Einstein. And what is application of photoelectric effect? Solar panel, solar light, solar cooker, etc. That is the innovations. Raman effect. It was invented by Sir C.V. Raman, our father of Indian science. So using the Raman effect, basic Raman scattering, Raman spectroscopy, Raman invention, laser Raman, FT Raman, resonance Raman, coherence anti-stroke resonance Raman, surface enhanced Raman spectroscopy, remote sensing. So these are called the innovations. So you must know the main difference between invention and innovation. My dear young budding scientists, I'm going to give you a brief account on life history of our Sir C. Raman for about 25 minutes. Before which, so you must go through a book written by Professor R. Pathasarathi, retired professor of IIT Chennai, former professor of IIC Bangalore. He wrote a book. Title of the book is Paths of Innovators. 2 volumes. It comprises a collection of scientists, their lives, their struggles, their achievements, and their laurels. For each and every innovator, Professor Pathasarathi has given briefly 3 to 4 pages, their life history. In mathematical science, there are 62 innovators. In physical science, 73 innovators. Chemical science, 44 innovators. Life sciences, 36 innovators. Engineering and technology, 76 innovators. A total of 291 innovators. Life history is presented in the book. Title is Paths of Innovators, written by Professor R. Pathasarathi. 2 volumes, which is available in Ikingbatham, Chennai. My request to our principal and head of the Department of Physics, Dr. IVCPEMM, and to have to get these 2 books, at least 5 volumes, 5 copies for reference in our institute library, better. The 291 innovators, ஒவ்வொரு ஸ்டூடெண்ட்டும் ஒரு நாளைக்கு ஒரு இனோவேட்டர் படிக்க சொல்லுங்க. Just 3 to 4 pages, maximum 5 pages. That's all. ஒரு நாளைக்கு a student should go through the lives, their struggle, their achievements, and the laurels of one innovator. ஒரு நாள் படிச்சா கூட within a year they can able to complete the life history of 291 innovators. They will get self-motivation towards research bent, scientific bent. That is a very, very important thing. All because of the innovations, inventions made by all these 291 innovators, we are living in the modern era of science. My dear young budding scientists, we are doing a lot of wonders in the field of physical science. We have made quite stir in the field of physical science. Recently, in the year 2005, we have celebrated International Year of Physics. In the year 1905, a great scientist in physical science, Albert Einstein, he invented three major discoveries. Number one, Brownian movement. Second discovery was theory of relativity. Third one is photoelectric effect. For photoelectric effect, he was conferred with Nobel Prize. All these three major discoveries were made by in 1 year 1905. Great achievement made by Albert Einstein. 1905 plus 100 is equal to 205. That's why to remark the completion of the 100 years of all these three major discoveries made by our great Albert Einstein, world has celebrated the International Year of Physics in the year 2005. Another important thing, my dear friends, golden decade for physics. As far as the physical science, for Indian scientists, the field of physical science, the year between 1920 and 1928, the year between 1920 and 1930 can be considered as golden decade for physics for Indian scientists in the field of physical science, physics. ஏனென்றால் Saka ionization formula in the year 1920. Most statistics in the year 1924. Chandrasekhar limit in the year 1930 or 31. The great celebrated Raman effect in the year 1928. All these four discoveries were made by our Indian scientists between 1920 and 1930. Therefore, the decade 1920 to 1930 is considered as golden decade for physics for Indian scientists. The great Raman, celebrated Raman effect. This is the main agenda for the present talk. Raman effect. My dear young students, நீங்க படிக்கணும். The landmark in the history of Tamil Nadu. இப்போ சர்சிவராமன் பத்தி அதிகமா அவேர்னஸ் இல்லாம அதிகமா இருக்கேன் நம்மளும். That's why நான் எழுதின +2 புக்ல I have given life history of Sarsivaram in one page along with the Raman effect, the theory given by Raman scattering. The Raman spectroscopy in தெரியணும். What is Raman effect தெரியணும். What is the life history of Sarsivaram? The landmark in the history of Tamil Nadu is the birthplace of Sarsivaram. Tiruchirappalli, Srirangam, and Thiruvanekkaval. நம்ம தமிழ்நாட்டில் பிறந்த சர்சிவராமன் ஐயா அவர்களுக்கு the great invention, Raman effect, Raman scattering, Raman spectroscopy பயன்படுத்தாத எந்த ஒரு லேபுமே இல்லைன்னே சொல்லலாம் உலக அளவில். அந்த அளவுக்கு Raman spectroscopy, Raman invention had made a quite stir in the field of research for materials characterization. Very, very important thing. All applications. Therefore, to remark the invention of the Raman effect on 28th February 1928, every year we are celebrating National Science Day to commemorate the Raman effect date 28 February. A gift that is intended to show respect, gratitude, and affection and admiration. That is called we are celebrating the day on which Raman effect was introduced or invented or announced. There is a tribute to Sarsivaram. Tribute means a gift that is intended to show respect, gratitude, and affection and admiration. This is a right time for us, right scientific platform for us to recognize the services rendered by Sarsivaram. That's why we are celebrating National Science Day on 28th February every year. That is very important thing. My dear students, what is the importance of Raman effect? Nominations made for Sir C.V. Raman for the Nobel Prize. I have made a brief survey on this title, Raman nominations made for Sir C.V. Raman for the Nobel Prize. The Raman effect was invented in the year 1928. The next immediate year, 1929 Nobel Prize award for yaar tharala in physical science. Physics lage yaar tharalaandra oru mudi varappo 48 nominators proposed 29 persons. 48 nominators proposed 29 persons for Nobel Prize. De Broglie, Cabens, Raman, and Wood were declared for the prize. But De Broglie was recommended by the committee. At the time, Ramanukku recommendation irundhalum, but kedaikala. So De Broglie was recommended by the committee. But the next year, 1930, 37 nominators proposed 21 persons. You see, Raman was the most suitable person as he was proposed 10 times as a single candidate for the prize. That is a specialty. You see the list. E. Block, he recommended Wood and C.V. Raman. Bohr, Niels Bohr, he recommended Wood and Sir C.V. Raman. Then O. Chol-Chan, he recommended Raman and another person, through two persons. Perrine, he recommended Raman and Elsenberg. De Broglie, he recommended Raman. Broglie recommended Raman. Pfeffer recommended Raman. Stark, Raman. Rutherford recommended Raman. Wilson, he recommended Raman. You see, Raman was the most suitable person as he was proposed 10 times as a single candidate for the prize. This is a specialty. My dear students, PG particular students, you should know the weightage of our Sir C.V. Raman. Inventions and Nobel Prize awarded. Discovery of X-rays by Ranchan. Year of invention 1895. Year of Nobel Prize 1901. After 6 years only, number of years waited to get Nobel Prize, 6 years. Similarly, Braun, he waited for 12 years. Wien, he waited for 18 years. Von Laue, he waited for 21 years. Planck, invented in the year 1909, discovery of energy quanta. Year of Nobel Prize 1918, he waited for 9 years. Stark, 14 years. Einstein, discovery of photoelectric effect in the year 1905. He got the Nobel Prize only 1919 after 14 years. Einstein, 6 years. Hertz, 12 years. But the specialty is C.V. Raman invented Raman effect in the year 1928. He was awarded Nobel Prize in the year 1930, just within 2 years. This is a specialty. If a Doctor of Science submit thesis to university, to get Doctor of Science in your field, which requires at least minimum 3 to 5 years. But Nobel Prize is admissible. 6 வருஷம் 12 வருஷம் 18 21 வருஷம். ஆனா Sir C.V. Raman கண்டுபிடிச்ச Raman effect கொடுத்த Nobel Prize within 2 years he is able to get the Nobel Prize. This is the importance of the Raman effect. Impact of the Raman effect among the scientific community. அந்த பெருமை நம்ம தமிழ்நாட்டுக்கு தான் சேரும். That is very very important. நான் தமிழ்நாட்டில் பிறந்த நம்ம Sir C.V. Raman is the first scientist awarded Nobel Prize in science from Asian country. உங்களுக்கு தெரியணும். அந்த அளவுக்கு பெரிய சயின்டிஸ்ட் நம்ம கொடுத்துருக்கோம் இந்த உலகத்துக்கு, நாட்டு இந்தியாவுக்கு, உலகத்தையே கொடுத்துருக்கோம். It was invented by Sir C. Raman. Actually, Sir C. Raman, he has announced this Raman effect, this invention, on 28th February 1928 at Indian Association of Cultivation of Science, Calcutta. It was a red day for the scientific community all over the world. National Council for Science and Technology Communication, one scientific organization, they have submitted a proposal to Government of India, to then Prime Minister, late Shri Rajiv Gandhi, to celebrate Raman effect, celebrate National Science Day, to remark the invention of the Raman effect on 28th February every year. Late Rajiv Gandhi, then Prime Minister, he has given the approval immediately. Since then, from 1986, we are celebrating the National Science Day. This is the importance of celebration of the National Science Day. My dear young students, இந்த டாக்கே வந்து எங்களை மாதிரி வயசான சயின்டிஸ்டுக்கு அவசியமே இல்லை. ஆல்ரெடி யூ நோ பெட்டர் அபவுட் சர் சி ராமன் லைஃப். But as young budding scientist, you must aware of the life history of Sir C. Raman. சின்ன குழந்தையா இருக்கும்போது ராமன் இருக்கா இல்லையா, வேவரிங் மைண்ட், ஒரு ஸ்டேபிள் மைண்டே இருக்காது. அனிமிக் பேஷண்ட், ரத்த சோகன் சொல்லுவாங்க தமிழ்ல, அனிமிக் பேஷண்ட். எந்த வேலை கொடுத்தாலும் அந்த அளவுக்கு ஒரு ஸ்ட்ராங்கா செய்ய மாட்டார். வேவரிங் மைண்ட், ஃபோக்கஸிங் மைண்டே இருக்காது. ஏதோ ஒரு வாரம் போவாரு, சொன்ன ஒர்க் செய்ய மாட்டார், சரியா படிக்க மாட்டார் பையன். சந்திரசேகர் ஐயர் இருக்கார் இல்லையா, லெப்ட்ல இருக்கார் இல்லையா, சந்திரசேகர் ஐயர் அப்பா. He was physics come mathematics professor. He was come physics and mathematics professor. And his wife, Srimati Padmavati Ammal, Parvati Ammal, Srimati Parvati Ammal படிச்சவங்க தான். அவர் ப்ரொஃபஸர் மேத்தமெட்டிக்ஸ் பிசிக்ஸ், பார்வதி அம்மாள் படிச்சவங்க. என்ன பண்ணார்னா, ஸ்ரீ சந்திரசேகர் ஐயர் தான் பையன் டெமான்ஸ்ட்ரேஷன் பண்ண வேண்டி கான்வெக்ஸ் லென்ஸ் இருக்கு இல்லையா, ஒரு 10 சென்டிமீட்டர் 25 சென்டிமீட்டர் போக்கல் லென்த்தில் கான்வெக்ஸ் லென்ஸ் வீட்டில் வச்சிருக்க. பையன் சரியா படிக்கலையே, வேவரி மைண்டா இருக்காரு, ஃபோக்கஸி மைண்டா இல்லையே, ஒரு கவலை அம்மாவுக்கு, பார்வதி அம்மாளுக்கு. மார்னிங் ஒரு 11 AM இருக்கும், நல்லா வெயில் காயுது. பார்வதி அம்மா தான் பையன் கூப்பிடுறாரு, ராமாங்கவா. பேப்பர்லாம் எடுத்து பிட்டா கிடிச்சு வாசல்ல கீழே போட்டுட்டு, அந்த லென்ஸ் இருக்கு இல்லையா, அந்த லென்ஸ் வந்து அப்படியே வந்து போக்கல் லென்த் இல்லாம அப்படியே வந்து இப்படி காட்டுறாங்க. பேப்பர் ஒன்றும் ஆகலை. ராமன் அப்சர்வ் பண்றான் பையன். அந்த பேப்பர் கூச்சி இருக்கு இல்லையா, பிட் பேப்பர்லாம் கூச்சி இருக்கு இல்லையா, அது வந்து அந்த லென்ஸுடைய பிரின்சிபல் போக்கஸ்ல கரெக்டா வச்சு ஒரு 5 மினிட்ஸ் அப்படியே காட்டுறாங்க பார்வதி அம்மா. அந்த ஃபோக்கல் பாயிண்ட்ல வைக்க உடனே 5 மினிட்ஸ் இருந்த உடனே, பிகாஸ் ஆஃப் த ஹை ரேடியேஷன், பேப்பர் வந்து அப்படியே வந்து பேர்ன் ஆகுது, பத்தி எரியுது. அப்ப சொல்றாங்க பார்வதி அம்மா தம் பையன் கிட்ட, ராமன் கிட்ட, ராமா உன் மனதை ஒருமுகப்படுத்து, அப்பதான் வாழ்க்கையில் சாதிக்க முடியும். வெரி குட் எக்ஸ்பீரியன்ஸ். அம்மா கொடுத்த அந்த டெமான்ஸ்ட்ரேஷனுக்கு லென்ஸ் வச்சுங்க, மனதை ஒருமுகப்படுத்தினால் நாம சாதிக்க முடியும். அந்த ஒரு பாயிண்ட் தான் டர்னிங் பாயிண்ட் அமைஞ்சது நம்மளுடைய ராமனுக்கு. மை டியர் யங் பட்டிங் சயின்டிஸ்ட், he was brilliant student from the very start. அந்த அனிமி பேஷண்ட் இருந்தாலும், அண்ட் வேவரிங் மைண்டா இருந்தாலும், ஃபோக்கஸிங் மைண்டு இல்லாம இருந்ததாலும், அம்மா கொடுத்த அந்த ஃபோக்கல் அந்த லென்ஸுடைய டெமான்ஸ்ட்ரேஷன் பிறகு மோட்டிவேஷன் ஆயிட்டான் பையன். பிரில்லியன்ட் ஃப்ரம் த வெரி ஸ்டார்ட். ராமன் பிறந்தது 7th November 1888, திருவானைக்காவல், ஆல்ரெடி மென்ஷன் பண்ணிருக்கு இல்லையா. He was a brilliant student from the very start. அதாவது திங்க் பண்ணோம். அவர் படிச்சது எங்க தெரியுங்களா? BA பிசிக்ஸ் படிச்சாரு 1901 மாநில கல்லூரி சென்னை. He did BA physics and BA physics honors. அந்த காலத்துல வந்து BSc இருக்காது, BComலாம் இருக்காது, MSc இருக்காது, MComலாம் இருக்காது, எல்லாமே BA தான். BA physics, BA chemistry, BA botany தான் படிப்பாங்க. PG இருக்காது, MA இருக்காது. BA honors-னா MA, அது PG அர்த்தம். He got admission for BA physics in the year 1901 during British government period. That is important thing. அப்ப ரிசர்ச் எல்லாம் ஒண்ணுமே இல்லை. ரிசர்ச்னா என்ன யாருக்குமே தெரியாது. இப்போ நீங்க வந்து you are doing research, you are doing your MSc project work under the guidance of your faculty members, you are doing MPhil project, you are doing your PhD program under the able guidance of your supervisor. அப்பலாம் சூப்பர்வைசர் இல்ல, அண்ட் MPhil dissertation கைடு இல்ல, ப்ராஜெக்டுக்கு கைடு யாரும் இருக்க மாட்டாங்க. 1901ல he got admission for first year physics. என்ன ஒண்ணுன்னா, when Raman passed his matriculation, he was just 12 years. கேட்கலாம் நீங்க, ஒரு மெட்ரிகுலேஷன் பாஸ் பண்றதா இருந்தா 17 வருஷம் முடிக்கணும், வயசு வரும். எப்படி 5 வருஷத்துக்கு முந்தைய ஒரு மெட்ரிகுலேஷன் பாஸ் பண்ணாரு? Because of his brain, because of his knowledge, because of his skill, because of his commitment with the subject, because of his dedication to the subject, he was given promotion for 5 years in school education. அதான் முக்கியம். எந்த அளவுக்கு நீங்க பிரைட்டா இருந்தீங்கன்னா, அந்த ராமன் படிக்கிறப்போ ஸ்கூல் எஜுகேஷன்ல 5 வருஷத்துக்கு முந்தைய வந்து he got promotion. That's why instead of completing matriculation at 17 years age, was able to complete 5 years before 12 years. அப்ப எவ்வளவு குட்டி பையனா இருப்பான் பாருங்க. BA பிசிக்ஸ்ல, அந்த BA பிசிக்ஸ் லேப்ல பிரசிடென்சி காலேஜ் போனீங்கன்னா இப்ப இருக்கு பாருங்க, ஒரு கேலரி இருக்கும், ரூம் நம்பர் 100. அந்த 100 தான் ராமன் படிச்ச ரூம் சொல்லுவாங்க. அங்க ஃப்ரண்ட் பெஞ்சில் உட்காந்துக்கலாம் பையன், இதே மாதிரி கேப் போட்டுக்கின்னு தலப்பா கட்டிட்டு குட்டி பையனா ஸ்கூல் படிக்கிற பையனா உட்காந்துட்டு இருக்கான். ஆல் அதர் ஸ்டூடெண்ட்ஸ் 17 years ஏஜ், எல்லாம் பெரிய பசங்களா இருக்காங்க. ஃபர்ஸ்ட் BA பிசிக்ஸ் ப்ரொஃபசர் EH எலியட். அப்போ வந்து ப்ரொஃபஸர்லாம் வந்து காலேஜில் நம்மள மாரி நம்ம தமிழ்நாட்டில் இருக்க மாட்டாங்க, இந்தியாவில் இருக்க மாட்டாங்க. எல்லாமே இறக்குமதி செய்யப்பட்ட வாத்தியாருங்க ஃப்ரம் லண்டன். பிகாஸ் பிரிட்டிஷ் கவர்மெண்ட்ல ப்ரொஃபசர்ஸ் வேர் ஃப்ரம் லண்டன், UK. ப்ரொஃபசர் EH எலியட், ப்ரொஃபசர் EH எலியட், இங்கிலீஷ் ப்ரொஃபசர். வகுப்பு என்ட்ரா ஆகிறார். என்ட்ரா ஆன உடனே அந்த சின்ன குட்டி பையனை பார்த்து அஸ்டானிஷ்ட், ஷாக், ஒரு சர்ப்ரைஸ். என்ன இந்த பையன் ஸ்கூல் போற பையன் மாதிரி இருக்க, தப்பி தவறி தெரியாம வந்து உட்காந்துட்டானோ என்ற ஒரு இதுல பையனை கூப்பிடுறார். தம்பி இங்க வா. வாட்ஸ் யுவர் நேம்? ஹவ் ஓல்ட் ஆர் யூ? வாட்ஸ் யுவர் ஃபாதர் நேம்? வாட்ஸ் யுவர் ஃபாதர்? Why you have come here? So these are all the questions raised by Professor EH Eliot. நீ இந்த வகுப்பு மாணவனா? இதான் கேட்ட கேள்வி. இந்த 5 கேள்வி கேட்டதும் வகுப்புல இருந்த மற்ற மாணவர்கள்லாம் வந்து சிரிக்கிறாங்க. ஆல்ரெடி இந்த பையனை பார்த்து சிரிச்சிட்டு இருக்காங்க. நான் குட்டி பையனா இருக்கேன், எப்படி வந்து BA ஜாயின் பண்ண சிரிச்சிட்டு இருக்காங்க. மை டியர் ஃப்ரெண்ட்ஸ், மை டியர் ஸ்டூடெண்ட்ஸ், அவ்வளவு பெரிய ஒரு இங்கிலீஷ் ப்ரொஃபசர் ஃப்ரம் லண்டன் 5 கொஸ்டின்ஸ் கேட்குறாங்க. அதுக்கு ஆன்சர் வெல் வித்தவுட் எனி ஹெசிடேஷன் இமிடியேட்லி ரிப்ளை, சார் மை நேம் இஸ் வெங்கட்ராமன், மை ஃபாதர் நேம் இஸ் சந்திரசேகர் ஐயர், he is physics cum mathematics professor, I am 12 years old, today I got admission for first BA physics. That's all. So these are all the answers given by the small boy Venkatraman, Chandrasekhara Venkatraman, C.V. Raman. எப்படி இருப்பாரு? சின்ன பையன் பாருங்க. இதை விட மேல என்னன்னா இன்ட்ரெஸ்டிங், இதை விட மேல என்னன்னா, he went to meet the HOD, அந்த பிரசிடென்சி காலேஜ் மாநில கல்லூரியில் இருக்கிற ப்ரொஃபசர் ஜோன்ஸ், then HOD, he is also from London. அதாவது செகண்ட் எம்ஏ போறான் பையன், செகண்ட் எம்ஏ அதாவது பி ஆனர்ஸ் படிக்கிறான், ஐ மீன்ஸ் எம்ஏ. he went to the HOD room. Sir, I want to pursue my research. பாருங்க, அங்க சூப்பர்வைசர் இல்ல, டிபார்ட்மெண்ட்ல யாரும் கைட் பண்றதுக்கு யாருமே இல்லை. ரிசர்ச் கான்செப்டே இல்லை அங்க தமிழ்நாட்டில், ஐ மீன் மதராஸ் ஸ்டேட்ல. ஈவன் தென் அந்த மைண்ட் பாருங்க, டுவர்ட்ஸ் inclination of research. In 1906, he met Professor Jones, then HOD. He got permission to avail the facilities in the Department of Physics, small optical system. He made some basic measurements. அதை பேஸ் பண்ணி he prepared a paper. He has published one paper. The first paper, diffraction at the stage. This is the first paper by Presidency College. இன்னும் சொல்ல போனாக்கா, not Presidency College. This was the first paper published by a scholar from Madras State. அதான் சொல்ல முடியும். Second paper on surface tension. The titles of the papers, paper diffraction at the stage. Second paper on surface tension. These two papers was published by him in Philosophical Magazine and Journal of Science, London. Very reputed journal. இந்த ரெண்டு பேப்பரையும் படிக்கிறார் ஒருத்தர். டாலித், நோபல் பரிசு வாங்கின ஒரு சயின்டிஸ்ட் லண்டன்ல படிச்சுட்டு ரொம்ப பெருமைப்படுறார். ஒரு மதராஸ் ஸ்டேட் இந்தியாவில், பாரத்ல இந்த அளவுக்கு குவாலிட்டி பேப்பர் எழுதியிருக்காங்களே. He wrote a letter to Presidency College. என்ன எழுதியிருக்கா தெரியுங்களா? டியர் ப்ரொஃபசர் ராமன். பையன் வந்து பி ஆனர்ஸ் தான் படிக்கிறான். அந்த சின்ன ஏஜ்ல he was able to publish 2 papers. When Raman published second paper, surface tension, he was just 18 years. எதுக்காக சொல்றேன்னா, நம்ம பிஎஸ்சி முடிச்சுட்டு எம்எஸ்சி முடிச்சு ப்ராஜெக்ட் பண்றீங்க. ஐ திங்க் 21 to 22 இயர்ஸ் ஆகுது. பாருங்க, 5 வருஷத்துக்கு முந்தைய பேப்பர் பப்ளிஷ் பண்றான். நம்ம ஏன் பண்ணக்கூடாது? நீ பண்ற எம்எஸ்சி ப்ராஜெக்டை should be published in the reputed journal. அதான் மெயின். நீ பண்ற எம்ஃபில் டிசர்டேஷனை should be published in the reputed journal. இந்த கட்டுரைகளை எழுதியது உள்ளபடியே ஒரு பேராசையாக தான் இருக்க வேண்டும் என்பது அவரது கணிப்பு. தட் இஸ் நூல் பரிசு பெற்ற ராலை. அந்த அளவுக்கு 2 quality papers. These 2 papers laid a strong foundation to him to pursue research in near future. My dear young budding scientists, Calcutta, Indian Association of Cultivation of Science. They have published 6 volumes of Sir C. Raman's publications, papers. First volume என்ன தெரியுங்களா? Scattering of light. Second volume, acoustics. Third volume, optics. Fourth one is optics of minerals and diamonds. And fifth volume is physics of crystals. And sixth one is floral colors and visual perception. டாக்டர் அறிவிச்சொல்லி கவனிக்க வேண்டியது என்னன்னா, நீங்க உங்க பிரின்சிபல் கிட்ட பெர்மிஷன் வாங்கி உங்க மேனேஜ்மெண்ட்டை கொடுத்து, த ஃபவுண்டர் ஆஃப் த இன்ஸ்டிடியூஷன், தட் இஸ் த கிரேட் கல்வி பிதாமகன், இந்த 6 வால்யூமும் மேபி 20,000 இருக்கும். நீங்க வாங்கி you have to maintain in the university stack for reference. ஒரு வால்யூம் வாங்க அவ்வளவு போதும். The researcher, those who are pursuing the PhD and they can go through the papers published by Sir C. Raman, they will understand how to write the quality research articles. They can see the style of English used by Sir C. Raman. That is very, very important thing. My dear friends, he got first place in the state BA honors. Then he wrote UPSC examination. Union Public Service Commission science student. In 1907, he wrote UPSC examination. He stood first place in the country. ஒரு physics படிச்ச பையன் 18 வயசுல UPSC exam எழுதுறாரு 1907ல he stood first place in the country. அதான் முக்கியம். He was appointed as Deputy Accountant General, Finance Department of India, Calcutta. நீங்க கேட்கலாம் ஏன் கல்கட்டா போடலன்னு கேட்கலாம். During 1907 அந்த பீரியட்ல Calcutta was the capital of India. இப்பதான் டெல்லி. உங்களுக்கு தெரியல. Kindly go through the history better. He was not happy. அதாவது நல்ல highest position, நல்ல salary, ஒரு கேபிட்டல் ஆஃப் இந்தியாவில் அப்பாயிண்ட் பண்ணிருக்காங்க. பட் அவர் கார்ல போல, வேணான்னு சொல்லிட்டார். யூஸ் டிராவல் பை ட்ராம் கார். இப்போ கல்கட்டா போறீங்கன்னா ட்ராம் கார் ஒன்று இருக்கும். ஒரு 5-6 போகி உள்ள ரயில் பெட்டி பேர் நடு ரோட்லயே போயிட்டே இருக்கும், மெதுவா போயிட்டு இருக்கும். அதான் டிராவல் பண்ணுவார். ஆபீஸ் முடிஞ்ச உடனே அவர் வீடு திரும்புறப்போ ட்ராம் கார்ல வரப்போ he could see one sign board. என்ன சைன் போர்டு? இந்தியன் அசோசியேஷன் ஆஃப் கல்டிவேஷன் ஆஃப் சயின்ஸ். என்னதான் ஹையஸ்ட் பொசிஷன் நல்ல சேலரி வாங்கினாலும் he was not happy with that position because his passion was always towards research, towards subject. Raman's passion was for physics. அதான் முக்கியம். அந்த அளவுக்கு வெரி பிசிக்ஸ் மேன். ட்ராம் கார் வராரு, திடீர்னு சைன் போர்டு பாக்குறாரு. என்ன சைன் போர்டுனா இந்தியன் அசோசியேஷன் ஆஃப் கல்டிவேஷன் ஆஃப் சயின்ஸ். இது சைன் போர்டு, இந்தியன் அசோசியேஷன் கல்டிவேஷன் ஆஃப் சயின்ஸ். பார்த்த உடனே டெஃபினட்டா ரிசர்ச் ஆர்கனைசேஷன் தான். அந்த ஓடுகின்ற அந்த ட்ராம் கார்ல இருந்து குதிச்சு ஓடி போறான் பையன், தலப்பா கட்டிட்டு. கூட வந்து பேசஞ்சர்லாம் ஒரே ஷாக்கு. என்ன அந்த பையன் கிறுக்கு பூச்சி பூச்சா அவனுக்கு, ஓடுற ட்ராம் கார்ல வீழ்ந்தா என்ன ஆகுறது? ஓடி போயிட்டு he knocked the door. You see the photograph of that building, Indian Association of Cultivation of Science, Calcutta. அதாவது 210 Bav Bazaar, Calcutta. Knock the door. Door knock பண்ண உடனே அங்க அசுதோஷ் தே லேப் அசிஸ்டன்ட் வெளியே வந்தார். வாட் யூ வாண்ட்? ராமன் கேட்கிறார். I am a person from Deputy Accountant General, Finance Department. I got my degree B honors. Already I have published 2 papers. I want to pursue research in your organization if you provide the facilities. Idan ketadu. Immediately, this lab assistant, he took him to the Amit Lal Sarkar, president of IACS. Or the president of the Indian Association of Cultivation of Science. Indian Association of Cultivation was established by the father of Amit Lal Sarkar. I think he is a father. That is the Magendra Sarkar actually. So he got permission from his father, and the permission was given to Sir C. Raman to pursue research in the Indian Association of Cultivation of Science. அன்பு மாணவ கண்மணிகளே, ஆஃப்டர் ஆபீஸ் அவர்ஸ் 5 மணிக்கு மேல நேரா லேபுக்கு வருவார். நைட்டு 10 மணிக்கு ஒர்க் பண்ணுவார், வீட்டுக்கு போவார். பட் 7 மணிக்கு எழுந்து 4 மணிக்கு லேபுக்கு வருவார். 8 வரைக்கும் ஒர்க் பண்ணுவார். மறுபடி வீட்டுக்கு போய் டிஃபன் முடிச்சுட்டு லஞ்ச் எடுத்து நேரா ட்ராம் கேரி ஆபீஸ் போவார். ஐ திங்க் he has spent nearly 10 years, 1907 to 1917, in this Indian Association of Cultivation Science Laboratory. Outcome of the effects made by our Sir C. Raman, he got inventor Raman effect in the year 1928. So this is a history. My dear friends, Oxford University, America, சயின்ஸ் காங்கிரஸ் பண்றாங்க, ஒரு கான்ஃபரன்ஸ் மாதிரி. நீங்க கான்ஃபரன்ஸ் வந்திருக்கீங்களா? அது மாதிரி every year science conference will be organized in different places. பண்றப்போ ஜே சாம்சன் அட்டாமிக் மாடல், ரூதர்ஃபோர்ட் அட்டாமிக் மாடல், பிராக் டைஃப்ராக்ஷன் ஸ்டடீஸ். இந்த 3 எமினன்ட் சயின்டிஸ்டும் they were present the first row of the conference venue. பெரிய ஆளுங்க எல்லாமே. ஆனா ராமன் போனாரு. அவர் ராமன் எஃபெக்டுக்காக he got Nobel Prize. அதுக்கும் நான் சிம்பிளா பாருங்க, அந்த ஆடிட்டோரியத்துல லாஸ்ட் போய் உட்காந்துட்டு இருக்கார். ராமனை பார்த்த ஜே தாம்சன், ரூதர்ஃபோர்ட், வில்லியம் பிராக் 3 பேர் ஒன்னா எழுந்து போயிட்டு ராமனை கை பிடிச்சி அழைச்சிட்டு ஃப்ரண்ட் ரோல தன் பக்கத்திலே அமர வச்சாங்க. ராமன் எமர்ஜ்டு ஆஸ் ட்ரூ இன்டர்நேஷனல் ஃபிகர். அதான் நீங்க கான்ட்ரிபியூஷன் நல்லா பண்ணீங்கன்னா எந்த எதிர்ப்பு வந்தாலும் நீங்க உலக அளவில் பெருமைப்படுத்தப்படுவீர்கள். இதோட எவிடன்ஸ் இருக்க. You got so many awards, நிறைய awards. Fellow of Royal Society in the year 1924. Knighthood of British Government 1929. Hughes Medal for Royal Society 1930. Nobel Prize 1930. Franklin Medal 1942. International Lenin Peace Prize for the Soviet Union. Government has appointed him as a national professor. ஒரு டிபார்ட்மெண்ட்ல ஒரு காலேஜ்ல ப்ரொஃபசர் கேட்டவங்க இவ்வளவு கஷ்டப்படுறோம் பாருங்க. கவர்மெண்ட் ஆஃப் இந்தியா has appointed him as national professor 1948 after independence. Government has decorated him with the Bharat Ratna highest position, highest award 1954. He was venerated as father of Indian science. இதை விட பெருமை யாருக்கு கிடைக்கும்? நினைச்சு பாருங்க. நீங்களா எங்க ஜெனரேஷன்? ராமன் திருச்சியில பிறந்தவர், திருவானைக்கா சொந்த ஊர், தமிழ்நாடு தான், மதராஸ் ஸ்டேட் தான். அந்த டைம்ல எந்த அளவுக்கு முன்னேறிக்கா பாருங்க. உலக அளவில் பெரிய சயின்டிஸ்ட். சயின்ஸ் வாஸ் இஸ் ஃபர்ஸ்ட் லவ். யார் சொன்னதுங்க? அவங்க மனைவி சொல்றாங்க, லோக சுந்தரி. அதாவது என்னன்னா, அவர் குடியிருந்தது சென்னையில சென்னையில இருக்கு இல்லையா, பாசாரதி கோயில் இருக்கு பாருங்க, திருவள்ளிக்கேணி, அங்கதான் வீடு. அவர் அப்படியே மார்னிங் போயிட்டு இருக்கிறப்போ ஒரு வீட்டுல இருந்து ஒரு சத்தம் கேக்குது, மியூசிக் கேக்குது. லோக சுந்தரிய ஒரு பெண்ணு ராம நீ சமானம் எவரு என்ற கீர்த்தனையை பாடிருக்காங்க. ராமா உனக்கு இணை யார், அதான் மீனிங். ராமா நீ சமானம் எவரு என்ற கீர்த்தனை வீணை மூலமா பாடிட்டு வாசிட்டு இருக்கிறாங்க. அது என்ன மீனிங்னா, ராமா உனக்கு இணை யாரு. அதாவது சசி ராமன் பார்த்தேன் எதிரி இல்லையா, பப்ளிஷ் பண்ண பேப்பர்ல மியூசிக்ஸ்ல பண்ணியிருக்காரு அவர். அந்த பாட்டு கேட்ட உடனே வித்தவுட் ஹேவிங் எனி பெர்மிஷன் நேரா வீட்டுல போயிட்டார். தப்பு இல்லது, அந்த அளவுக்கு ஈர்ப்பு மியூசிக் மேல. வீட்டு என்டர் ஆயிட்டார் நேரா. என்கிற தியாகராஜன் கீர்த்தனையை பாட பறி போனது ராமனின் மனம். அது கிட்ட போய் நிக்கிறாரு, அந்த அம்மா வாசிக்கிறாங்க, இவர் அந்த பொண்ணை பாக்குறாரு. சோ ராம நீ சமானம் எவருன்னு சொன்ன உடனே ராமா உனக்கு இணை யார், அதான் மீனிங். என்கிற தியாகராஜரின் கீர்த்தனை பாட ராமனின் மனம் பறி போனது, அந்த அம்மா மேல காதல் வந்தது. இதுதான் ஒரு சயின்டிஸ்ட் இருந்தாலும் அந்த லவ்ன்றது பாருங்க, மியூசிக்கால லவ் அஃபேர் வந்தது பாருங்க, எந்த அளவுக்கு நல்லா இருக்கு பாருங்க. உடனே என்ன ஒரு பிரச்சனை, அந்த டைம்ல ராமனுக்கு அலைன்ஸ் பார்த்துட்டு இருக்காங்க கல்யாணத்துக்கு பேரண்ட்ஸ். எப்படி சொல்றது, நல்லா பிசி வாசிக்கிற பொண்ணு, நல்ல குரல் இருக்கு, பிடிச்சு போச்சு, லோகசுந்தரி தான் கல்யாணம் பண்ணணும்னு ஆசைப்படுறாரு. Then he expressed his opinion through Marxist communist leader, freedom fighter, Peterent Uncle's son. ஏன்னா அவங்க சொன்னா அப்பா அம்மா கேட்பாங்க. அவங்க Peterent Uncle's son மூலமா வியூ சொல்லி ஃபைனலி ஒத்துட்டாங்க. இது அரேஞ்ச் லவ் மேரேஜ், ஆக்சுவலி அரேஞ்ச் லவ் மேரேஜ். புரியுதுங்களா? ஸோ அந்த அம்மா சொன்னா தெரியுங்களா? குழந்தம்மா சொன்ன லைஃப் ஹிஸ்டரி படிச்சு பாருங்க தெரியும். ராமனுக்கும் எனக்கும் 2 மகன்கள் இருக்கிறாங்க. அதுவே அதிசயமா நான் ஃபீல் பண்றேன். ஏன்னா இஸ் ஃபர்ஸ்ட் லவ் வாஸ் ஒன்லி ரிசர்ச் பிசிக்ஸ் தான். அப்படி இருந்தும் எங்களுக்கு 2 சன்ஸ் இருக்காங்க. அது ரொம்ப அதிசயமான விஷயம். அந்த அளவுக்கு ஒரு ஸ்டேட்மெண்ட். மை டியர் யங் பட்டிங் டைம் இஸ் அப் ஆல்ரெடி. ஐ வில் டேக் அனதர் ஒரு 5 minutes or 6 minutes முடிச்சிடுறேன். He was invited by Osmania University, Hyderabad in the year 1967. During the celebration of the Golden Jubilee, as a chief guest of honor, he delivered a talk. என்ன talk? Scattering of light by diamond. அவர் நோபல் பிரைஸ் கிடைச்ச உடனே he has received number of gifts and moments all over the world. ஏறக்குறைய 600க்கும் மேற்பட்ட டைமண்ட் வெரைட்டி அவர் கிஃப்டா வருது. ஒரு டைமண்ட் பீஸ் கூட அவர் வீட்டுக்கு எடுத்து போகவே இல்லை. அதான் உண்மை. பட் இருந்தாலும் எல்லா டைமண்ட் வெரைட்டியும் 600 டைமண்ட் வெரைட்டியும் இந்தியன் அசோசியேஷன் ஆஃப் கல்டிவேஷன் சயின்ஸ் இருக்கிற ஒரு மியூசியத்துல டிஸ்பிளே பண்ணியிருக்காரு. இப்போ போனா பாருங்க. இப்படி கல்கட்டா போற மாதிரி இருந்தா கைண்ட்லி விசிட் இந்தியன் அசோசியேஷன் ஆஃப் கல்டிவேஷன் ஆஃப் சயின்ஸ் கேம்பஸ் and a visit to museum, Raman Museum, and we can see all the diamond varieties. இந்த 600 டைமண்ட்ஸுக்கும் he recorded Raman spectrum வச்சு he delivered a talk for about 1 hour. ஒரு பையன் கேட்கறான், ஒரு ரிசர்ச் ஸ்காலர், ஐயா நீங்க கொடுத்த 1 hour டாக் ராமன் ஸ்பெக்ட்ராஸ்கோபி, ராமன் ஸ்கேட்டரிங் ஆஃப் டைமண்ட், நீங்க 1 hour கொடுத்துருக்கீங்க, மோர் இன்ஃபார்மேட்டிவ், ரொம்ப யூஸ்ஃபுல்லா இருக்கு. என்ன ஒரு குறைன்னா, you have given very good idea how to study the Raman scattering on diamonds, how to study the structure of diamond using Raman spectroscopy, but you have not given how to make the diamond. Raman diamond ஸ்டடி பண்றதுக்கு ஐடியா கொடுத்துட்டீங்க, ஆனா டைமண்டை உருவாக்குறதுக்கு ஐடியா தரலன்னு கேட்கறான் பையன். ஒரு கேள்வி ஒரு மாதிரியா இருந்தது. ராமன் replied immediately, தம்பி, to make the diamond is very simple. ஏன்னா you come with a small coal, சில கரிக்கட்டை கொண்டு வா, 1000 அடி ஆழம் தோண்டி பூமியில புதைச்சு வை, come and see after 1000 years you will get diamond. This is science. See பாருங்க, அதாவது forgive a child who is afraid of light. The real tragedy is when men are afraid of light. நான் சர்சிராமனை பெருமைப்படுத்த வேண்டி என்னால் கொடுக்கப்பட்ட ஒரு கொட்டேஷன் தான். Quotation coined by Indian Spectrophysics Association. Forgive a child who is afraid of the darkness, but the real tragedy is when men are afraid of light. But for Sarsivi-Raman, he is afraid of light. He is not afraid of light because light is his source. Light is his banner. Light is his symbol. That's why with scattering of light by the materials, he did an extensive research work in the field of spectroscopy. My dear friends, on 10th December 1930, Raman went to Sweden. அந்த டைம்ல நோபல் பிரைஸ் வாங்குறதுக்கு எங்க போனோம்? ஸ்வீடன் போனோம். அங்கதான் அந்த கண்ட்ரிக்கு போனோம். You have to receive the Nobel Prize from Sweden's then king Carl Gustaf. அப்போ நோபல் பிரைஸ் வாங்குறப்போ அவர் தலை மேல ஒரு தேசிய கொடி பறக்குது, தேசிய கீதம் பாடுறாங்க. அப்போ ஒரு கண் கலங்குது. ஏன் கண்கள் தெரியுங்களா? பறந்தது நம்ம தேசிய கொடி அல்ல, தமிழ்நாடு நம்ம இந்திய தேசிய கொடி அல்ல, யூனியன் ஜாக் பிளாக். பாடப்பட்டது நம்ம இந்திய ஜனகன அல்ல, பாடப்பட்டது அந்த இங்கிலாந்தின் காட் சேவ் த கிங் என்ற தேசிய கீதம். அப்போதான் கண்ணில் தண்ணி வருறார். நமது பாவப்பட்ட இந்தியாவுக்கு ஒரு தேசிய கீதம் இல்லையே, நம்ம பாவப்பட்ட இந்தியாவுக்கு ஒரு தேசிய கொடி இல்லையே என்ற ஒரு நாட்டுப்பற்று பாருங்க. நாட்டுப்பற்று என்னதான் சயின்டிஸ்ட் இருந்தாலும் நாட்டுப்பற்று பாருங்க. ரவீந்திரநாத் தாகூர் இலக்கியத்திற்காக அவர் நூல் பரிசு கொடுக்கப்பட்டது கல்கட்டாவில். பாராட்டு விழா நடத்துறாங்க. எல்லா விஐபியும் பாராட்டு விழா போறதுக்கு போறாங்க. எல்லாமே போறவங்கலாம் வந்து அந்த என்ட்ரன்ஸ் ரிசப்ஷன்ல கையெழுத்து போட்டு போறாங்க. எல்லாமே they offered their signature in English except Sir C.V. ராமன். எல்லாம் போட்டா தெரியுங்களா? தமிழ் தான் போட்டு போனார். சர் சி வி ராமன் தமிழ் தான் போட்டு போனார். மொழிப்பற்று. எதுக்காக சொல்றேன்னா, மை டியர் ஃப்ரெண்ட்ஸ், மொழிப்பற்று முக்கியம். நாட்டுப்பற்று, மொழிப்பற்று. He was conducting an interview for selection of the project fellow. IIC பெங்களூர்ல. He was the director of the IIC பெங்களூர். பையன் வந்து உட்கார்றான். கேள்வி கேட்கிறார் சர் சி ராமன். ஒரு கேள்வி கூட ப்ராப்பரா பதில் சொல்ல அந்த பையன். He said, you are not appointed. பையன் ஏமாற்றமா வந்த வேலை கிடைக்கலன்னு திரும்பி எழுந்து போறான். எழுந்து போகும்போது அந்த ரூம்ல கார்பெட்ல கீழே ஒரு குண்டூசி இருக்கு. அந்த குண்டூசி எடுத்து பக்கத்துல இருக்க ஜன்னல்ல வச்சுட்டு தென் போறான் பையன். ராமன் noticed his activity, my dear students. பையன் கூப்பிடுறான், தம்பி இங்க வா, you are appointed. I can teach you the subject, but I cannot teach you the responsibility. உங்களுக்கு சப்ஜெக்ட் தெரியல நான் உங்களுக்கு டீச் பண்ணிடுவேன், அது பிரச்சனை இல்லை எனக்கு. ஆனா பொறுப்புணர்ச்சி நான் டீச் பண்ணாதான் முடியும் சொல்ல முடியாது. ஸோ இருக்கிற குண்டூசி எடுத்து மேலே வச்சுட்டு போற பாருங்க. வந்த வேலை கிடைக்கலன்னு ஏமாற்றமா இருந்தாலும் தட் இஸ் த ரெஸ்பான்சிபிலிட்டி. ஸோ பொறுப்புணர்ச்சிக்கு முக்கியம் கொடுத்த நமது சர் சி வி ராமன். Therefore, my dear friends, you see, last slide பாருங்க. இதே ராஜாஜி, then former CM of our Madras state, பெரியாள் ராஜாஜி. He was doing law காலேஜ் லா படிச்சுட்டு இருக்காரு. அப்ப சுவாமி விவேகானந்தா வர்றார் அந்த லா காலேஜுக்கு. ஒரு கொஸ்டின் கேட்கிறார். அந்த சின்ன பையனை பார்த்தா, சின்ன பையனா இருக்கிறார். யாரு? ராஜகோபாலாச்சாரி. தம்பி, இந்த வானமும் கடலும் ஏன் நீளமா இருக்குன்னு கேட்கிறார். அவர் சொல்றாரு, பதில் சொல்றாரு பாருங்க. வானமும் கடலும் நீளமாக இருப்பதற்கு காரணம் கண்ணபுரான் உடல் நீளமா இருப்பதுதான். இது இறைஞானம். அதே கடலும் வானம் நீளமா இருப்பதற்கு காரணம் தெரியுங்களா? ராமன் சொன்ன சயின்டிபிக் இன்வென்ஷன் பாருங்க. ஸ்கேட்டரிங் ஆஃப் லைட் பை வாட்டர் மாலிகூல்ஸ் அண்ட் மாலிகூல்ஸ் ஆஃப் த கேசியஸ் ஸ்டேட் இன் த அட்மாஸ்பியர். இது விஞ்ஞானம். ராஜாஜி சொன்னது இறைஞானம், ராமன் சொன்னது விஞ்ஞானம். ஸோ விஞ்ஞானத்தையே நம்ம சமயமாக கருதின மெம்பர் தான் வந்து சர் சி வி ராமன். Therefore, born on 7th November 1888, died on 21st November 1970. 82 வருஷம் அழகாக நம்ம சர்வீஸ் பண்ணியிருக்காரு. He was cremated on the grounds of Raman Institute on his request. Therefore, அன்பு மாணவ கண்மணிகளே, பிரெயின் மேனேஜ்மெண்ட் உள்ள நம்ம சர் சி வி ராமன், டைம் மேனேஜ்மெண்ட் உள்ள நம்ம சர் சி வி ராமன், ஹியூமன் ரிசோர்ஸ் மேனேஜ்மெண்ட் உள்ளடக்கிய நம்ம சர் சி வி ராமன், பொறுப்புணர்ச்சிக்கு முக்கியம் கொடுத்த சர் சி வி ராமன், விஞ்ஞானத்தை தம் மதமாக ஏற்றுக்கொண்ட சர் சி வி ராமன், நாட்டு பற்றுமிக்க சர் சி வி ராமன், தமிழ் மொழி பற்றுமிக்க சர் சி வி ராமன். அவர் பெயரில் ஒரு பல்கலைக்கழகம் அவர் பிறந்த தமிழ் மண்ணில் இல்லையே என்ற பெருங்குறை நம்மிடம் இருக்கதான் செய்கிறது. காலம் பதில் சொல்லட்டும். வாழ்க ராமனின் புகழ், வாழ்க ராமன் எஃபெக்ட் பயணம். ஸோ நன்றி, வணக்கம். தேங்க்யூ டாக்டர் அரவி செல்வி அண்ட் டாக்டர் சுரேஷ்.
Excellent talk, sir.
Oh, sir, thank you, sir. Thank you, sir.
As long as I'm very, very much interested to listen to your talks.
Thank you, sir. Thank you, sir.
Every time I get inspired.
Thank you, sir. Thank you,
So
sir.
I cannot constitute a Raman research lab in Tamil Nadu.
Oh, sir, sir.
But we can think of and remember Raman forever.
Oh, sir. Thank you, sir. Thank you, sir.
People see
Yes, sir.
Nowadays, the politicians has come forward to construct any research lab,
Yeah, yes, sir.
and
Yes,
they
sir.
are making
Correct.
privatization. That's all.
Yeah, yes, sir. Yes, sir. Correct, sir. So thanks a lot, sir, for your appreciation. And
No,
I need
sir.
your blessings always, sir.
No.
Oh,
I am
sir, sir.
younger to you, but
Oh,
I
sir,
love
sir.
to listen your talks
Oh, sir, sir. Thank
and
you.
love to participate your conferences.
Oh, sir, sir.
And every day I am getting some boon from your
Oh, sir.
talks.
Thank you, sir. Thank you, sir. And in
Your
continuation of, yes, sir.
your dedication or interest definitely will fetch something
Yes,
good
sir.
for the society.
Okay, thank you, sir. Definitely, sir. Thank you, sir. And with the continuation of this conference, sir,
Yeah.
let us think about our commemoration of our Porchian.
No, that is June 6th. That is automatically it is there. June 6th.
Okay, sir.
June
Thank you,
6th
sir.
we are going to have it. No doubt
Yes.
about it.
Okay, sir. Thank you, sir.
Thank you, sir, for your excellent speech.
Oh, thank you, madam. Thank you, madam. Thank you.
Hello, sir. It is really very inspiring, and then really enjoyed. So after it really make me motivate. I think
Okay,
really inspiring talk, sir. Really
Sir,
great.
Reddy sir is interact with you, sir.
Oh, ready. Okay, sir. Thank you, Professor Reddy, sir.
Thank you very much, sir. Really great. And in fact, it
Yes,
was I use the Raman.
Yeah.
Very fancy Raman instrument. I think really inspiring your talk, and they're really great, sir. Really great. Again, really great.
Thank you, sir. Thank you, sir. Thank you.
And
Thank you.
really, you're a motivational speaker. I think that is very important. Talk
Yeah.
like
Yes, sir.
Yeah,
That's
thank you very
why
much.
Dr. Arvichelli, convener of the conference, he requested me to give this kind of talk to motivate the younger generation.
Yeah.
Towards
Really,
research,
really
but that's
great.
why, sir. Yes, sir.
Yeah, thank you very much, sir. Maybe
Sir.
I'll see that if any
Sir.
physics conference, I'll tell to Karnataka also some places we want it like.
Okay, sir.
motivate.
Thank you, sir. Definitely, sir. Definitely. Thank you, sir. Thank you.
Okay, sir. Thank you very much, sir. Thank you. Thank
Okay,
you
sir.
very
Wish
much.
all
Not only
success, sir.
Madam Aruselvi, we are all inviting you to give such type of talks. We
Okay.
join with her to please deliver such talks.
Yes, sir.
At least one should ignite his mind and he will carry forward our scientific challenges for the future of the country.
Okay, sir. Definitely, sir.
Sir, I am Kalainathan.
Oh, Taganathan. My student.
Sir, Jaishankar sir, good morning.
Good
Good morning, sir. Vanakkam, sir.
Kalinathan, VAT, sir. VAT.
Thank you very much, sir, for the highly interesting. So it will be highly useful for the young buds, sir.
Yes, sir. Thank you.
Undergraduate, the present research scholars, it will be highly useful, sir.
Yeah, nice.
Thank you.
Professor Jaishankar, Professor Reddy, sir.
Thank you.
And Dr. Kalinathan is my beloved student at Pachapas College.
Oh, it is
He did my
really great,
MSc.
sir.
He did my MSc project under my guidance. The MSc project is published in a journal that time.
Great,
Sir, we can smell you all over the world, not only from VIT or Pachappa College. We are able to smell all over the world forever.
Thank you, sir.
Very good.
Really very nice, really inspiring.
Thank you.
By listening your talk, I became your student.
Yes, sir.
I love to listen to your talks in future. In fact, Kalainathan also, thank you very much, sir. In fact, I used to come to VIT for some time.
Okay. Thank you. Most welcome, sir. Most welcome.
Thank you very much, sir. Thank you very much, sir.
Thank you. All the best. Thank you, sir. Thank you.
Yeah. Are you Chelvi?
Sir, small
sharing
introduction about you, sir. Small introduction about you.
Yes. That sharing is provided to me.
Yes, sir. Definitely.
Give permission to share. Yeah. So that I can start.
Oh, screenshot. Sir, approved, sir.
Can you see my slide?
Yes, sir. Shared, sir. It is visible, sir.
Is it moving?
It is moving. Yes, sir.
Okay, then it's fine. You can start.
Sir, please, sir.
Yeah.
Sir, kindly wait.
Yeah. Okay.
Dear research scholars and the participants, the second day oral presentation is going to start shortly. The participants, those who are registered for the oral presentation, are asked to join separate link Google platform, which was intimated to you already at 10:45. So kindly request you to join the Google Meet link at once. Thank you. Now we are going to start our second session. Music is the arithmetic of sounds, as optics is the geometry of light. Here with us we have a most valuable personality, the most respected Honorable Professor Dr. S. Kalainathan sir from VIT University Vellore is going to discuss about growth and characterization of NLO crystals grown by solution. Now I ask our Assistant Professor Dr. S. Gaurisan sir to give intro about our eminent professor. Thank you.
Good morning to all. First of all, I convey my heartfelt thanks to organizing committee for giving this opportunity to introduce this session. The resource person, Dr. S. Kalinathan sir. Good morning, sir. He is working as assistant senior professor, Center for Nanotechnology Research in VIT University of Vellore. It is a right time and a right Good morning to all. First of all, I convey my heartfelt thanks to organizing committee for giving this opportunity to introduce this session. The resource person, Dr. S. Kalinathan sir. Good morning, sir. He is working as senior professor, Center for Nanotechnology Research in VIT University of Vellore. It is a right time and a right place to share one information among the participants. Myself and our HOD, Dr. R. IVCPEMM, belongs to SARS research family in VIT University of Vellore. Dr. S. Kalinathan sir has been completed BSc Physics in Madras University and followed by MSc Physics completed in Madras University in the year of 1986. He got the PhD degree awarded from the Anna University in the year of 1992. He is very much interested in the domain of growth of crystal by bridgement technique, low temperature solution growth, gel growth technique, nanomaterial, laser short peening, magnetic and solar cell thin films. He is a membership of Indian Association for Crystal Growth. Dr. S. Kalinathan sir has been published 490 journals with high impact factor. It is a great achievement. It contains 275 international journals and 215 conference papers. Professor S. Kalinathan sir got a number of Indian government funded projects. They are listed by DRDO 4 project, DST 5 project, IG Corp 1 project, CSR 1 project, DAE 1 project, BRNS 1 project. The total budget of project is around 4 crores in INR. Totally 24 PhD scholars got awarded by the under the guidance of Dr. S. Kalinathan sir. He went for visiting professor in the year of 2014 and 2017, 2018, 2019 in Akita University, Japan, and honorary visiting professor in the year of 2017, Australian National University, Canberra, Australia. He got the invitation fellowship in the year of 2015 from the University of Tokyo in Japan. He got the award of Professor R. Ramasamy National Award for Crystal Growth for the year of 2009 by Indian Association for Crystal Growth. Dr. S. Kalinathan sir got the Most Active Researcher Award by VIT University for the year of 2008. In 1997, he got the Best Teacher Award by VIT University Vellore. He visited the number of foreign countries such as Japan, USA, London for the purpose of conference and symposium. Thank you, sir.
Good morning to all.
Now I invite
At the outset,
S. Kalinathan
I thank
sir,
the.
VIT University Vellore, to deliver his speech.
Okay. So good morning to all. At the outside, I thank the introducer for my nice introduction. It's my pleasure to thank Dr. Arivu Chelvi, head, that is a convener, Department of Physics, Sri Vidya Mandir Arts and Science College, to deliver an invited talk in the International Virtual Conference on Physics of Emerging Materials and Molecules, organized in collaboration with Indian Spectrophysics Association. I have the proud to thank my guru, Dr. S. Gunasekaran, President of ISFA. He is highly sincere and dedicated researcher. I feel happy to present my talk in the presence of my friend, Dr. Jaisankar also. In this occasion, I thank all the organizing committee members and this management of Sri Vidya Mandir Arts and Science College. Okay. The previous talk was given by my guru, yes, Dr. Gunasekaran sir. He elaborately gave the biography of Sir C.V. Raman. I think that will be highly useful for the new, that is a young researchers. That research, it should not be based, it should come based on their own interest. It should not come artificially or through some force. So if it is the case, you can't concentrate on research properly. So Sir has explained about Sir C.V. Raman's life also. While he was so young itself, he came out with good results. So that one, it was not motivated by anyone, based on his own interest. If you want to do a good research, please concentrate on your research. So your motivation, that is a ending point, it should be a good point. That is the most important one. Okay. Before I give my, so today I am going to give a lecture on growth and characterization of non-linear optical crystals grown by solution growth method. Before I give my talk, I acknowledge all my research students who have completed the research under my guidance. Here you can see that so far 25 students are completed. The last student Arun Kumar's report has come. Just we are waiting for the Viva. Mostly next week that Viva also will be conducted. So without their contribution, it is not at all possible to give some of my students' contribution. So here, this slide, it focus on various fields where I am concentrating. The first here you can see that introduction, that is that's a non-linear optical materials. Okay, so initially I started my research career in this field of non-linear optical materials. That is a slow evaporation technique. Then I moved to this gel growth technique. Now we are working on bridgement technique also to grow the non-linear optical crystals. Then this optical floating zone technique. This optical floating zone technique, many oxide crystals related with this laser application we have grown here. Then this bridgement technique, if you take under this one, we have grown this cesium iodide thallium activated crystal. That is that main application was for the fabrication of gamma ray detector. The next one, that is here biological crystals and bio nano crystals. Biological crystals, that's related with this urinary stone. In this gel medium, how it is possible to control the nucleation of the urinary stones. Okay, that one we have studied. And this bio nano materials, if you take, if you want to replace our teeth or bone, some that is a hydroxyapatite material in the nano form, it is required. For that purpose, we have done that work. Then this flux growth we have grown, that's a PM and PT crystal for this underwater sensor work. Then that laser shock peening process also we are working. So laser shock peening work there, we are working on surface modification work. that is also a very, very important one. It has lot of application in this aeronautical and automobile and this medical field. Apart from that, that is nuclear reactors also. Based on this process, it is possible to increase the corrosion resistance, fatigue, and this mechanical property. So these are these various fields we are focusing. But now today I am going to concentrate on this one, that is a slow evaporation technique, that is by for this nonlinear optical crystals. Before I enter into my talk, the various crystal growth processes, if you take broadly, that can be classified into, that is a melt growth, gel growth, solution growth, vapor. In general, if you see all the materials available in the world, if you take, that will be only three forms, that is solid, liquid, and gas. So all the three methods, it is possible to grow the crystal. For example, if you take that vapor, that is for this gas. That's a solution here we can see. It's a melt here if you see from the solid to solid. So methods are available. Okay. So in this melt growth itself, if you take, it is here, that can be classified, that is a with crucible and this without crucible. Even with crucible itself, there are many methods, that is a Bridgman, Chakralsky, and Chiropoulos. So here we have the facilities to grow the crystals by Bridgman also. In the case of without crucible, here that is a zone melting and this vernal. During the presentation of that is Dr. S.G. sir, he focused more importance on the diamond also. Artificial, see, he gave a technique that is naturally how to grow the diamond crystal. Suppose it must be grown by artificial, then we have to go for vernal. So it based on this vernal, it is possible to grow the artificial diamonds. Then this gel growth, that is a single diffusion and a double diffusion. Both the techniques we have used to grow the urinary stones. Next one, that is a solution growth. In the case of solution growth, that is a low temperature and high temperature. So high temperature we have not tried. In this case of low temperature, that is a slow cooling, temperature gradient, and slow evaporation. Okay, these are the techniques. Here we use that's a slow cooling technique. So vapor, there are two techniques, that is a physical vapor deposition and a chemical vapor deposition. So these are this general area of this crystal growth. Here in my present, I am going to talk about that slow cooling technique. Okay. So based on this technique only, we have grown the crystals. Why we want to study or concentrate on the field crystal growth? Based on the importance of the crystals, that is first one, that is based on the importance. We can say that is these pillars of modern technology. For any engineering side, if you concentrate, for any electronic devices also, there, yeah, the important part will be from the crystal growth technique only. Otherwise, that is not at all possible. That is this work horses that drive optoelectronic devices of present photonic era. Okay. So all the electronic devices, if you take, that is a silicon, indium phosphide, gallium arsenide, whatever the materials, even if you want to make a diode or transistor, there, without this material, it is not at all possible. So we have to concentrate on how to prepare that material. Okay. So based on that only, it is possible, the final device quality will be there. Even in the case of fiber optic communication system. So everywhere nowadays that metal cables are replaced with this fiber based on its efficiency and commercial side also. For the source side and this detector side, okay, both the case. So without the crystal growth technique, it is not at all possible to improve the improve that fiber optic communication system. Or the source also, it's a kind of crystal. Okay, crystal it will be there. For the detector side also it will be. Then this why that is nowadays we are focusing on this nanomaterial, polycrystal materials also available. That is, so we have to grow defectless crystal. Okay, flawless crystals are very essential, and that homogeneity. So we have to reduce these inhomogeneities while we are growing the crystal. See, inhomogeneous or defects, what property or now we can concentrate on that is ultimate one. Ultimate one, if you take, that is single crystal. The single crystal, whatever we are getting, the property is the maximum property or efficiency for this particular material. But once you go for the polycrystalline, amorphous or nanomaterial, easily we can prepare the crystal, but efficiency that will be less. Here we can see some of the applications of the crystals at the that is a transistor, tunnel diode, single diodes, laser, filters and oscillators, radiation detectors, and this ultrasonic amplifier, industrial bearings, cutting and abrasive. There we are using that's a diamond and a sapphire rectifiers, laser modulators, harmonic generators. Okay, so various crystals here we can see, that is the silicon, germanium, gallium arsenide, indium arsenide, york crystal, potassium chloride, sodium iodide, like this. Okay, the n number of crystals are there. So based on the application, the first point, okay, why we want to concentrate on the crystal means based on its application. The next one, why we want to concentrate more means the quality of the crystal also, it must be improved. Okay, even today I have grown one crystal means that there will be some possibility to increase the quality. Okay, defectless crystal, it must be grown. Okay, so for that the crystal growth technique or the research on this field, it is very important one. I already told you in my first slide itself. So I am going to focus on solution growth. The solution growth is mostly we will be using water as a solvent. Okay, so even water normally, otherwise some of this methanol, ethanol, other solvent also going to be used. While we are using that one, that solubility of the solution from which the crystal is going to be grown. So that one is very important factor. For that one, if we want to grow a big size crystal, metastable zone, okay, with metastable zone width, it is very important one. Without that, it is not at all possible to end up with a bulk size crystal. Okay, here we can see the three regions. Okay, here this is a concentration versus temperature. This one here, it is the first region, second one, third one. Third one is called label. The second one is called metastable. It is this first one is called stable. Stable, metastable, and this label. It's a stable is undersaturated solution. For example, if you take a, that is a water 100 ml, you take it. Let me take that is a sugar is going to be dissolved there. There is some limit to dissolve that sugar in this water. Let me take that is a 30 gram. 30 gram is sufficient. After that, it is not at all possible to dissolve in the 100 ml of water. Let me consider. Now, here in the stable state is less than 30 gram. Let me take here, we have that is here 27 gram. 27 gram of sugar is added here. Okay, that is the situation. Now, this position here, if you take, it is more than 30. More than 30, you can also able to more than now that 30 gram also for a particular temperature. Let me take 35 degree. 35 degree, 30 gram. Okay, here it is less than that one. Now you add 32 gram and raise the temperature. So instead of 35 degree, you raise it to 45 degree. In that case, there that 45, suppose if you are going to increase the temperature to 40 degree, 40 degree, it's that is a solid content, that's a sugar content also will be increased. So more than 32 also it will be there. Later you can reduce this temperature. In this case, we can get this super saturation condition. It is a super saturation condition. It is under saturation. This one is this saturated condition. Okay, this one is this saturated condition. Now if you here before you are going to grow the crystal, initially a seed crystal based on the fast evaporation, we have to get a seed crystal. By inserting that seed crystal into the prepared solution, it is possible to get a bulk size crystal. Now let me consider in this position. In this position, we are going to insert a seed crystal. If you insert the seed crystal, already it is undersaturated. Once you insert the crystal, means automatically that will be dissolved. You can't get a crystal. Okay, at level it is a highly, that is a more than the required solute, that chemical whatever the case, it is added in the solution, in that in this solvent. So in this case, whether we are going to add the seed crystal, automatically the multi nucleation will be formed at the bottom of the beaker here. Now what is this metastable? This position, unless you add seed crystal, there will not be any growth. So this position only, it is going to be selected to grow a bulk size crystal. At the same time, the range of temperature also that can be calculated. Based on this one, it is possible to select the range of temperature based on the temperature. So this process itself, that is a slow cooling technique. In that case, while you are reducing the temperature, that the multinucleation or that is a precipitation of the chemicals at the bottom of the beaker, we can't get it. Mostly if it is within a solvent, if it is a 100 gram of chemicals are added, means you can end up with at least 70% or 80%. Okay, you can get a bulk size crystal. So in this case, that metastable zone width is very, very important property. Based on that only, it is possible to grow a bulk size crystal in the case of solution growth technique. So he is the father of this nonlinear optical property, that is Peter Franken. So he has invented this nonlinear property in 1961. Okay, that second harmonic generation property based on a quartz crystal he has invented using this ruby laser. Here, this experimental arrangement also here we can see. Now, if you see here, there is a ruby laser is there. That wavelength for this ruby laser is 6,943 angstrom unit. Later here, he has used one focusing lens. That quartz crystal is, that is fixed here. It is a NLO crystal. After that, here, that is a prism and collimating lenses are fixed here. Then here he has used a photographic plate. So here the incident radiation's wavelength is this one, that is a 6,943. It is allowed to fall. Finally, we are getting this one. There is no problem. It is coming. But here in this experiment, he has identified this one more wavelength, that is 3,471.5. Here, if you calculate, that's a 6,943 divided by 2, we can get this one. Okay, one more wavelength. So this property only we can say that is a second harmonic generation. Okay, second harmonic generation. The next, what is this NLO, non-linear optical property? If you take a non-linear optical crystal, you pass the light radiations of low intensity. If you measure this output radiation, in this output radiation also there will not be any change. Whatever we have given that inlet, that is a input radiation, the same thing we can get it. But once we increase the intensity of the incident radiation like laser beam, in that case only it is going to affect the property of the material. There only we can get two radiations. One is corresponding to this incident, the another one is half of its wavelength. So that's in the case of linear. So linear, there is no change. Let me consider that is a low light intensity is subjected on this material. The same thing we can get it as this output. NLO material we can get this different wavelength. Okay, different wavelength. That example also we can see that is a KDP, ADP. Like there are many crystals in Tamil Nadu itself. If you see, there are many scientists, many researchers working on this material. That here, one example we can take. Let me take a string. For that, we are going to give you a force, stretch it. Stretch it. Here, that's a force. F is given to the string. X is this movement along this direction. Let me take along the X direction. Here, K is this spring constant. Once you are going to stretch till at certain limit of or that force which are subjected on the string, that will be directly proportional. That stretching of the string and the force, that will be directly proportional. Once some limit is crossed, after then the force whatever it is subjected, it will not be directly proportional. That one here we can see that equation here. That is here we can take that is a k prime, k double primes or order of constants and are much smaller than the constant k. But these are the factors it is going to affect the or giving the way for this second harmonic generation. This is the other example also we can take, that is this Hooke's law for this second harmonic generation. So what is happening in this NLO process? If you take once a high intensity radiation is subjected on this material, means initially it is going, that radiation is going to interact with this material, that is the crystal you can take, or the atoms or molecules which are present within this material. So it is going to induce for the formation of this dipole. After that, it will set it to oscillate. When at the same time, once the dipole is formed, means there will be polarization formation within the crystal. So whenever we are passing the intensity of, that is a low intensity radiation, let me take the intensity of the radiation as E. So if it is a low intensity is subjected on the crystal, means the polarization that will be directly proportional only. If the intensity is high, at the same time the field intensity whatever it is subjected by the through the light radiation, it should be comparable with the interatomic or intermolecular intensity. Once it is comparable, means during the case only it is possible to get the polarization. Okay, so high macroscopic polarization we can get it. So through that it is possible to get this second harmonic generation. The non-linear optical crystals that can be classified broadly, that is active NLO material and this passive NLO materials. Now we can ask the question, what is active and what is passive? The passive is the one whenever we are going to pass the laser radiation on this material, we can get the second harmonic generation. Based on the second harmonic generation, it is not possible to analyze the property of the crystal. So the property of the crystal is not included in this output radiation. So that kind of material, we can say that is passive materials. Okay, there we can get this harmonic, that's a second harmonic generation, frequency mixing, optical reflection, etc. Okay, then if the property also, if it is imposed in this output radiation, from that it is possible to get the characteristics of the crystal. That one we can say that is this active material. Here we can say that the example, that is your two photon absorption, stimulated Raman, religence, brilliant scattering. These are the some of these examples for this. That is a active NLO materials. And this is one of these important applications of these NLO materials. Here, once the laser radiation is subjected on this NLO crystal, what are the frequencies it is possible? Let me take the incident is omega 1. So omega 1, the second harmonic generation, if you take, that's a omega 2, another, that's half of the one. That also omega 2 we can get it, and that's a doubled of that one, that is the incident radiation, that is there 2 omega 1 possible. Similarly, for this half of the one, that is the second harmonic generation, that is the omega 2, that also it is possible to get it 2 omega 2. Then the combination and this difference of the two wavelengths. So these are this variation or various parameters of the frequency, or it is going to be used in the case of a fiber optic communication system. The next, that is the application is, that is a optical phase conjugation. If you consider this ordinary radiation, in this ordinary radiation, once the light radiation is incident on the mirror, that will be reflected in this other direction. Incident one direction, and this reflection also in this other directions. But in the case of non-linear optical materials, that reflection also it will be in the same direction. So this property is highly useful for this phase conjugated mirrors. That property is going to be used. Then to understand or to measure the non-linear optical property of the crystal, that is a phase matching is very, very important one. If you take any material, there will be 3 axes. Among the 3 axes, if you measure the refractive index, that will be one side that will be different compared to this rest of the 2. The axis where it has a different refractive index, we can say that is a extraordinary axis or idler axis. If the signal, that is a radiation, and idler, that is this extraordinary ray, okay, have the same polarization, then we can say that is their type 1 phase matching. Suppose if both are in this opposite direction, we can say that is their type 2 phase matching. So how it is possible to measure this NLO means through powder XRD it is possible. That is a Maker fringe method. Another one, absolute measurement by phase matched second harmonic generation, and this is a scan. Now I give that external technique for that powder technique, powder and this is that scan technique. In the case of powder, this experimental arrangement is available many places. Even this IISc Bangalore is very famous. Other places also it is available. Based on this powder, it is going to be fixed here. From this, using this CRO, it is possible to measure this input radiation and this output. From this, its efficiency also based on the reference material, it is possible to calculate the second harmonic efficiency of the given material. The next one, that is the Z-scan method. The third harmonic generation of the non-linear optical crystal, that can be measured using this technique. Here there are 2 methods. So here the source material is there. Here the crystal is going to be fixed here. Here we have the detector. Now the crystal will be moved back and forth along the direction of the incident radiation by 70 micrometer distance. From that, the output radiation is going to be measured. So here that's a open aperture geometry is, if you take the whole radiation, the output radiation will be subjected on the detector. So in the case of closed means that the diameter, that input radiation's diameter is going to be fixed at small area. From this, it is going to be calculated. So now I will move into my research. So the first, that nonlinear optical material, I am going to focus on that is a 4-dimethylamino methyl 4-still basilium tosylate. So NLO means this dust is very popular material. In India itself, if you take many research centers and researchers are working or concentrating on this field. Nowadays, that's commercially also these dust crystals are available. It has lot of applications. So it is this preparation technique for this dust crystal, that is a 4-picoline is going to be added with this methyl toluene sulfonate. It is going to be added in this toluene. It is going to be heated. So from this we can get a white, that is a insoluble, that is a salt that is insoluble in this toluene. From this, the dimethyl is going to be, DMF is going to be added. Then from this we can get this 4-methyl N-methyl pyridinium sulfonate. We can get it. Then that one is going to be added with this another chemical, that is 4N-dimethyl amino benzaldehyde. During the condensation process and reflecting this material at 120 degree, finally we can get this dust crystal. So it is this synthesis process of this material. Though, so these are these crystals, there's a dust crystals we got using this technique. Initially we got this crystal like this. So these are the crystal here. One technique, that is a slope nucleation technique, also we have adopted to grow a bulk size crystal. The major problem of this dust crystal is, that is the thickness. So normally the thickness of the material, that length no problem, the thickness will be very less. So that was the problem. Here also, here we can see the dust crystal. Here also the thickness is less. So most of these papers are published. Here we can see the reference. We have published in 2008 itself, this crystal. So to increase the thickness, we have adopted, that is a nucleation reduction technique. There, the solution is prepared. On the surface of the solution, that's a few oil drops we have placed, that is on the surface of the solution was filled with this oil, so that the evaporation rate of the solvent was reduced. Finally, so once the solvent is reduced, means it is going to affect the solubility of the solution. If it is reaching the supersaturation, means automatically multinucleation will be formed. Once the multinucleation is formed, it is very difficult to get a
Excuse me, sir.
crystal. Yes, sir.
Sir, sorry for the disturbance, sir.
Yes.
2 more speakers are waiting, sir. Next speaker is waiting. Sir.
How long I have? Yes, how long I have time?
Sir, 5 minutes. Just you can take 5 minutes.
5,
Actually, they provide only 30 minutes for each talk.
Sir, Jaisakar sir.
Actually, they provide only 30 minutes for each talk.
Okay, sir.
Somehow, okay, we will see.
Okay, okay, sir.
Go ahead, sir. Go ahead, sir. Go ahead, sir. Please.
Okay, thank you, sir. So, based on this one, we have controlled the solvent evaporation. Then we end up with to increase the thickness. So that also we have published. So these are the thickness improved one. That also we have published in a very important journal, that is Crystal Growth and Design in the 2007. Okay, here you can see. The next, that is a DSNS crystal. That is also important one. Its NLO property, if you take, it was 1.5 times higher than the dust. Based on that efficiency only, we have selected this DSNS crystal. This DSNS crystals problem while we are selecting was the size of the, here also that's a aspect ratio, that here the reported value was only 2 mm length, okay, 2 mm length and 100 micrometer diameter, like a small needle only it was reported. Even the picture also we couldn't see anywhere. In a paper we have seen that one. Based on this that is a NLO efficiency, we have taken that work. Then using that additive method, by adding various additives, we have grown this crystal. That here we have tried many solubilities. Finally we have concluded that that is a methanol chloroform. So it was this best one, methanol acetonitrile, this one. It was this best one to grow a that is a DSNS crystal. Here the solubility also should be high. Otherwise the final crystal also that size will not be much. So we have selected a best solubility. At the same time, these additives, that is a STPB and DTPA. So these are these additives for different ppm ratio we have used. Finally we got a good size crystal. Here you can see. So it was the first visible crystals in the literature for this DSNS crystal. Here you can see. So based on the time limit, so I would like to reduce some of the slides. So MMONS crystal, that is also a very, very important one. That is a 3-methyl, 4-methoxy, 4-nitrile. Okay, that one. It is also important one. This for this crystals NLO efficiency also higher than that dust crystal. The derivative of the dust crystal, another one, that is a Corns crystal, that also we have grown using this Sankar Narayan Ramaswamy technique. The grown crystals here we can see this one. SR technique we have used. The growing crystal here we can see. So to grow this crystal also we have used the we have measured this metastable zone width after selecting a proper solvent. Here that is a solvent we have used, that's a ethyl methyl ketone. The grown crystal here we can see. This after that it was subjected for this various analysis, that is NMR, FTR and other things. This one important that is the NLO efficiency. Normally in India, if you take anywhere, so the powder NLO efficiency only they have measured. We have tried to measure the output radiations. Okay, that's energy in terms of that is a grown crystal. So it is this arrangement we have used to measure this NLO property of the grown crystal. Here we have used the source as NDR laser. So the wavelength is 1064 nanometer. Here we have brought this radiation. Here that the XY stage is there. There we have fixed the grown crystal. 1064 nanometer is invisible. Okay, once that is subjected on this NLO material is this output radiation 1064 divided by 2, that is a 532. 532 is corresponding to the green radiation. That is possible to see here from these slides. So here we can see this 1064 nanometer, 64, it is invisible. We have brought the radiation here. Then using various filters, it is subjected on the crystal. Once it is subjected on the crystal, the green emission here we can see. So 1064 divided by 2, okay, 532 here we can see. So at the same time, we have rotated for this different angle. From this, we have measured where we are getting this maximum energy. That is, we have measured in terms of millijoules. Here, at the orientation of the crystal also, we have measured for the plane, that is the 0, 1, 1. at 115 degree. We got that maximum output for this Cairns crystal and this MONS crystal also. For the that plane, for the plane, that is a 100 we got, that's at 50 degrees degree. Okay, we got this maximum. So whenever we grow a bulk size crystal, it is going to be used along with this laser radiation. So it's that is a laser damage threshold also. It is very, very important one. For that, we have the facility to measure this laser damage threshold energy of a particular crystal. Here we have focused that is a helium neon lasers radiation and this laser, that is NDR lasers radiation at a particular point of the crystal. After that, here we have this screen. There screen, so let me take, initially it is going to be like this. Gradually the energy of the NDR laser is going to be increased. Once small damage is created on the surface of the crystal, means the image on the screen that will be distorted. The distorted image also here we can see. There we will stop it. Then we will measure the NDR lasers energy. From this it is possible to calculate this laser damage threshold. Here we can see for this one, for this MMON crystal, we have measured, it's 154. Okay. And for this Cairns crystal, that is 113. It is this Z-scan arrangement we have to measure this third harmonic generation. Here also, that is a Gaussian filter is used based on that only pure radiation that can be subjected on the crystal. Using that, it is possible to get this, to measure this third harmonic generation. Suppose if the Gaussian filter is not there, means the radiation will be like this. Radiation will be like this. Okay. Once we use this Gaussian filter, we can get this radiation like this. So pure laser radiation will be subjected. Okay. Small portion. So here we can get it. So from this we have measured using that, that is a open aperture technique and this closed aperture technique. We have measured this third order non-linear susceptibility. These are the parameters it is possible to measure. Okay. So due to want of time and other things, I cut short some of these slides. I will stop it here. So I am ready to ask if you have any queries. Once again, I thank the organizers of Vidya Mandir Arts and Science College for giving me the opportunity to share my research findings in this conference. Thank you.
Sir, thank you, sir.
Thank you, ma.
Thank you,
Any
sir.
questions?
I will call later, sir.
Okay, ma. Any question is there? No?
Sir, any question, dear participants and professors, any question? Please ask to sir.
Sir, nice presentation. Really enjoyed how
Okay,
to
sir.
grow
Thank
the
you, sir.
Yeah,
Thank
really
you,
great, sir. Really great.
Thank you, sir.
Okay, sir. Thank you, sir.
Professor Kalainathan, sir.
Sir.
Thank you, sir.
Thank you, sir. So I have stopped sharing my screen. You can proceed.
Sir, Professor Jaisankar, sir.
Yes, madam.
Sir, shall we start, sir, your session?
Yes, madam. Shall I share my?
Okay,
you are allowing me to share the screen?
Sir, definitely, sir. And then one more
Please.
request, sir.
Tell me, madam.
Sir, small introduction about you, sir. Please, sir. Kindly wait, sir.
No problem. Go ahead.
Okay, sir. Thank you, sir.
Good morning to one and all. Photonics discovers the unlimited potential of light-based technologies. It's the light that matters the most. Here we have a potential personality of photonics, our resource person, most respected professor, Dr. C.K. Jaishankar sir from Sri Venkateswara University, Tirupati, going to discuss about physics of emerging materials of rare yet doped glasses for photonic applications. Now, I request our Assistant Professor, Mrs. M. Vanmadi ma'am, to give short intro about our eminent professor.
Good morning to everyone present here. It's my honor and a privilege to give a short note on the eminent professor, Dr. C.K. Jaishankar sir, Professor, Department of Physics, Sri Venkateswara University, Chittoor, Tirupati. Our eminent chief guest is a versatile personality in the field of physics. He obtained his doctorate in 1984 about optical absorption spectra of ER3 plus and TM3 plus ions in certain solutions. His service to the field of science is immeasurable. He is one of the lifetime members of various professional bodies like Rare Earth Association of India, the Indian Association of Physics Teachers, Luminance Society of India, European Rare Earth Actinide Society, Indian Physics Association, Indian Laser Association, and Indian Society for Crystal Growth. He is the chairman for the Board of Studies in Physics, Dravidian University, and a member of Program Advisory Committees in New Delhi, and also a member of Board of Studies in Physics in Bangalore University and Pondicherry University. He has published 234 publications of his own and 432 as a co-author. He made several research projects by the help of many funding agencies. He is expertise in the field of astronomy and astrophysics. Now I conclude my address and welcome our eminent professor, Dr. C.K. Jaishankar, to deliver his speech. I welcome you, sir. Thank you, one and all present here. Thank you.
Thank you very much for your kind introduction. Is it okay? Are you able to see my slides, madam?
Sir, okay, sir. It is visible, sir.
Hello?
Sir, it is visible, sir.
Is it visible?
Visible, yes, sir. Visible, sir.
Is it
yes,
okay?
Sir. Screen is enlarged, sir.
Okay, now it is enlarged.
Yes, sir.
Okay, thank you very much, both Indian Spectra of Physics as well as the college for giving an opportunity. After hearing excellent talk by many speakers, that includes Professor Gunasekhan sir and Kalainathan sir, and my topic is a little bit different because most of the topics are based on the glass, crystals, batteries, and so on. But I am looking for amorphous material, which is not at all a crystalline material, which is a non-crystalline material. However, these non-crystalline materials such as glass and glass ceramics are having very important properties. And without seeing the glass, without touching the glass, without using the glass, it is nowadays it is impossible to lead our life in a modern competitive society. And now, for all these things, we need physics and chemistry of the materials. And now, both the college and the ISPA has came forward, identified a good topic, physics of emerging materials, and really very important topic on the eve of celebration of National Science Day. And now, you see, for all these things, whether it is the science of the materials or technology of the materials or the scattering of Raman effect, whatever it may be, today we are able to see the modern society because of three aspects. One is electromagnetic waves and their exploitation, particularly laser technology. And advances in material science, it may be a crystal or non-crystalline material or non-crystal or whatever it may be. And the next one is computational capabilities. These are the three paths that made our society modernized as well as industrialized, and now we are moving forward. And in particular, even in the COVID-19 pandemic environment, our science and technology is allowing to interact with you through internet. We are talking about the internet because stay home, stay free. So we are not interact with you people unless we are having some connectivity. That is the internet facility, and that internet facility we are enjoying, and so that we are able to meet any challenges, unexpected pandemic environment or whatever it may be. In all these things, these are the three components. One is how best we are making use of electromagnetic waves, and how best we are able to use the material science and also computational capabilities. And Professor Gunasekar sir rightly told innovations and inventions, and because of innovations and inventions, these three fields have been progressed like anything. And now, you see, before I am going to begin my actual talk on direct doped materials, Raman spectroscopy, IR spectroscopy, vibration spectroscopy, rotational spectroscopy, and molecular spectroscopy, these are all one and the same. And now, you see, the theme of the conference, physics of the materials and molecules. We take any material or a molecule, it is nothing but made of more than one atom. If it is a material or a molecule, it is made of more than one atom. I mean, diatomic molecule, triatomic molecule, so on. Once a molecule is formed, the molecule gets vibrated as well as rotational energies are existing, and these are quantized. And by measuring this rotational and vibrational energies, one can get fingerprint analysis. And that's what the molecular spectroscopy says. And same thing, because a molecule is able to rotate in the rotational in the microwave region, and that's why it's called rotational spectroscopy. Similarly, the molecule gets vibrational, and that's why it's called vibration spectroscopy. The vibration spectroscopy, because in the huge family of electromagnetic waves, the vibrational energies in the region of IR region, and that is why it is called IR spectroscopy. And before invention of Raman spectroscopy, one is able to measure the vibrational rotational energies by using appropriate microwave infrared radiation. But after invention of the Raman spectroscopy, one can evaluate vibrational and rotational energies of a molecule by using visible radiation. And that is why it is called Raman spectroscopy. And now we see, as you already heard from the topic, and most of them are told many things, but now I conclude that no one, I think, elaborated what actually inspired the Raman to do scattering theory. Because he's, you see, already Professor Kulasekar told that Vijnanam or whatever that is able to blue because that is going to be explained by science. And the other one is Tamil word I could not say, where there is a god sitting Vishnu and he appears blue. That is why I don't know what actually it means. How the science is able to explain the blue of the sky is as follows. And now it is due to scattering of light. And now you see, the entire electromagnetic waves are ranging from gamma rays to radio waves. In the huge family of electromagnetic waves, a human being is able to see only part of it, that is called visible light. I mean, Vibgyor, violet to red. All these colors are mainly depends upon three major colors, which are nothing but blue, green, and red. If blue, green, and red are adding different proportions, different intensities, then you will get spectrum of colors, I mean infinite of colors. If blue, green, and red are adding equal together, we will get white light. No doubt, the sun emits blue, green, and red. It is traveling from sun to earth. While traveling, it is able to touch or hits the water molecules or dust particles or whatever available in the surface of the universe, and the light gets scattered. Why the light gets scattered? Because of vibrational rotation of the molecule, then some of the energy is absorbed or emitted or whatever it may be. The result is nothing but a scattering. And now, once scattering takes place, and there is a famous rule which was already innovated, earlier speakers like earlier scientists like Rayleigh or whatever it may be, what they are able to prove that is the scattered intensity is inversely proportional to the wavelength of lambda to the power of 4. This is nothing but intensity of the scattered light that depends upon the wavelength. If the wavelength is long, the scattered intensity is less. If the wavelength is short, the wavelength is short, the scattered intensity is more. So blue, green, and red are reaching our Earth. All other colors, of course, it is not going to reach the Earth because of ozone layer or whatever it may be. And now a simple mathematics will tell that blue is shorter wavelength and its intensity, scattered intensity, is very, very high compared to green and red. So once light is coming from sun to earth and reaching the earth, the intensity of the blue light is very, very high. That's why the entire atmosphere looks like blue, so that the sky appears blue or the water appears blue. That's what Sir C.V. Raman is able to explain through his theory. And now, why when blue, green, and red is hitting the dust molecules, molecules or water molecules? Because the molecule gets vibrated or rotational, and because of vibrational energies and rotational energy, the molecule, the incident energy gets scattered. And that's why the Raman effect is so famous, because he is able to explain not only blue of the sky, that is an invention. And innovation is nothing but determination of the molecular, vibrational, and rotational energies. I repeat once again, he invented scattering of light. And innovation is nothing but how Raman effect is successfully useful to characterize any molecule or materials through Raman scattering. Unless you evaluate the molecular vibrations, rotational energy, it is impossible to evaluate, to understand physical and chemical properties of the molecules. Once you know physical and chemical properties of the molecule, then you can tell not only science of the material, but also its application. So any material is having any applications before that, that has to be characterized in this direction. Raman spectroscopy is the best tool. You see, this is a molecule, for example, CO molecule, and having faster vibrations and less vibrations, and this is a diatomic molecule. Similarly, if you take CO2 and H2O, maybe one is non-linear and linear molecule. Through your Raman spectroscopy, all these molecules are having characteristic energies, and those energies you are able to analyze them. And with that, you see, X-ray diffraction will tell what are the arrangement of the atoms, whereas the Raman spectroscopy will tell not only the arrangement of the atoms in a molecule, I mean, is it linear or nonlinear, is it linear or non-linear, it is having symmetric bending or asymmetric bending, and everything can be obtained. So not only the nature of the atoms, but also the bonds, structure involved within the molecule. That is why Raman spectroscopy is so famous to characterize any molecule that has been naturally existed or artificially synthesized. So with Raman effect, science and technology has been developed, and now this is just scattering phenomena only. And now this is what I'm telling. And now you see the molecules get vibrated, and these vibrations and rotations depending upon the bond length, bond angle, and coordination number, and also linear molecule or non-linear molecule. All these things can be explained with Raman effect. So Raman effect or Raman phenomena is very, very useful to identify qualitatively and quantitatively of any molecules that is naturally available or artificially synthesized, which are having practical applications. And now, just if at all a molecule, it is having electronic energy, because electronic energy is nothing but electrons jumps from one orbit to other orbit, and now once it jumps from one orbit to other orbit, it may move from lower energy to higher energy or higher energy to lower energy. That makes you absorption or emission. Similarly, each electronic level is associated with vibrational level, and again each vibration is associated with rotational level. So a molecule is having electronic levels as well as vibrational levels as well as rotational levels, and the establishment of these energy levels as well as their structural details are very, very important. And Raman spectroscopy is one of the best non-destructive analysis. I mean, the molecule never gets destructed, but even then I can measure its physical chemical properties, and also fingerprint analysis. For example, you just see the radiation. What I'm telling here, a quantized energy has been allowed to interact with the matter, and that matter may be a molecule or dust particle or water molecule exists in the atmosphere, and once the photon interacts with the matter, any of these phenomena will take place. And now, by measuring either scattering or emission or diffraction or transmission, I can tell what is the material, because I know what is the energy I sent, what is the energy allowed to interact. And now I have the analytical tool A to Z. That's what Professor Gunasekar is telling. This spectroscopic technique is such that A to Z materials can be synthesized by using any of the electromagnetic wave depending upon the material you are synthesizing. And now the photon is having these are the characteristic properties. Energy, I mean, what is wavelength, and what is its intensity, what is the nature of the light, is it polarized, elliptically polarized, plane polarized, circularly polarized, and then is it coherent. I mean, when you talk about Raman effect, you need highly monochromatic and coherent light. And now what is its phase? Any of these properties are partial and completely gets modulated when the photon is allowed to interact the material. The people who are going to do research, please remember this point. The electromagnetic wave, depending upon the wavelength, I mean, it may be infrared or infrared or microwave or visible radiation or X-rays or gamma rays, whatever it may be. And that radiation is allowed to interact with matter. Once it interacts, due to scattering, because of scattering, any of these phenomena will take place, and in turn, any of these properties gets modulated. And now, if at all you are able to get the measure quantitatively the modulation of the light after interacting with the matter, I can tell what the material it is. This is what the spectroscopic or analytical technique, and among various techniques, Raman spectroscopy is the best one to get fingerprint analysis of the material or molecule. And now, because of scattering, it may take absorption or emission, transmission, reflection, refraction, luminescence, so on. And now, and all this interpretation, for example, if at all I am able to evaluate the absorption and emission, I can establish electronic energy levels. At the same time, I can evaluate the fluorescent levels, whether the levels are having any fluorescence properties and so on. And then I can exploit the stimulated emission and spontaneous emission, and I can get a radiation, which is a special radiation, which is nothing but a laser, and laser is nothing but a source based on stimulated emission. Many people are getting confused. At least the people who are attending my talk, please define laser is nothing but a source based on stimulated emission. And many of the students even today they are telling that what do you mean by laser? They simply say that light amplification by stimulated emission of radiation. This is only an acronym you are explaining. But if at all you want to be a best student, you are having this subject and you are depth in the knowledge, you have to tell that laser is nothing but a source based on stimulated emission. Because of stimulated emission, the light gets amplified. All other sources light coming from the sunlight or your fluorescent lamp, your street light or whatever it may be, all are based on spontaneous emission. No doubt the spontaneous emission is also having monochromicity, intensity, coherence, everything. But those values are so small so that you may not have any practical applications. For example, you might have heard nonlinear optics. No doubt the radiation interacts with the matter and the polarization changes. Those polarization changes very, very small. And now if at all you are sending the intense light, the polarization changes non-linearly so that that material becomes non-linear material. Because of the light is having very, very high intense, because the high intensity is coming because of stimulated emission, not because of spontaneous emission. So laser is nothing but a source based on stimulated emission. And now please remember, when Raman effect was invented, they invented only with the mercury lamp using a filter and allowed to pass the green light to interact with the material, and they are able to measure the Stokes and anti-Stokes of the pure organic material. And now they have to expose the film hours together, my dear friends. And also it's a photographic film, and now it takes overnight to do the experiment. And now the science and technology, inventions and innovations have been progressing steadily in such a way you can get this Raman scattering, Raman effect with no time. Just keep the sample, your monitor will tell the Raman effect because you are using high intensity radiation, your color film has been digitized. No need to go to a dark room because you see, if you see the history of the Raman effect, they struggled a lot to invent Raman effect. They used photographic film, and to develop the photographic film, it takes hours together. It has to be dried, so you will not get the result within a minute. Whereas now the science and technology, because as I told you, advances in materials, advanced computational capabilities, advanced electromagnetic waves, you will get result with no time. Just keep the sample, you see the result on the monitor. And also you can modify, you can evaluate everything because of computational techniques. The wavelengths have been analyzed, and also is it similar to any other compound? Everything you are able to get it. And similarly, when you do the transmission, you can do how material is best for communicating electromagnetic waves, particularly optical signals. And today fiber optics becomes famous because of transmission properties. And now the earlier Professor Kalainathan and the earlier speaker spoke about the crystalline materials. Even the crystalline materials, there are two types, uniaxial and biaxial. And all those things can be distinguished through refraction because double refraction will take place. And now reflection, total internal reflection is the cause for the development of the fiber optics that you are able to study from the interaction of the one of the analytical tool. And also diffraction. Without diffraction, it is impossible to avoid the crystal, the X-ray diffraction or whatever it may be. And diffraction is very, very important. And now if the electromagnet interacts with material, sometimes that electromagnetic wave, other than visible radiation, gamma rays or X-rays, interacts the material, you will get visible light. That's what scintillators you can say. If you know how the X-rays have been invented, you are keeping a fluorescent lamp, fluorescent screen, so that if at all X-ray generated, that fluorescent screen gives color because that is visible. Because X-ray cannot be seen, but with the fluorescent screen, you can see the laser emission. So if the material is able to emit, then all display devices are very, very useful. Today you are having light emitting diodes, you are having your laptop screens, you are having your mobile screens, you are having display screens of TV or whatever it may be, or even in the street lights or traffic lights and the name boards or display boards everywhere in the market or bazaar or in supermarkets for advertisement or so on, all are depending upon the display devices only. And now, you see, material science is very, very important. Physics of the materials is very important. You take any of these topics, I mean, nanoscience, technology, whatever it may be, spectroscopic technique is one of the best technique to analyze the material. So it is very, very important point one has to remember. And now you see, these are all the glassy material because my topic is glass and glass ceramics. As I told you, for example, you can see beautiful monuments, forts. The windows are really very, very attractive colors, which was constructed long, long ago. You can go to any port or temples, you may miss to see the iron or steel or anything else, but still you can enjoy some windows, colored windows. And now, do you think the color has been started, invented now? It has been having a long, long history. And you can see goggles and bakers. You see, the chemistry department is surviving because of glass. Do you think without baker, without pipette, the chemistry department will survive? There is a glass. And now the alcoholic bottle. So even a poor fellow will not get sleep unless he takes a cup of alcohol. And now this glass is this alcohol vessels are made of glass. And now the lens or whatever it may be, watch or laptops, everything is made of glass. And glass is ruling the society. And now just you see, these are the colored glasses. And all these color glasses can be obtained. For example, the crystallographer is able to develop a pure crystalline materials. A spectroscopic technique will add some impurities. Why is adding some impurities in the material? Because some of its properties has to get modulated so that you can get little bit applications. For example, If at all you take a colorless glass, if you add any transition elements like nickel, cobalt, copper, whatever it may be, you will get its respective colors. And this is transition elements. And today, the rarest elements have been added in such a way, still you will get better colors, durability, lifetime, or really very extensive applications and benefits we are having. Instead of transition elements, if you use rare earth elements, you will get wide variety of applications. And now, my dear friends, today ruling in science and society only a glass. If at all you just click in internet or Chrome, the Canada tourism, and in Canada, the tourism is going to, because tourist buses taking one city and the other city, and they take in the morning and they drop in the evening. Where in the case of Canada, they start a vehicle, a train is constructed, the entire part was constructed only by a glass or amorphous material like polymers, polished plastics. And now you are having a transparent glass window. When you are sitting in the train, you can enjoy the beauty of the sceneries, waterfalls, animals, and everything. A train has been constructed by a 75% are constructed by a glassy material. And I don't know whether you believe or not, whenever we enter in a train or a bus or a car, children are fond of sitting only near window. And now it has been rolled out. Anywhere you can sit, anywhere you can enjoy. Not only children, along with children, the parents, and the entire family can enjoy the view made of a glass. And similarly, my dear friends, nowadays, most of the monuments also constructed by a glass. And if you add some impurities in a glass, which will emit some fluorescent materials, by applying the voltage, you can change the color of the house. For example, if at all you want to change the color of the house, you have to paint them. And if at all you want to repaint, you have to remove, you have to repaint once again, you have to change the colors. And night times you can see the entire building color can be changed, not only the entire portion, part of the portion partially, so that you can decorate your building in such a way you can get variety of colors. And just because of glass and their impurities present in the glass makes you lovely buildings. And now, not only the societal applications, scientific applications, if at all you want to develop, generate high energy and high power, the laser gain media should be very large. That is possible only a glassy material, not a single crystal material. The power limitations are there because the gain media, you cannot grow a single crystal more than 1 feet or even more than 1 centimeter. If it starts more than 1 centimeter, defects and clusters will be formed. Where in the glass, it is not such a case. Glass is the only material one can fabricate a bulky window sizes to a complex miniature fiber. So you know what is fiber? It is having clad and core, which are having microns, and not only a micron size, one can draw a kilometer length, few kilometers. So it is not possible any other materials. Only a glass and glass ceramics can be fabricated whatever size you want, and maintaining the homogeneity and cost effective. And you see, you can prepare variety of glasses in such a way. So for a laser gain media nowadays, glass is very important gain media. Similarly, optical fibers, as I told you. And now today, communication technology, information technology, everything is surrounding all over the world, because you are able to communicate from one point to other point with no time, and because of optical fibers. And now even you see the power sources or whatever it may be. Previously, a battery has been fabricated by anode and cathode and electrolyte. Electrolyte is amorphous material, and anode and cathode is crystalline material. And once the charge of the electron or the barriers are traveling from one end to the other end, it goes from amorphous to crystalline material. There is always a problem, and that is interfacial problem. If at all any of the cathode are molded into a glassy material, transport properties are very, very easy. So you can get less loss and high energy can be obtained. So nowadays, people are working to fabricate batteries, at least part of it by a glass material, because electrolyte is only amorphous material. And now the cathode is a crystalline material. If at all I am able to replace this crystal material by glassy material, and now 50% of the enhancement can be achieved. That's what people are doing. And now this is what I'm showing. And now you just see glass ceramic, glass material, and one acts as electrolyte, the other one acts as anode and cathode. And now this is the way how one can improve the efficiency of the batteries by making glassy material instead of crystalline material. And now there are different classes, and now you might have heard phosphate, silicate, telluride, germanate, chloride, lead oxide, and so on. And these classes can be modified because once borate glass, phosphate glass, this is a fixed one. If you add some impurities like alkali and alkaline elements, its properties can be modulated. And now, once you are able to modify the glass composition, then you can add some active elements like rare earth elements, D block elements, so that its optical properties or magnetic properties or electrical properties, thermal properties, you can able to modify depending upon the glass composition. So there is no end for research in glassy materials and glass ceramics. By changing the proper modifiers, proper formers, proper active ions, one can enhance the optical, magnetic, electrical, thermal, and any properties. And that's what research is going on. Compared to crystal materials, glassy materials are very, very easy. Even one can start in degree colleges and small colleges just with 50,000. One can prepare variety of classes so that they can make active research in their field if they are interested. And for you see, if at all you grow a nanomaterials or a single crystals, you have to go to X-ray diffraction, you have to go to SEM, TEM. The characterization is very, very expensive. Once you prepare a glass, even a layman can test whether the glass is formed
Sir,
or not.
excuse me, sir.
And by looking vision,
Sir,
you
excuse
can
me,
say
sir.
whether the glass is transparent or not. I can do everything. And like, just as I told you,
Excuse me,
there's
sir.
a former, modifier, and active. I can keep on changing glasses. I can prepare variety of glasses. So this simple way,
Excuse me, sir.
just being, yes,
Sir, the time is
hello.
going on, sir.
Okay, I will stop within 5 to 10. Don't worry. So variety of glass can be prepared,
Okay, sir.
and now I can measure the optical properties because depending upon the environment, the optical properties are going to change. And this is what I am going to do. What is position? What is off width? What is the area under the car? And now if I measure these things, I can optimize the materials and the optical properties. This is what we are doing in our activity. And in this connection, once a class is prepared, I want to tell you, Raman spectroscopy is a powerful tool to establish the vibrational rotational energy of the molecules, which we call the phonon energy. And now the phonon energy will tell you luminescence properties. The phonon energy is very, very high. Multiphone relaxation is very, very high. In turn, you may not get the luminescence. So Raman effect is very, very important to identify a better molecule which is having high luminescence properties. And these are all different types of glasses and their phonon energies. And if the phonon energy is less, it is good for luminescence properties. And now, look, these are all the glasses we have prepared. And whether you believe me or not, these glasses are really having some technological applications for which we are very fortunate. And Department of Atomic Energy has given a huge amount, and we developed these glasses at SU University Tirupati and having some potential applications. And now glass may be converted into glass ceramic. You see, glass is a non-crystal material. I can induce crystallinity so that I can get a nanostructure. Once I am able to convert glass into glass ceramic, and it is having enhanced properties. And for example, you see, the blue one is a glass material, so the black one is a glass material, and the blue, red, and the glass ceramics. And you can see the shorter lifetime and this is a longer lifetime, and that makes glass ceramics are far better than the glass materials. And all what we do is we can keep on changing glass composition. we measure simply optical absorption, emission, and decay time measurements, and we will optimize the glasses and for specific applications. And now I can show you an important, interesting point. People may be interesting. If at all you want to generate color, three colors are important, as I told you: blue, green, and red. And now the cerium 3 plus of rare earth ion emits blue color, and terbium emits green color, and europium emits red color. And now how these colors are going to be tuned or modulated as for example, look, if at all europium, terbium, cerium, terbium, thulium, samarium, all these ions, active ions are having different colors. These are all in the visible region. And now if I join two glasses, for example, this is the red and green and blue. These are three major colors. By combining these two, for example, you can see europium is red and terbium is green. And now keep on changing the concentrations. I can play from red to green and I can get infinite colors. This is the way how researchers are able to do it, and we can develop new colors, because in the market you are able to see different colors of your vehicles. Every day you are getting different colors. That is possible because of changing their colors. And now similarly, the europium is red and cerium is blue color, and keep on changing the concentration of these two things combined together. I can play from red to blue, and in between there are so many colors. How best you are able to attract you, and life warranty and so on, sharpness, everything can be monitored, and these are all having some photonic applications. And now you see the entire material science and their molecules, characterization of their materials through Raman spectroscopy makes you. Today, our forefathers are used to live in thatched houses. Today, we are having skyscrapers. And similarly, our forefathers are able to use only mud vessels. Today, we are having stainless steels. These are all because of development in material science. Not only science and technology has been developed, same thing, the human beings have been developed from our ancestors. From I don't want to tell you. Today, we are able to see a modern person because our gene has been developed over the time. And now the gene has been developed in such a way, someone become Albert Einstein, someone become a Sir C.V. Raman, someone become Abdul Kalam. All this depends upon the way you are coming up, the way you are trained, the way you are gaining your knowledge is very, very important. That makes not only improvement in material science, but also genes improvement and so on. And now what I can say that glass and glass ceramics are emerging essential and exciting materials, molecules. As such, its physics is very, very much needed. Identified the importance and necessity of by Indian Spectrophysics Association and Sri Vidya Mandir Arts and Science College, Uttangarai. Hope this event can stimulate creativity in our minds towards Make in India and Made in India, in which at least someone who is listening to this talk are going to be a part of it. And now, you see, as the Professor Gunasek already pointed out, 2005 has been recognized International Era of Physics, and similar 2015 has been recognized as International Era of Light, and 16th May has been recognized International Day of Light. And the science Raman effect is a powerful tool to establish a molecular vibrational rotation through scattering theory, and that the theory was invented in February 28, 1928, and that's why we are able to see a Science Day celebrations on February 28. And what I request is someone has come to forward to find out new inventions so that our name should be recognized International Day of Science, not National Day of Science. That's what we expect. And now I finally thank my parents, teachers, family, friends, and my classmates and students who are responsible for my development in science and technology. I'm able to gain some knowledge because of the components generated, helped by all this community. So I thank the organizers giving an opportunity to share my knowledge, though time is short. And if anybody is interested in glass science and technology, they can always contact my email and also my mobile number. I will be at your end if you need it, anything towards my lecture. Thank you very much for listening patiently, and thank you once again for all. I'm closing my talk,
Thank
madam.
you, sir. Thank you, sir, for your valuable informative speech.
Thank you, Professor Dr. Jayasankar sir.
Thank you, sir.
And,
All credit goes to you, sir.
Actually, this is a more informative and useful lecture to the younger generation, those who are interested to pursue research in the glassy materials.
Yes,
And
sir, yes, sir.
we have mentioned laser, source based on simulated emission. I think today only I have got this new idea. So this is year after,
Yes, sir.
we will adopt. Laser means source based or simulated emission. Yeah, correct.
Yes.
And more thing, impurity present in the glassy materials makes lovely building. These are one of the
Yes, sir.
applications. Here I
Yes,
have
sir.
shown the PowerPoint in the slide. I think I could see the lovely buildings.
Okay,
You can
sir.
do wonders with the glassy materials.
Yes, sir.
So, thank you, Professor, for your nice talk. Thank you, sir. Thank you.
Thank you, sir. Thank you, sir.
Dear participants, any questions?
Sir, nice presentations. Sir, really enjoyed. I've been learning your classes. All this one. In fact, we work with solid state and it's very nice, comprehensive presentations. Are really, we love your physics. Okay, of Raman, all this important information. Sir, thank you very much, sir. We'll keep in touch, sir. Thank you.
Thank you.
Sir,
Thank
Professor, sir, one question from our student side, sir.
you. Please.
Good afternoon, sir.
Yes, please.
Sir, I'm Vijay from SMM College, sir.
Please.
Sir, your session is very nice and informative.
Go ahead.
I have one. Sir, why partly was glasses?
Huh? Why rare earths
Sir, why
instead of transit
particularly
elements?
rare earth was doped to glasses?
No, that's what I'm telling. You see, the importance of rare earths can be understood because of its electronic configuration. The active elements, the valence electrons available in the F orbit makes you very, very sharp emissions and also very, very metastable states. Metastable state is nothing but once the atom gets excited, it will stay relatively longer time. In the case of D block elements, the outermost electrons are not shielded, where in the case of F elements, the outermost valence electrons are shielded by occupied 5s2, 5p6 orbitals. That makes rare earths are very, very important and useful to get sharp line emissions and also long lifetimes. And also you will get once sharp emission means the colors are very, very sharp. And also in the case of D block elements, the problem is you take an iron. Once the material is synthesized, you may get 2 plus, 3 plus, 4. The valence is not going to be a stable one. Whereas in the case of F block elements, either 2 plus or 4 plus instead of 3 plus. That makes you the electronic configuration also can be fixed. Once the electronic configuration at the ionization state is fixed, and automatically the energy levels can be fixed. So you can have a particular application and whatever desired applications you want. You take D block elements, iron 2 plus 3 plus 4, similarly nickel also 2 plus 3 plus. There are so many valence states that makes complicated spectral lines. Interpretation is very, very difficult, and now the F block elements are very, very quite easy, and that is why today you can see most of the lasers available in the market in the research labs are based on neodymium, erbium, ytterbium only. No doubt the laser has been invented with ruby laser, no more available in the market. You can see only the exhibition. So that gives us stepping stone to enter solid state lasers, and the day by day science and technology, research, innovations and inventions are increasing, and the rare earth elements are so attractive just because of its electronic configuration. And now one more point I want to tell you, sir. Previously it is called rare earth, but is no more rare earth. It is essential, necessary element. You can see everywhere, anywhere. For example, your laptop screen, your mobile screen, your TV screen is made of rare earth elements only, because those elements are able to emit different colors. all fluorescent materials are made of rare earths only, just because of its unique electronic configurations. If you still want to more, you can talk to me. I will explain you later on. Okay.
Sir, thank you, sir. Thank you so much, sir.
Okay. Anything else, sir?
Thank you, sir.
Oh.
Thank you, Professor C.K. Jaishankar, sir.
Thank you, madam. Thank you both of the ISPA and our college giving an opportunity. I remember forever, and let us keep continue.
Okay, sir. Thank you, sir. Thank you, sir. Sir, respected Dr. C. Segar, sir. We shall start, sir.
Yes, madam.
Okay, sir.
Very good afternoon. I am ready.
Sir,
I
good
can.
afternoon, sir. Good afternoon, sir.
Morning,
Can I
sir.
upload now?
Good morning, Professor Sagar.
Yeah, very good morning, sir.
Good morning.
Sir, Jaishankar, sir.
Yeah.
Good morning. Good morning.
Yeah. Very nice meeting, seeing you all. Though we are separated, by distance, we are all now connected, and yeah, it's very nice meeting you, sir.
Thank you.
Madam,
thank you,
upload.
sir.
Sir, Panala, sir. Sir, a small introduction, sir, about you.
Yeah, go ahead, madam. Go ahead,
Okay,
please.
sir. Thank you, sir. Thank you for your permission, sir.
Good afternoon, one and all. Infectious diseases are impossible to cover up. You may be able to cover up the figures, but you can't cover up the virus. Now, in this fabulous session, we have an eminent resource personality, the most respected Professor Dr. C. Segar sir from Alagappa University, Karaikudi, is going to discuss about the science of Kapasura Kudineer and its role in the prevention and control of coronavirus disease COVID 2019. Now, I request Dr. K.M.P. Prabhu sir, Assistant Professor, to give small intro about our eminent professor. Thank you.
Madam, in the meantime, please
Sir?
permit my uploading. It
Sir,
says
sure,
it's
sir.
disabled.
Sure, sir. Definitely, sir.
I want to upload, but it is disabled. It says host disabled participant screen sharing.
Sir, now please click, sir. Now it is approved, sir.
This will start sharing. One moment. Can you see my slide now, madam?
No, sir. No, sir.
Now?
Yes, sir. Yes, sir. Now it is okay, sir. Now it is visible, sir.
One moment. It's full screen now. Is that okay?
Yes.
Full screen.
Yes, sir. It is in full screen, sir. Now it is in full screen.
Okay.
We shall start, sir. Your intro.
Yeah. Can
Okay,
I
sir.
start?
Thank you, sir.
Sir, good morning to one and all. I am extremely proud to stand before you to introduce our professor and the chief guest of Dr. C. Segar sir, Professor and Head, Department of Bioelectronics and Biosensor, Alagappa University, Karaikudi. He has awarded PhD degree in Nanomaterial Nanoscience, Crystal Growth Center, Anna University, Chennai. Teaching experience, Assistant Professor of Physics, Pillar University, in the year duration of 2005 to 2010. And also worked in Professor and Head, Department of Bioelectronics and Biosensor, Alagappa University, Karaikudi, from 2010 to till date. Postdoctoral fellowship, he has been awarded with the post PDF by Nippon Telephone and Telegraph NTT Corporation, Japan for 3 years, 1997 to 2000, and the Institute of Solid State and Material Research Fellowship, Denson for another 5 years, 2005 to 2000 to 2005. Subsequently, he has served as assistant professor of Pelliar University at Pelliar University, Salem. He also served as founder coordinator for the Center of Nanoscience and Technology in the same university, and mobilized a grant worth of more than 100 lakhs in 2008.
Sorry for the interruption, Prabhu.
Contribution, Pelliar University award him with Sir C.V. Raman Innovative Research Award in the year of 2009. Dr. C. Sagar sir has been working in Agartala University as professor and head of the Department of Bioelectronic and Biosensors since March 2010 to till date. His current research activities include development of chemical and biosensors for applications in the area of biomedical, environmental, and food technology. He has published more than
Prabhu, I think it is enough. Thank you. I want to start.
Additional responsibilities, member in Senate, member in Standing Committee of Academic Affairs, Dean in Industrial Consultants, member in Quality Assurance Cell, Director Center for International Relationship, Dean Research, Coordinator Center for Nanotechnology, Coordinator for Center for Renewable Energy at the Alagappa University. Area of specialization, Material Science, Metallurgy, Semiconductor, Carbon Nanotubes, Biomaterials, Low Dimensional Equipments. He has researched for PhD he completed 11 scholars and ongoing 7. Also, PDF is completed 2 and ongoing 1. Publishing more than 100 journals in the citations of around the 1968. Cumulative factor is around 350. H index is 24. I-10 index is 50. Fund research project UGC Debt Collaborative Research, UGC Higher Education Department. Total cumulative fund is 261 lakhs. Distinction activities and awards, National Metro Loan Scholarship, Government of India.
Prabhu.
Junior Research Fellowship, DST, State Level Screening Test, Senior Research Fellowship, TN Set, Council for Science and Industrial Research, Sir C.V. Raman Award, visiting professor in various countries, Japan, Shizuoka University, and Italy. Alagappa Excellence Award for Researchers, Sir DST Government Award, Travel Support, Best Postal Award, and visiting researchers in various universities and various countries. Events organizing leading roles of various conferences, workshops, and chairpersons is more than 20 conferences. Overall visitings various country, Japan, Singapore, Canada, Japan, USA, France, Germany, Italy, Switzerland, South Korea, Italy, Malaysia, and so on. Membership of various boardings, life membership in MRSI, life membership in Crystal Association, Electrochemical Society in USA. Academic bodies is Chairman Board of Studies and Board of Studies in Electronics, Bioelectronics, Biosensors, Electronics and Communication in Alagappa University. Also pursuing various PhD programs in various universities.
Prabhu, I think it is enough. Thank you.
Sagar sir have been awarded Alagappa Excellence for the year of 2016 to 2017 in recognition as his research contribution. He is also visiting professor in Shizuoka University, Japan, and University of Messina, Italy. Thank you, sir. Thank you for this given opportunities in our department. Thank you, sir. Now session for.
So, yeah, very good afternoon to all of you. Is it audible, madam?
Professor Dr. C. Sagar sir to deliver.
Yes, madam. I am talking. Is it audible? Hello.
Audible, Sagar.
Okay. She is not responding.
Dr. Ari Selvi?
Sir, I'm in line.
Is audible?
Can you listen to me? Like, am I audible?
Yes, sir.
Okay.
You are audible, sir.
Oh, great. So, yeah, thank you so much, first of all, for the very, very long introduction. I was trying to interrupt, and in fact, I gave a very short, just 6 of my minutes for introduction. Thank you, Prabhu. He was my student in Periyar. Probably that is the reason why he has mentioned.
Not like that. You deserve richly. You deserve richly.
Thank you.
Not like that. Not like that.
Okay. Thank you very much. Yeah. Already we are late by more than 1 hour, I think. My schedule is later by 1 hour. So first of all, I would like to thank my mentor, my guru, my professor, SG sir, S. Gunasegaran sir. We used to SG and also ISPA, and again the head management of the founder of the college, the great institutions in Uttangarai, Chandrasekhar sir, and the Department of Physics for organizing such a nice nice conference through virtual mode. And yeah, and now I want to start my presentation. As you could see, the title of my presentation is something I think different from what has been talked so far. And Professor Jayasankar has given very very colorful classes, and its application was emphasizing glasses are superior than anything, whether it's a single crystal or polycrystal or
Thank you.
Okay.
So yes, indeed, glasses are one of the oldest known scientifically investigated material and known material. So you are great and your work is great, sir. But now what I'm going to talk about the science of Kabasura Kudineer. Now almost this has become a very common word among the community, among the people. And COVID, we have almost forgotten it, or we are trying to forget it, but people again, government is talking about the recurrence in the form of second wave. So it is very important that we pay attention to the diseases like COVID 2019 and the much more to be faced probably in the future due to the global warming and other drastic changes that is taking place in the earth. About virus. Now, virus is very familiar word. Whenever we go, earlier, whenever we go to doctor with the complaint of fever or headache or body pain, even without seeing the patient, without checking temperature or without any investigation, doctor always says it is a simple virus fever. It will be there for 2-3 days. It will be all right, but still you take medicine when you have fever. That was the case probably that we have been witnessing right from our childhood, and even now it was going on. Suddenly, same the virus family has come, and it has put the entire world in a standstill for more than a year now. It is close to a year now, more than 2019. So what is this virus, and how different the coronavirus when compared to the viruses that we know already? For that, we need to begin with what is this virus? Are very small, that everybody knows. We cannot see it with the naked eye because the size of the virus is from 20 to 300 nanometer. So it cannot be seen with the naked eye, but there are special fiber-shaped viruses which goes up to 1.4 micrometer. Still, it is beyond our human visibility. So, like this, there are millions and millions of virus species. I don't mean viruses. Virus species, virus kinds, virus types that exist on the earth. So far, only about 5,000 viruses have been investigated in detail, and we know the history and structure and other details of the viruses. Virus was discovered about 130 years back, And lots of research have been carried out by biologists and particularly microbiologists to understand what these viruses are, because the viruses, are dangerous, unlike the other microorganisms such as bacteria. So, but despite all such, long 130 years of research, still there is a question whether the virus has a life or not. Do viruses have life or not? That is still a question, unanswered question. Again, there is another group of people says it is just an organic structure that interact with living organisms. So this debate is still going on whether the virus has life or not. But despite under such a condition, viruses create causes lots of diseases. So we need to know more about the virus and take precaution. See, viruses, and again, say the major difference between the virus and bacteria is why it cannot, reproduce. Why people say that it doesn't have life? Because it does not have cell structure. That is the basic unit of life. We all know that all living beings, including human beings, are made up of cells, animal cells, plant cells, etc. So virus do not have cells, but they have RNA, that is the genes that could reproduce and replicate, the copies through self-assembly process. So the viruses cannot reproduce independently. That is the point. So they always look for the host organism, and whenever they come across living organisms like plants, microorganisms, microbes, birds, animals, and now humans. So they are hunting for their survival, that they want to stick on to some living organism for survival. And they are very selective. That is one of the key, speciality about it. They seem to be more, clever now. Probably we cannot say with the human beings, but the virus turned out to be very clever because they are choosy. They don't affect all parts of the body. For example, if it happens to enter into the human body, it goes to the liver, it goes to the lungs, and it goes to some parts of the organs, and sit comfortably and does all sorts of harms. So this in this series, in this background that we know about the virus, coronavirus was invented in we cannot say, was discovered in 2019 in Wuhan city of China. Okay, since then we know the history and the impact that the coronavirus had on the humankind. So far, it has affected 85 million people, and in 218 countries, probably the entire world. And the overall death is close to 18 lakhs, that is 1.8 million so far. But fortunately, it is very, very small in India. And you see the Wuhan city, and I was there in Wuhan about 4 years back, visiting university for some days. So this is the current statistics. Why I am showing this? You forget about all the numbers. You pay attention to this India and the global. When compared to the entire world, the many nations in the world, recovery percentage in India is 96.4 or even more. The death is only 1.4% or less. See here, it is 1.4%, and when compared to most of the countries, sir. Hello. Okay, so the death is also very, very small when compared to many countries in the world. There are countries where about 4 to 5% death rate also. Death in the sense those who have affected could not recover and died. So there is some speciality about India. Okay, this is a key point for my research. Now this is what I wanted to relevant our research. So why this is so, that India is less affected and India recovered very fast, and with high percentage, and the death percentage is small. Why? And there are many reasons. People say, when you look at the WHO site, World Health Organization site, or any other media, that they say there are many young people in India, so their immunity is better, and so the recovery rate is very high. And that is one of the reasons. The other reasons is Indians are dirty, so their immunity is high. That is also being talked about. And another group says that Indian statistics are not reliable because India is very big and they don't have reliable statistics. That is, it's not my statement. This is a statement that you find in the internet by well-known bodies. So apart from all these, reasonings, there could be something else. That's what I feel, and everybody has to, think in that way. That our traditional food, our traditional medicine, including Siddha medicine, that is the, that comes from South India, could play a major role in controlling and curing COVID-19. That could be one of the reasons why. When we say this is a kind of empirical fact, this is the fact that we see, the results that we see by ourselves. But when you want to say it as a scientist, when you want to confirm or when you want to convince the world community that our traditional medicine is good, Siddha medicine is good, and they are helpful in treating the corona, and our food itself is a medicine. We are living in a tropical, on the equatorial line in the earth, where we see full 12 hours a day and 12 hours night, and beautiful sunny days for more than almost all through the year. So this means we are blessed with lots of natural resources, natural food, which itself act as a medicine. Food is a medicine, another concept. So how do you convince? How do you convince the scientific community outside the world and even for our own people that yes, this Kabasara Kudineer and the medicine like that, and our food work favorably in such a way that we don't have many problems, especially with the virus attack like COVID. So for that, now the question is, what is Kabasara Kudineer? We all know it is made up of 15 different herbs, medicinal plants. Sometimes we take root. There are reasons for that. Sometimes leaves and stem, all this. So 15 herbal plants were taken, and in the they are dried, and the same proportion was mixed and ground well, and we got a powder. And this is the visuals. The picture of the 15 ingredients of the Kabasara Churanam. Before it becomes a drink, it is Churanam only. So these are the things. Most of them, say for example, Chuku, that is Inji, ginger, and many Krambu. Likewise, so some of them or many of them are being used in our day-to-day food also. Okay, and see what is there in the plant. We are all physicists mostly, and I also studied physics, but doing more of biological related research now. So I have to essentially read all this. See, every plant or every fruit have a major phytocompounds, so-called, any chemical that is found in the plants or fruits are called phytocompounds or phytochemical. So every food, for example, Chuku, Inji has gingerberrin as the major phytocompound, Tipili as piperin, Krambu, Iconal. Likewise, every compound has a major chemical in the plant. In the plant. So when you mix 15 of them, and you again you boil it in water, and how many of these chemicals are soluble in water, and solubility obviously cannot be the same for all the chemicals, because now it is a chemical, biochemical, we call phytocompound. So solubility cannot be the same, it will be different. And again you are eating. So the question now comes, then in this background, I asked many questions as and we try to understand, or we need to understand essentially many questions. What is the science of Kabasara Kudineer? Okay, how does it help in curing COVID-19, or for that matter, other diseases? Again, remember that this Kabasara Kudineer or Kabasara Churanam is not new. This is known for hundreds or even thousands of years. Our elders, our the saints in the olden days, they have been using this for centuries. So I'm sorry, there is a phone call. So, and then the question comes. So, the Kabasara Churanam is not new. This is a traditional Siddha medicine. Okay, and why 15 herbs? For example, Nilavembu Kasayam was served for dengue. It is only one. But now for COVID-19 or for other lungs-related diseases, cold-related diseases, 15 plants were mixed. Why 15? And what are the chemicals present in it, in the Kabasara Kudinir? And what are the proportion of these chemicals? When you go to a medical shop, you buy a tablet or a tonic, then you look at the contents present, and also they give the composition, so many milligrams, like that. So what are the proportion of these chemicals? And why drink? Again, the question is, Kabasara Kudinir is given in always hot, decoction. Unlike other tonics, there are many, even, these Siddha medicines available in the form of tonics in the medical stores. They are preserved, they are stored in the bottle and kept in the refrigerator or or even in the open atmosphere for months or sometimes even years. But Kabasara Kudinir, it is always recommended to drink only hot. Why? What is the difference between the other? We forget about the Western medicine. We can concentrate on our own Indian medicine, our own Tamil Siddha medicine. Why it has to be served hot, and how much to drink. When you YouTube, when you Google it, there are so many people. Everybody becomes a doctor. Everybody becomes a Siddha doctor, and they have floated so many, sites. You drink like this, that, so many 3 times a day, 4 times a day, and on what basis they say how much to drink, and how to determine how many days. Again, they say 4 days is fine, 3 days is fine, and how on what basis they decide how many days. And the most important, how does the KSK work? What is the biology of the pharmaceutical happening that takes place in the body? And another important question is, what are the side effects, after effects? And I again Google through YouTube, I found that for a pregnant woman it's not good, and for children it's not good. Fine, but on what basis you say? Again, that is the problem. So above all, if the traditional medicines are Siddha medicine, here Kabasara Kudinir, why can't we sell it to the other countries? And why can't we sell it even in the northern part of India? And these are the questions that we had in mind before starting the research. I think I've taken too much of time, but these are the very purpose of the research presentation. I always believe is to inculcate the questioning capacity or questioning habit among the youngsters. Young research, that is the very purpose. Otherwise, they may not be able to follow all my high-tech research or high-tech equipment that I use. But what is more important, you question. Whatever you see, you need to ask the right way, all right, and you will become successful in whatever you do, whether it's a research or anything that you do in life will become all right. So the purpose is to make you to think about all this. And we have carried out, some scientific investigations. There are again number of publications that came from India and more and other country, India studies, advanced crystallographic studies to talk about how this could help. But experimental research in the wet laboratory, probably not many people have done. And this is what we did. We have taken Kabasara Kudinir, Kabasara Churanam. We have prepared decoction at different temperatures, and also in different products we have tested and prepared the liquid, and parallelly we have developed a sensor. This is the major part of our major specialization of our department and my group. So we develop sensors, new sensors for research and development, also for the application purpose. So from this diagram, you can visualize all the research. Initially, this is independent. We have prepared the hydroxyapatite, titanium oxide composite, nanomaterial composite, and coated on the glassy carbon electrode. It became a thin film, and this is what you see. And we have taken Cabasora Kudineer, and yeah, I mean, we have prepared Cabasora Kudineer from Cabasora Churanum, and we have tested this on the electrode at various temperatures. This is the, and also under various conditions. This is the essence of what. And at present, what we have achieved so far is that we have determined, we have tested that there are so four major phytochemicals in the Cabasora Kudineer, that is after the extract is done. One is the ascorbic acid. Ascorbic acid, you all know, it's a vitamin C. And another one is icanol. It comes from okay, lavangam, I think. And this is thymol, and this is gingerol. These are the chemicals, these are the phytochemicals found in the Cabasora Kudineer in various concentration. That is what I wanted to tell you for now. And this we have tested independently. For example, we have taken this separately from Suku and all these, and tested separately, and all together when they are in the form of decoction in the Cabasora Kudineer. This also we have tested. So this is the experimental detail. Okay, and we have prepared the composite material, hydroxyapatite, titanium oxide, tested all the calculations, XPS, spectroscopic studies, and all this, and prepared the thin film, very thin film on the glassy carbon electrode. This is simply about the material preparation and electrode preparation part. And parallelly, what we did is we have taken the Cabasora Kudineer and did the UV visible spectroscopy studies. Various concentration, various quantities, 1 to 40 microliter. And then you see there was always one. This was the initial study we did. There was always one peak at around 271, and when we refer to the literature, this 207 T correspond to the itself, and from the laboratory, and did the UV visible spectroscopy. You see what is the result in this diagram. A strong peak at the 271, here 270. So this is an indication. This is the UV visible spectroscopy of the Cabasora Kudineer initially. It gave a strong peak here at 271, indicating that there is ascorbic acid. Ascorbic acid is nothing but vitamin C. You must have seen that the government has recommended, and in some cases they have also supplied ascorbic acid, vitamin C, along with zinc tablets. That is booster. That's what I used to tell. That is how we used to tell. Immunity boosting happens there. Okay, and then we have tested this with the several electrodes, several sensors. It's not only hydroxyapatite, titanium oxide, but with the many sensors based on many materials in order to check if the reproducibility. Yes, it is done. And we have also used another, this is the electrochemical study where you also, and confirming that ascorbic acid is one of the prominent compound that is found in the Cabasora Kudineer after extraction. And the second compound is icanol. Okay, and that's what we did. And we continued with this, and ascorbic acid and icanol were determined and quantified. How much? See, that is the problem. By how much? For example, if you take 100 ml or in a tumbler and you drink, or 50 ml in a tumbler, you drink it. And in the 50 ml, how much ascorbic acid is there? How much eugenol is there? How much gingerol is there? This is very important. That is because I've written here in Tamil because I made this presentation in Tamil for some other organization, the entire presentation. அதிலிருந்து நான் இப்போ மாத்திட்டு இருந்தேன். இதில் என்னன்னா எந்த அமிர்தமானாலும் அளவுக்கு மீறினால் நஞ்சு நம்ம தமிழ்ல அழகா சொல்லியிருக்கிறாங்க. அந்த மாதிரி ascorbic acid good, eugenol is good, but when it goes beyond certain limit, WHO has given a recommendation, World Health Organization, and it affects the liver, kidney, you can see ear, kidney, and also some other parts. So it is very important that you take the right amount. So our sensor is detects that this is the concentration range. Our sensor can detect this concentration range, and the lowest detection limits are given here. We can detect even the very, very small quantity down to 63.3 nanomole of ascorbic acid and 94 nanomole of eugenol. So this is the sensitivity of the sensor, and this can selectively detect only the target compound. And we have confirmed all the requirements like sensitivity, selectivity, stability, reproducibility. These are the key factors when you say you have a new device for sensing. Then you need to convince, you need to prove that it fulfills all the requirements to be called as a device or an analytical device for this purpose. So we did all the experiments here, and we have developed. See, with this sensor, we were able to detect only 2, ascorbic acid and eugenol, and for gingerol and thymol, we have developed another sensor based on the iron oxide, nanoparticles. And with this also, say for example, initially this material itself has to be characterized, and again most important is what is the pH value. And our physiological pH is 7. Water pH is 7.4. Water pH is 7. So we need to take neutral. And what is the pH value of the Kabasarocudinir? It's more of acidic. That is why we have checked the pH value of the Kabasarocudinir also. I'll make it fast. And we have made all the experiments at pH 7 because that is the pH value body accepts. So we have done a very nice experiments to determine gingerol and thymol quantities in Kabasarocudinir. You can see here the lowest detection limits are 35.2 nanomole and 24 nanomole. Not available in the market, and nobody tested it so far. That is because Western countries they're not bothered, and other medicine, that is because they want to monopolize. They want to be monopolized. Ascorbic acid, they sell it in the form of tablet vitamins that everyone is buying, but whereas it is there in our regular food, it can be taken as a supplement. But somehow the kind of monopoly they wanted to have over the countries, over the world, and we find a lot of difficulties in publishing these works in a good journal. They say work is good, but we cannot publish. That is because once they publish this, then it becomes a scientifically accepted norms. Then everybody will start at least following us, and later maybe taking us. That is the problem, a kind of politics that we face, but still we have one of our papers now has been accepted in a very good journal, and we also try to take patent of it. Okay, now the question is, you can ask me, well, I have asked already, why do we drink hot? Why can't we store? Can we? Again, we did it. We prepared the Kabasarocudinir, stored it in the refrigerator, take it again, heat it, slightly warm it and drink. That is also not good. So it has to be taken in the fresh and hot form. The reason is we have done again spectroscopy and also electrochemical studies. You see, as a function of time, very freshly prepared Kavasar Kudineer was tested. In 30 minutes, you see the intensity dropped drastically. Ascorbic acid became ascorbate, oxidized, like what is happening in the apple. When apple is rich of vitamins, vitamin C, ascorbic acid. When you cut the apple and keep it in the atmosphere for, open atmosphere for some time, within some minutes, it becomes colored. That is because of the oxidation that takes place in the ascorbic acid, making it ascorbate, and it will not have the same effect like what you have, especially in the presence of metals. Zinc is given as a supplement. So the same thing we have tested with the electrochemical experiments. Now with time, there is a drastic change in the degradation of the quality. Drastic change in the chemistry and degradation of the quality. So it is much better that we drink always fresh Kavasar Kudineer. This is the proof that we have shown scientifically. Another thing is that we take rice. I don't know how many people. Rice, especially nama kaikutal rice சாப்பிட
Dear professors and participants, some technical issues in SAR side. Kindly wait.
Okay, I'm sorry, it got interrupted. Is it audible now, madam?
Sir, yes, sir. Yes, sir, you are audible, sir.
இது தெரியுதுங்களா ஸ்லைட்ஸ் தெரியுதா?
Yeah, it is okay now. It is okay.
Okay,
Okay, sir.
okay.
Okay, sir.
I'm sorry. நம்ம சாப்பாட பத்தி பேச ஆரம்பிச்ச உடனே க்ளோஸ் ஆயிட்டது. நம்ம சாப்பிட போகணும். Okay, so I was talking about, rasam sadam is really a medicine. That is what I was trying to tell you, and these are the proof that.
Sir, your screen is, sorry, sir. Sorry, sir. Screen is not visible, sir.
I'm sorry, Inama?
We could
Sir,
not see the
screen
screen.
தெரியல.
Just a second.
Share agla, sir.
Okay. I'm coming, sir.
கொஞ்சம் disturbance இருக்கு, sir.
Much to
Audio
be
sir.
seen. I think I can.
audible, but PPT is not visible. Problem with the screen share.
Sorry.
Yeah.
Madam,
வாய்ஸ் நல்லா இருக்கு
நீங்க திரும்ப
சார். சாரி சார். திரும்ப அலோவ் பண்ணுங்க சார். ஸ்கிரீன் ஷேர்
நீங்க திரும்ப
சார். இப்ப பெட்டர் சார். வாய்ஸ் பெட்டரா இருக்குங்க சார்.
மேடம் ஸ்கிரீன் ஷேர் அலோவ் பண்ணாதான் வரும். அலோவ் பண்ணிட்டீங்களா?
இப்ப அலோவ் பண்ணியாச்சுங்க சார்.
ஓகே. இப்ப தெரியுதுங்களா மேடம்?
சார் இன்னும் இல்ல சார். இன்னும் இல்ல சார்.
பட் நான் தெரியுறேன். அப்படிதானே?
ஆமா சார், நீங்க தெரியுறீங்க.
உங்க வீடியோ தெரியுது, ஸ்கிரீன் தான் தெரியலங்க சார்.
வீடியோ ஆடியோ நல்லா இருக்குங்க சார்.
Sir, you can restart, sir. You can restart. The better way is to restart.
One moment.
You please restart, sir, so that that may be better.
Time waste ஆகும்னு பார்த்தேன். பாப்போம். இது லாஸ்ட் ட்ரையல். Not coming. Okay. சார் வரல.
வரல சேகர்.
மேடம் திரும்ப பர்மிட் பண்ணுங்க மேடம்.
சார் இப்ப அலோவ் பண்ணுங்க சுரேஷ்.
இல்ல பர்மிட் பண்ணல இன்னொன்னு.
பண்ணியாச்சுங்க சார். இப்போ கொடுத்தாச்சுங்க சார்.
இப்போ கொடுத்தாச்சு இல்ல? வருதுங்களா ஸ்கிரீன்?
நோ சார்.
வரலையா? ஒரே ஒரு நிமிஷம். ஓகே. இப்ப வருதுங்களா மேடம்?
ஓகே சார். இப்ப ஸ்டார்ட் ஆகுது.
No, sir.
Yes, now it is okay.
We can see the slide now. Okay.
I'm sorry, sir. Sorry for the interruption, sir.
No issue.
Okay.
No problem.
Okay. So, in fact, I just wanted to make it fast. This is a reason. So here, this is what I have been talking about. Now, why do we drink hot? Again, that is because of the degradation in the form of chemical changes that is happening with time. So நம்ம ஊர்ல, that is again one of the biggest advantages, that we always prepare new food, and almost yearly, at least 2 times a day we prepare the food and eat it instantly. அதுவும் நல்ல சூடா சாப்பிட்டுட்டு இருக்கிறதுனா, that is one of the biggest advantages, unlike the Western countries where they preserve it in the refrigerator and eat it again with the microwave oven, and and these people, now that at least we have seen, they don't have much, though they are very strong physically, they don't have much immunity, that is desired immunity. So in many ways, our traditional food is good. The pattern that we follow for cooking, eating is good. Again, the compositions. See, these are not, these all did not happen over the years, over the centuries. We talk about this Tamil culture about 3,000, 2,000, 3,000, 4,000, even 5,000 after this Kiladi findings have been revealed. This Mother Sivaganga close by. So this evolved over hundreds and thousands of years. The pattern that we have, it is so unfortunate that we try to bypass and follow the Western countries of going for fast food, and and we avoid Indian food or Tamil food, go for pizza, burger, all this fast food. So these are really bad trend that we that is happening in the country now, in the region now. But all these studies clearly, why I am telling this, these studies clearly indicate that there is science in whatever our elders did. It was not, just like that. It was followed based on the experience, but still scientifically, many of them are true. Okay, I can say I have many slides to show, but again, the essence, the conclusion is the same. 30 minutes is the opt period. You can say in Tamil, in 30 minutes time, the peak intensity came down, and then it became more or less stable. So after 30 minutes, then you can see here, after 30 minutes for several hours, you see many peaks that remained here. Here also after 30 minutes, and it is more or less stable. So then there was a question: does it mean that we can preserve, eat it, and again drink? No. When we eat it again, the new peak did not appear. So once it is degraded, certain chemicals cannot be recovered. It may become warm, but there won't be any chemical changes. There is no, the chemistry is not reversible here. Okay, so this is again evident from our research. And quality, this is very, very important. And we are doing many works in order to have new devices to check the food adulteration, food contamination, and the excessive utilization of chemicals in the form of pesticides, herbicides, fertilizers. And there are so many bad things are happening in the country because there is no control over, there is no mechanism over the food, processing, food distribution, food growth, and all this. So there is an evidence here with the Capasora soranum. We have purchased about 20 products from different. Now, once there was a demand, and every supermarket also started, small Malige Kada also started selling Capasora soranum in the packet, 70 rupees, 80 rupees. So we bought many of them and investigated, to check if they are of the same quality. So when you talk about a medicine, and it should be of same quality, same composition, same chemical, and whenever and whoever produces. But unfortunately, very unfortunately in our country, and these people, for example, 15 herbs, 15 செடிகளை போடணும், இது வேலை எது குறைவா இருக்குதோ அதை போட்டுட்டாங்க. விலை அதிகமா இருக்கிறது, பட் அது ரொம்ப எசென்ஷியல்னா அது போடுறது. Because we get only powder and we don't check it. Government is not checking. Government is not helping. Government is also not guiding how to prepare, and no licensing has been done. அதனால என்னாச்சு, நாங்க 20 செக் பண்ணோம். When we tested about 20 products, we found 2-3 are of same quality. I cannot say good quality. And again, there was one product supplied by Lions Club to our university for free that was found to be really good. And the rest of the commercial products were not of the same quality, because we can see clearly a peak. If it is good quality, you should be able to see all the 4 compounds in the right composition. Then it is not good quality. So that is very, very important that there should be a mechanism to ensure the quality of especially the medicine at least, if not food, and in order to have the desired effect, have the useful effect of the Suranam like Kapasura Suranam for the betterment. Then if we do all this, we will be able to sell it to outside and we'll be able to internationalize and we'll be able to do much better. So with this, I wanted to stop because it is already much more than the time allotted to me. And if there are any questions I can ask, and the take-home message for the student especially, I hope there are students listening in the classroom. Message is, start asking and questions about the things around you. In that way, so you need to work on the scientific validation of our traditional treasures like medicine, food, and medicine, the treatment, other treatments, etc. I thank you for your attention, and if there are any questions, I'll be able to clarify, hopefully.
Professor Sagar?
Yes, sir. Yes, sir.
Congratulations.
Thank you, sir.
For
Thank
your
you.
Excellent talk. So on COVID-19,
Yes,
you have taken a nice problem. You chose a nice problem. Normally, I used to quote one annotations. That is a concept development for inspiring innovations to bind science and society. The outcome of the research should be useful to the society directly, even to the common person. That is real research and research excellence. So based on which I think you have chosen this kind of problem. So in your research area. So I should thank you for your effort taken to take this problem. And one more thing, and you have used one FTR spectroscopy for your study. I think already we have discussed about this
yes,
problem.
Sir, I just 1 minute, sir.
Okay.
In the 1 minute. In the very beginning, I mentioned very happily that Professor SG Gunasekaran sir is everything. Mentor means it is everything. And in fact, he was the source of inspiration for this research. And we had a very many discussions over phone because in those days, because of the lockdown, we could not go there. Sir suggested some of the problems or the ideas how to go ahead, and we were planning to do FTIR. Sir, based on the FTIR.
FTR, ATR. Okay,
ATR.
Yeah.
Both are same. Both are same.
Yeah.
Yeah, and because of the lockdown, our students and we could not visit SARS laboratory. Otherwise, we could. He has done some the preliminary studies. We did it with the spectroscopy, and I sent the results to SAR, and got the feedback from him, suggestions from him. That was the great the source or the idea behind all this the new findings. Yes, sir. Thank you very much, sir. I take this opportunity to thank you for your
Sir,
guidance.
1 minute, sir. Sir, 1 minute, sir.
Yes, sir.
You have tested 20 different samples and different there are differences. Any action on it? Because that is also very, very important. You have to bring to the notice of higher authorities what are the analysis you have made, how it is useful to society, and that can be controlled.
Yes, sir. Yes, sir. So this is what, in fact, we have been in touch with the Ayush. There is a Ministry of Ayush and Government of India that they take care of the Ayurveda, Unani, Siddha, and homeopathy medicines. And we are in touch with them. And also the National Institute of Siddha is there in Chennai, Tambaram. And we are also following their activities and all. And see, our people believe if only you publish in any white man journal, people journals are comes from the for other countries. So we are concentrating more on publishing this so that these people believe that what we have found is correct. And I'm sure that the work like this will be a guideline for the government. Especially, I talked about the quality and also how to prescribe and all this. Thank you very much for your suggestion, sir. And we'll have to take it up with the government agencies.
So not yet published. Your results are not yet
No,
published.
published see, we aim at one, for example, bioelectronic biosensor with impact factor 10.5. So they have given asked for many questions. Revision has come, and another journal also with the impact factor 5+. So we always aim at kind of analytical journal which has high impact factors, and they ask many questions, and it is in process.
Okay, thank you. Good luck.
Thank you, sir. Thank you.
Thank you, sir, for your trendy topic, sir.
Okay, ma'am. Sir, once again, I thank you all, especially Professor Jayasankar. It's very nice to meet you. And
No, very
sir,
useful.
Sir, Dr. Jiban Poda sir is in line, sir.
Yeah,
from
Jiban
Bangladesh.
Poda.
Yes, sir.
Nice to meet you.
Professor Jiban Poda.
Jiban Poda, sir.
Yeah, because of you, in fact, I have converted my Tamil talk into English talk. Otherwise, I was about to,
But
speak
still
in
we are able
Tamil.
to see some Tamil slides.
Yes.
Headlines are English, but still the text is in Tamil.
Some of them. From the morning, I was trying to make it English after seeing the names of Jiban Podar sir. We know for more than 3 decades. When I was a student, he was visiting our Crystal Growth Center. So
Great.
it's very nice to see you all on the platform. So obviously, COVID situation in our country, I think.
Yeah, is better. I think in Dhaka or in a whole country, Bangladesh is a little bit better than Europe and USA or Australia. Even mortality rate is also not too high. Still, the people are in villages. The people are not using any mask. Actually, they don't know what is the corona.
Okay, I think we will meet sir separately. It's a seminar time, and Madam is in a hurry now. Arivu Selvi. So once again, my sincere and thanks to Professor Gunasegaran sir and ISPA, Jayasankar, for all of you for listening to me, for interacting till this time. And I wish the conference a good luck, madam. If there is any question, students can take me.
Okay, sir.
Thank you very much.
Thank you, sir. Thank you, sir. Thank you, sir.
And Professor Jiban Podan sir, really, and we are really fortunate for your valuable presence with this 2-day national program, and we feel proud to see you all.
Yeah,
and Professor Jayasankar sir and Professor Poder and Professor our beloved student Dr. Sagar. So I think on behalf of ISPA and I my own self, I extend a cordial welcome to you, sir. Thank you, sir.
Thank you, sir.
Thank you.
Can I share my screen?
Sir, definitely,
Sure.
sir. Definitely, sir. Sure, sir. Hello. Sir, please wait, sir.
Yeah.
Sir, a intro about you, sir.
Just I'll show then. What about that slide is okay? That
Okay, sir. Okay, okay, sir. It is visible.
okay. Good afternoon. Mathiya Banakam. So all distinguished scientists.
Excuse me,
speakers.
sir.
Yeah.
Excuse me, sir.
Please.
Sir, please be waited, sir. Some intro about you, sir.
Okay.
Start intro. Okay, sir.
This is a Jiban Poddar. So
Sir, we will introduce. We will introduce, sir.
yeah, am I audible?
Yes, sir. Yes, sir. You are
Okay.
audible.
So I am working in the University of Bangladesh, University of Engineering and Technology, in the Department of Physics. So more than 35 years I have been teaching in the same department. So I came to India Crystal Growth Center in 1993, first time.
Sir, excuse me, sir. We will
Yeah.
introduce, sir. We will introduce.
My introduction?
Yes, sir. Please kindly wait, sir. Kindly
So
wait. Sir.
organizer will introduce this.
Okay, okay, okay.
Process. Thanks.
Okay, please.
Thank you, sir.
Good afternoon to one and all. It's a world of multiple screens, smart displays, with tons of low-cost computing, with big sensors built into devices. In this session, our resource person, the most respected Dr. Jiban Podar sir from Bangladesh University of Engineering and Technology, Bangladesh, is going to discuss about synthesis and the characterization of CO-doped CO3O4 nanostructured thin films via thermal spray pyrolysis for glucose sensor application. Now, I ask our assistant professor, Dr. D. Balaji sir, to give a small intro about our eminent professor. Thank you.
Good afternoon, everyone. It gives me immense pleasure to welcome and introduce Professor Dr. Jiban Podar sir, Department of Physics, Bangladesh University of Engineering and Technology, Dhaka, Bangladesh. After completing his PhD, Sir joined as scientific officer at Bangladesh Atomic Energy Commission in 1987. Later, in 1989, he joined as lecturer in Department of Physics in Bangladesh University of Engineering and Technology, and he became professor in 2002 in same department. He pursued his postdoctoral research at Anna University, Chennai, and gained JSPS fellowship in Nagoya Institute of Technology, Japan. Professor served as visiting professor in Department of Chemical and Biotechnology Engineering University at Canada. He has received many awards, including Lifetime Achievement Award. Professor research area interest includes growth kinetics, NLO crystals, compound semiconductors, thin films, nanomaterials, carbon and carbonaceous material for optoelectronics and photonic applications. Professor supervised 16 MSc students, 28 MPhil students, and 5 PhD students. Professor evaluated over 160 PhD theses from different universities around the world. As of 2020, Professor has published over 165 research articles in referred journals and proceedings, and author of Applied Engineering Physics, Electricity and Magnetism for Science and Engineering Students. And he has won US patent about methods and apparatus for crystallization for salts. Professor is a fellow of Bangladesh Physical Society and now acting as an editor-in-chief and Bangladesh Journal of Scientific Research. Professor is always energetic, charming, friendly, motivator to young body like us. His bond, link, and chain between us is unbreakable. As a CGC product, now I am once again welcome Professor Dr. Jiban Podar sir to deliver his talk.
Thank you, organizer, to introduce me. First of all, I'm very much thankful to Professor, my respected Professor, Dr. Setu Gunasekaran, for your kind invitation to this virtual conference. So I am so much blessed that all of you, I know very well. So we are so lucky that still 1 year we passed very nicely, and hope all of you are in good health. And all of my friends in Tamil Nadu, they are also doing well. So this conference actually, still I remember that Sri Vidya Mandir 1.5 years before I attended that conference. And thank you, Dr. Arivu Selvi, Dr. Suresh. At that time, they did a lot in their conference. So this time actually, I will talk about that. Mainly the presentation gives you an overview of the synthesis of metal oxides, nanostructures, thin films via the thermal spray pyrolysis for sensing applications actually. So I will give an emphasis on that, the global sensor applications. So this material I have chosen that the cobalt oxide, and as a dopant is the copper. So the overview of these presentations, I will talk about transition metal oxides, copper doped cobalt oxides. Deposition technique is very simple technique I have used for deposition of the thin films. Then the characterizations, I'll discuss about the results of the field emission scanning electron microscope, EDX, for stoichiometric study, then structural study by XRD, and optical transmittance, electrical resistivity, and the glucose sensing properties. These are the topics, actually keywords of my presentation. Here is a sensor is always is very important device that can sense, that can detect the presence of the elements in the environment or in the human body. Actually, based on that, the presence of concentration of the elements, a corresponding potential difference is developed on the film's surface properties due to that resistance of the material. So based on this, the output voltage, the type of the material and the concentration of the element we can estimate. So there are different types of the sensors. Actually, we use especially the gas sensor for the toxic elements, and ideal gas sensors requires some salient parameters. So these parameters we have to look at for fabrication. We need that high responsivity, then good selectivity, fast response, and the great stability, and reproducibility also we need. Then room temperature, working temperature as the room temperature, and we always seek for the low cost and easy to fabricate. Especially for gas sensor are typically classified into various types based on the type of the sensing element. The classification of the various types of the gas sensors based on the sensing elements are as follows, like the metal oxides semiconductor gas sensors, optical gas sensor, electrochemical gas sensor, capacitance based gas sensor, calorimetric gas sensor, acoustic based gas sensor, and resistive based gas sensors. In my talk, actually, I will give you just a brief idea about the resistive type gas sensors. Not only gas sensors, so that we can detect also glucose sensor. So metal oxide semiconductor gas sensors. Here I am talking about the metal oxide semiconductor sensors, gas sensors. So we need that the nano size particle is very important for these sensing applications. Mostly we need that the mesoporous material, and mesoporous materials are mostly ordered and one of the most important functional materials due to their abundant porous structures, uniform pore size distribution, high specific surface area, and versatile composition such as the carbon and metal oxides. So the main attention has given due to their low cost, high and fast response with relatively simplicity of use and ability to detect a large number of the gaseous. These sensors has a unique properties such as the mechanical, optical, electrical, catalytic, and magnetic properties. It possesses that the high surface area per unit mass. The movement of electrons and holes in semiconductor materials are controlled by size and geometry. So we need to tailor the size of the nanoparticles. That is the most important, and we have to tune the structures of the material, mostly the porous structures, and void and porosity is important. And at the same time, the nanoparticle size in the range of the 20 to 100 nanometer are suitable and recommended for the sensing applications. Here, we see that the different types of the materials, the types of metal oxides. We know that the common abundantly available that alkaline earth metal oxides, like the calcium oxides, magnesium oxides. There are some transition metal oxides, these copper oxides, tungsten oxides, manganese oxides, and cobalt oxides, cerium oxides, so many things. And poor metal oxides also, aluminum oxides, indium oxides, tin oxides. And there are some rare earth metal oxides like the cerium oxides, neodymium oxides, and samarium oxides. So these are the group of the oxides material. And these materials are taken nowadays for the gas sensing purpose or the biosensor purposes. The reason is that these are all the metals, but they behave as the semiconducting characteristics. Why these are the semiconducting characteristics? If you look at that, the D shell, they have the odd number of the electrons. And these are the main cause for producing that the semiconducting nature. So if we select that the cobalt oxide, manganese oxide, tungsten oxide, cerium oxides, the rare earth metal oxides, all these series materials we have studied. And dopant, as a dopant, we have used that the copper is very cheap material. So in the periodic table, we can see that these group of these transition metals, especially these type of materials in the D shell, they have the odd number of the electrons, and these are the specialty for showing that the semiconducting behavior. That's why we have talked about the metal oxide semiconductor thin films, especially suitable for the sensing applications. Here, why these are cobalt oxides? This is very attractive and unique properties. These materials is showing that unique properties, excellent chemical and thermal stability, low toxicity, non-stoichiometry, extra capacity to store and release the oxygen, high electrical conductivity, and producing the electron hole pairs, a nice electrochemical response. And that's why the cobalt oxides is a good candidate for bio and gas sensing performances. Copper, why this is copper actually here? The copper is very cheap and very low cost material available in the earth. And here we see that this copper can incorporate into the cobalt oxides due to the different in ionic radius of copper 2+ ion and 1+ ion, that is 0.74 angstrom and 0.65 angstrom. So copper doped cobalt oxide shows a very significant morphological, structural, optical, and electrical properties. Change the structural parameters. This copper can change the structural parameters and introduce an oxygen vacancy suitable for sensing applications. And this dopant can control the electrical conductivity, and that is also suitable for the glucose and other biosensing performances. Here, if we see that the cobalt oxides, this is actually the spinal cubic structures, and having that the chemical formula CO3O4, and this is the these spinal cubic structures is mainly they have the 8 tetrahedral and 4 octahedral sites per unit cell. So tetrahedral sites especially are smaller, and then the octahedral spaces. So B ions occupy half the octahedral holes, where the A ions occupy 1/8 of the tetrahedral holes. So this is this cobalt oxide is actually P-type semiconductor and more stable than the cobalt oxides, and is less than the 500 degrees Celsius temperature. Below these temperatures, then only it shows that the cobalt oxides your face. Here, if we see that if you look at these sites, metal oxides are well-known materials for the sensors, biosensors, optoelectronic devices because of their low cost, high sensitivity, and simplicity in function. Uses as a sensors in health monitoring applications like the drug delivery, glucose sensors, cancer sensors detections. We can use the cobalt oxides, metal oxides as a sensor material. These are the cancer therapy, biosensors, glucose sensors, gas sensors, humidity sensors, battery, fuel cell, optical lenses, transistors, CD, and optical coatings. For all these purposes, we can use the metal oxides, transition metal oxides like the cobalt oxides. I have used that very simple technique actually. It's very low cost and very simple technique that is called the spray pyrolysis technique. This is the homemade, and we don't need any the vacuum systems. This is the open air, as the oxides materials are favorable to deposit in the open air. So the plenty of oxygens are available in the environment, so we can use the oxygens, and we use to the air using the compression, and we pass through the channel, and there is the nozzle, and I used this IV needle, and this is the open container that contains the aqueous solutions. Here, actually, these are two processes. The first is the hydrolysis processes. When we use the salt and dissolve in the water, it gives the hydrolysis process. And again, when the solution is sprayed through the nozzle at a constant rate, maintaining that the constant distance about 25 centimeters and we have that the hot plate. We are using that the barrier to change the temperature, and the optical pyrometer also we can use, or the thermocouple also to detect the temperature. And we use the mask also, the 1 by 1 square centimeter area we can deposit. This is the advantage actually. This advantage mainly these materials, there is no vacuum at all, and we can increase the large area deposition, so that depending on the distance in between that the area of the nozzle and the distance, LD ratio of that LD gives you the actually the area for large area deposition. So that is possible, and we use this the very low cost material. We don't need that the high purity materials. That is the advantage of the simple the spray paralysis, thermal spray paralysis technique. And we can deposit on any plain glass substrates, or any paper, or any plastic, or any cloth. So that is easy to actually deposit on the very low cost the substrate. Here, if we see that this is the depositions, actually the plain glass substrates, the pure cobalt oxides, and 4% of the copper actually there. This is the copper, 4 atomic percent, 6 atomic percent, and 10 atomic percent. So different atomic percentage of the copper we added as a dopant. If we see that the main criteria for this, the effect of the crystallite size is very important, actually the parameter. This the grain size that plays an important role in resistance change and influence the gas sensing performances. Here, then we have to tune that the porosity, and we have to maintain that porosity. And that is the important for the sensing purposes. So the electron charge density change only happens when the exterior type of the oxide grains. There are the grains, and the outer surface, there is the oxygen content are there, but interior region inside the grain, there is a depletion area, has no contribution to change the resistance. That resistance comes from the outer sphere of that the grain size. And because the oxygen can contact on the grain surfaces, so, and that surfaces changes the resistivity, and we maintain, we can measure the resistivity of these the deposited films, and that resistivity gives the change of the potential difference and output voltage. Then we can identify the amount of absorptions, and the types of the materials also we can detect depending on the absorptions of the oxygens and the creation of the grain size, and that depends on that the porosity. So here we see that this is the pure, and this is the 2%, 4%, 6%. And particularly the 4%, after having that the optical study, structural properties, and the nanoparticle grain size, and as well from the resistivity measurement, we have found that the low concentration of the copper dope, the cobalt oxides, gives the better performance and the suitable parameters that is for sensing applications. Essential parameters for the sensing applications. Relatively homogeneous distribution of spherical particles with porous layer is obtained for 4 atomic percent copper doped the cobalt oxides. Porous surfaces of cobalt oxide is obtained for precursor materials having the organic phase, because we use that the acetate format and other components. So there is the transition of the formation of the mesoporous from the organic phase also. Here, we actually confirm that whether that the copper is doped within the sample, and for that we studied that the energy dispersive X-ray, that is the EDX, and we identified that the peak for the oxygens and copper is there, and cobalt. So this we can say that this is the most stoichiometric film consisting of the copper as a dopant and cobalt and oxygens. So that we identified using that the EDX spectra. And here then we have seen that these are the mainly this particle actually the XRD. XRD always gives that the informations that the position of the peak, and that is the intensity of the peak. Position of the peak always gives that the unit cell, and the intensity always gives the purity of the materials, and full with half maxima that we calculated the crystallite size. So that the position and almost in the same positions without any change of the crystal structures, that dopant copper little bit change that the resistivity and optical properties and band gap also. But structurally, we did not find any. But from full with half maxima, we calculated that the minimum, the crystallite size is about the 25 nanometers. And that we can say that this is the suitable actually for the sensing applications. Here, there is a table, but is not coming here. I don't know. That crystallite size is depending on that lattice constants, definitely that unit cell parameters and presence of the divalent copper and trivalent the cobalt ions and excess of the copper ions at higher content from about 6%. So that crystallite size is again that the increases here. The minimum crystallite size we got at 4% of copper, about the 25 nanometer. So better randomly orientation of crystallite size are observed for both the, we also use that the iron as a dopant also, but here only in the slides and in my presentations, I will show that the copper doped the cobalt oxides. Here, this is the absorbance and transmittance is almost the same that we have seen that in the visible region, about 4 to 30% in the visible region, that is very minimum here. But in the infrared region, there is a optical transmittance about the 44 to 76% in the near infrared regions. So this transmittance obtains in the visible that comes from that the DD shell and SP and PD transitions of cobalt ions. In the visible region, that is the amount of that this is the transmittance is low, but absorbance is more. So that because of absorbance is interaction between the DD and SP and PD transitions of the cobalt oxides here. And that we calculated the band gap actually using that the tau formula from the optical transmittance data. And we calculated the thickness of the films using the Physio fringe method. That is the simple, the Newton's ring. That is that method actually, the reflected light systems. And we calculated the thickness, and that thickness about 200 to 300 nanometer. That is the thickness of the films. We got it. And using that for the pure cobalt oxides for 4%, 2%, 4%, and 6%. Here there is that the minimum band gap we got it at about that for 4% here. Here again we'll see that the transitions of the band gap, optical band gap mainly, and here is a 0% for and 2% and 4% is the optical band gap, and that is also here we see that the thickness is about 291 and 2.182 band gap we got it, but for 6% actually here. That the value is 2% is the minimum and second 6% is also minimum. That there is a change, I don't know, but especially 4% we got that the more smaller crystallite size, and there is a small variations here also we got it. Here then resistivity is important parameters actually that comes around 10 to the power 4 order, that resistivity here. And as a function of temperature, it shows that the 2% is there also is also copper concentrations at for 2%. We got these the conductivity is the minimum here, and conductivity is also for these the maximums for the 4% conductivity. And again, we got it that the that resistivity is a function of temperature. It shows that the semiconducting behavior, that range is the semiconducting behavior. Resistivity is that is the minimum for 6% actually. Then and the carrier concentrations also we calculated here, and Hall effect measurement because of the doping concentrations that are the common data actually we need to specify these the types of the material, and decrease in resistivity with the temperature confirming the semiconducting behavior of the materials. Next, actually here we see that the thickness 4% here actually this some data actually in fact we got some anomalies, but particularly if we compare that the average crystallite size about 24 nanometer, band gap is about 2.19, and the thickness is 291, although the band gap is minimum for 2 point, but that is behavior as a semiconducting characteristics. So it should be there. And resistivity is also, that is the 0.45, carrier concentrations and Hall mobility also. That band gap is related to that resistivity and the optical properties also. And that is also related to that crystallite size also, that band gap. We see that the effect, lower crystallite size increases the grain boundary scattering, for which the impedance increases for the electron movement. Or lower crystallite size always increases the grain boundary scattering, and that for which the resistance increases for that the electron movement here. And second, actually, this is the 4-point-proof method. We use that the zinc and copper as the electrode. And next, actually, the sensitivity we measure, this is the formula, actually, IX is the difference in between the sample and without sample. That is the actually with the glucose and without glucose, that the potential, the current passing through the samples, and that is the glucose concentration. In presence of the glucose concentration is the current difference between. And so here we can see this is the equation. Glucose and water and sodium hydroxide is used for acceleration of the solutions, and ultimately the free electrons are generated from the glucose solutions, and that interact with that the metal, actually species on the thin films. This is the metal oxides, nanocrystalline metal oxides, thin films, and this material, oxides material metal, just contact with the free electrons generated from the glucose solutions, and there is a creations of the holes actually. Then pair combination of the electron, we see that the effect of this, that, and from there actually we calculated these the mainly on the film surface active metal atoms enhance reactivity. So any metals on the films that can pick up that the free electrons coming from the glucose solutions, and by extracting electron, oxygen molecules absorbs on the oxide surface, and that changes the stoichiometry and conductivity. At the film surface, oxygen ions may immediately interact and bond with ions from the glucose molecules, and these interaction produce the charge carrier and increase the current actually. So increase of the current confirm the glucose sensing performance of the films, which is measured by the IV car. So the glucose concentrations we maintain 0.4, 0.2 molar concentration, supply voltage about the 64, and important parameters, that is the current response, rising time, recovery time, response time, rectangular waveforms. We got no negative influence of glucose on the film surface, complete oxidation reduction of glucose, final act as a detector having on-off illuminations here. So this is the sensitive sensing current. So we measured here. This is the rising current, actually the time taken to rise from minimum to the maximum, and the recovery time to come back to the original position. That is the value, and on-off, this minimum is off, the maximum is the on positions. That is the peak of the sensing current with the time. Actually, we have seen there copper doped to the copper cobalt oxide films, and here is the two. This is the 0, 2, 4, and 6. And finally, we have seen that the glucose response actually at 4% actually, that we got that the nice the crystallite size about 0.97 second to pick up, and the concentrations we got it actually 43%, and the minimum time, that is the 0.9 seconds, is the response time actually here. And then we got it a 0.97, the sensing time with the time, shortest response time, and quick response ability. So because of these the film characteristics, we have the less response time and quick response ability, we got it. So the conclusion is the 4 atomic percent cobalt doped cobalt oxides have the high response ability, may own more active sites for detecting the glucose because of interaction of the copper and the cobalt oxides. Copper is playing to create the crystallite size actually here, and the glucose is creating that the free electrons, and that is picked up by the cobalt oxides films here. So that is also 3-dimensional views, cross-sectional views. We can see that the blue color mainly the direct combination of the conducting electrons. Green color represents the combination of superficial electrons, and the red yellow color gives you the oxidation reduction processes. So sensitivity decreases at the concentrations of the glucose concentrations is increases because of the most active sites on electrodes are covered by glucose and current response is reduced. So the sensitivity is always decreases because of the high concentrations of the main. And so we use the software, and then the color combinations also we can predict that the combinations oxidation reductions and recombinations of surface electrons, and as well by that the hole and carrier mobility also that gives you the recombinations of the materials. Here is also the dark red portions is giving the actually 0.5 mole at 4% here is that gives you that the red portion shows that the sensitivity of the 4 atomic percent cobalt copper to cobalt oxide films at different glucose concentration. Maximum response is observed at 0.5. That is the 0.1, 0.3, 0.5 is the maximum response. Here you see that the 112 percentage, that the 92, 97, 102, 112, and 106. That is the main 0.5 molar concentrations that we can detect, that the main glucose concentration leading to increase in electron concentrations, which may increase the oxygen vacancies and reduce related the defects in the cobalt oxides and nanoparticle. More absorption sites for glucose molecules are provided by oxygen vacancies. Actually, the main conclusions I would say that always the transition metal oxides are helpful for creating that the oxidation state, change of the oxidation state, as well for the creation of the holes, as well for the creation of the oxygen vacancies also that can create. And because of that deficiencies and the defects, we got the lot of the defect centers in the films, and that is the main suitable for the absorptions, because the gas molecules, different gas molecules are the different size, and that depending.
Excuse me, sir.
So that is the main conclusions, and that is the conclusions mainly that the cobalt oxides films developed, and the copper doped 4% we recommend that is the suitable for in these purposes for the absorptions. Especially we have detected the glucose, and some publications also in 2020 that is the SN Applied Sciences that the cobalt doped manganese oxides that we detected and published. That is also, and that is also here the electrical iron doped manganese oxides also we have done. And these are the main, actually last we have completed that the copper doped the cobalt oxides is not yet published, but still we are working. So again, I would like to give my great appreciations and gratefulness to the organizers, and especially Professor Sadhguna Shekaran sir for your kind invitation. And as we cannot meet each other, but hope to meet you all again in near futures. And still we'll keep our collaborations, and as long as we are in this art. So we'll be very happy to meet you all. And thank you, every members of the organizing committee. And again, thank you very much for your patience hearing.
That's 30 minutes, sir.
Thank you, Professor.
Thank you, sir.
Jiban Podar, sir.
I know, sir. Yeah. You are so kind, actually. How are you now? How is your health, sir?
Oh, fine, sir. Fine, sir. I'm okay. I'm going regular checkup. I'm taking medicine regularly.
Sir.
So health is normal, sir. No problem. Thank you for your concern, sir. Thank you. Thank you.
We are always worried, sir, when we get to know about your health.
Yeah. You inquired about me during a last visit to Sri Vidya Mandir.
Yeah.
And we have sent the mail, everything. I'm thankful to you.
Thank you, sir.
Concern. Yeah.
Again, I have a plan to actually to make a visit to Buet, actually.
Oh, okay. Definitely, Professor. Definitely.
Thank you, sir.
Yeah.
Thank you.
Thank you, sir. Thank you, sir.
Thank you very much.
Yeah.
Thank you, sir. Thank you, sir.
Professor Jiban Podar, sir.
Sir.
Technical data given in your talk will be immensely useful to the younger generation. to pursue the research work in this area, I think useful to the scientific community also, and then society. I think really we are happy to see you with this 2-day national webinar, national conference organized by Sri Vidya Mandir College in collaboration with ISPA sir. Again, and we invite you for any.
My apology actually, because of that the meeting and so many classes, I could not attend that the inaugural sessions. But again, I have some exam duty now to that after 15 minutes. So anyway, thank you, sir. Everybody.
Thank you, sir. Thanks a lot.
Thank you.
Thank you, sir. Thank you, sir.
Good afternoon, sir. I am
Welcome, sir.
Here.
Dr. Selvapandiyan.
How are you, sir? How are you, sir?
Fine. I'm very happy to see you. Vanakkam.
Sir, welcome, sir.
Shall I share the screen, madam?
Yeah.
Definitely, sir. Please wait, sir. Small introduction about sir, about you.
Madam, post display பண்ணுங்க. Disable பண்ணுங்க. Yeah.
Yes.
Our former professor Ed.
Yes, sir.
Of our Vidya Mandir
Our
College.
department head, sir.
He started this kind of activities long before. Every year organizing national international conferences, and Inspire program, also the young students program, everything, you know. I think now Dr. Aruseli is following his steps actually. I think in continuation of the work undertaken by our Selvapandiyan, Dr. Aruseli is, I think, continuing your continuous effort.
SARS training, sir. SAROட training தான், sir.
Yeah, to organize this kind of activity, I think we should appreciate on behalf of ISPA. Kindly.
Thank you, sir.
Keep it up.
Thank you, sir. We shall start, sir.
Okay, ma'am.
Okay.
Start.
Swami Vivekananda quotes that take up one idea, make that one idea your life, dream of it, think of it, live on that idea. Let the brain, the body, muscles, nerves, every part of your body be full of that idea and just leave every other idea alone. This is the way to success, and this is the way great spiritual giants are produced. Here is our most respected, most valuable professor, Dr. M. Selvapandiyan, sir, with us, who is giving to detail us as the introduction, properties and applications of NLO materials. I call upon Mr. J. Armugam, Assistant Professor, to give short intro about our eminent professor.
என் நாவி கலந்த என் அன்னை தமிழின் பாதங்களை தொட்டு வணங்குவதில் பெரும் மகிழ்ச்சி கொள்கிறேன். Good afternoon to all of you. On behalf of organizing committee, Sri Vidya Mandir Arts and Science College, Autonomous, Uttangarai, and Indian Spectrophysics Association, Chennai, it is great pleasure to us to introduce today chief guest, eminent professor, great personality, hard worker, young and dynamic, good researcher, Professor Dr. M. Selvapandiyan sir, Principal, Periyar University Constitute Arts and Science College, Arur, and also Department of Physics, Periyar University, PG Extension Center, and Dharmapuri. Professor Dr. M. Selvapandiyan sir pursued undergraduation in physics at Periyar Arts College, Kadalur. He reached Anna University, Chennai for his post-graduation degree. He completed his Master of Philosophy at Bharathidasan University, and he has registered for research work at Bharatiyar University, Coimbatore. Professor Dr. M. Sellu Pandian sir started his teaching career at the Sri Vidya Mandir Arts and Science College, Uttangarai in 2002. And he remains a dedicated teacher to this day. But he was restless to do more than just teach syllabus. So he went about promoting research activities in the department. He also is credited more than 52 publications in reputed national and international journals. He also extending his meritorious service of being referee of various reputed journals like as International Journal of Science, Technology and Humanities, Materials Letter, Indian Journal of Science and Technology, Vibration Spectroscopy, Journal of Saudi Chemical Society, Silicon Springer Nature Journal, Journal of Scientific Research and Journal of Materials Electronics. And he was invited to deliver more than 72 lectures in national, international conferences and many more science programs. And he is the Senate member, Principal Senate of Periyar University, active member in various states such as DST, JRF Selection Committee in various institutions. He also acting as an external technical expert in various science bodies such as DST, FEST program, various institutions, Board of Studies, Doctoral Committee in various institutions, and UG PG Course Application Committee, and Guest Lecture Selection Committee of Periyar University. He served as a coordinator of IQSC cell in Sri Vidya Mandir Arts and Science College. Under his valuable guidance, he has preserved so far 20 MPhil scholar and 84 MS students in the field of crystal growth, nanoscience and thin film, and 2 PhD scholars submitted their thesis, and the remaining 4 is currently going on, and 5 MSc students also they are doing the research work. All right, Dr. M. Sellu Pandian sir has been honored not a single time, 3 times. He received Best Teacher Award from the prestigious institution of Sri Vidya Mandir Arts and Science College, Autonomous Uttangarai. Not only that, he also received the great and prestigious award, ISPA, Indian Spectrophysics Association Award, Dr. S. Gunasekaran Award for better and good research excellence. He also received Vidya Educationist Award 2017 from the Sri Vidya Mandir Arts and Science College, Uttangarai, for his contributions in the field of science. He also published 52 papers in the national and international conferences to his credit, and he is authored in a number of books in the field of physics and environmental science. And he has organized 5 national conferences, faculty development program and workshop, organized 3 DST Inspire program with grant, and 1 TNSCST CSAP program with grant, and 2 Indian Academy Lectureship Workshop program with support of grant, and UGC a state level seminar, more than 50 one-day seminars he also conducted, and he also acting as various members in the science bodies, that is Indian Association for Crystal Growth, life member in Indian Physics Association, life member in Indian Spectrophysics Association, life member in Materials Research Society of India, and executive member in Indian Science and Technology Association. So under Dr. M. Sellu Pandian for leadership, hard work, honesty and sincerity, perseverance and self-confidence, 13 students of UG and PG and MPhil physics students clinched gold medals and university first rank, and also more than 65 students fetched 2 to 10 ranks from Periyar University examination at Sri Vidya Mandir Arts and Science College, Uttangarai, from the period 2002 to 2015. Now I would like to talk in Tamil few words. எப்பொருள் யாரார் வாய் கேட்பினும் அப்பொருள் மெய்ப்பொருள் காண்பது அறிவு என்பது வள்ளுவனின் வாக்கு. இந்த வள்ளுவனின் வாக்கிற்கு வலு சேர்ப்பது போல நடந்து கொள்பவர் வரப்புயர நீர் உயரம், நீர் உயர நெல் உயரம், நெல் உயர குடி உயரம், குடி உயர கோல் உயரம், கோல் உயர கோன் உயர்வான் என்ற அவ்வை பாட்டியின் வரிகளுக்கு இணங்க செயல்பட்டு கொண்டிருக்கும் கடின உழைப்பாளி, சிறந்த ஆய்வாளர், காலத்தை கச்சிதமாக கடப்பவர், கிரேட் பர்சனாலிட்டி, எமினன்ட் ப்ரொஃபசர், யங் அண்ட் டைனமிக், Dr. M. Sellu Pandian sir, on behalf of organizing committee, Sri Vidya Mandir Arts and Science College, and especially Indian Spectro Association, Dr. S. Gunasegaran sir, I invite you, sir, to deliver a great lecture on this conference. I invite you, sir. Please welcome and thank you for giving this opportunity.
Thank you, Arumugam, for giving a nice introduction about me. Madam, share பண்ணலாமா?
ஷேர் பண்ணலாம் சார், பண்ணுங்க சார். சார் கொடுத்தாச்சு சார்.
Yes. Is it visible, madam?
Yes, sir. Yes, sir.
அன்றோ எந்த நாவியும் உடலும் உடமை எல்லாம் கொன்றே எனையா எனையாட்கொண்ட போதே கொண்டிலையோ இன்று ஓர் இடையூறு எனக்கு உண்டோ எந்தோல் முக்கன் எம்மானே நன்றே செய்வாய் பிழை செய்வாய் நானோ இதற்கு நாயகமோ என்று இறைவனை வணங்கி, most respected eminent professor, former registrar of Periyar University, founder president ISPA, Dr. S. Gunasegaran sir, respected head of the Department of Physics, convener of this program, Dr. IVCPEMM, lovable friend Dr. J. Arumugam, and other from various institutions and students, friends. Very good afternoon to one and all present this webinar program. So first of all, I would like to thank convener and Professor S. Gunasegaran sir for having given the wonderful opportunity to share my views and ideas about the basic research to the benefit of young minds, the students. I think this is only for PG and MPhil and PhD scholar for their upliftment or carry out so their research work in very good and quality manner. Okay, so my title is the properties and applications of nonlinear optical single crystal. It's an introduction here.
Sir, excuse me,
madam. Yes,
sir,
madam.
Screen, please enlarge your screen, sir.
Yeah.
It's a slideshow.
Yes.
Okay.
Okay, sir.
Yeah, okay.
Okay, so
okay.
Linear, that is there are two kinds of the optical nature. One is the linear nature and another one is the non-linear nature. So in the linear nature, people are using only the low intensity of radiation to check the quality of the material. So if we pass lower intensity of the radiation, that means lower wavelength of the radiation to the material at the time which interact with the material and then emit the same kind of radiation as the input. Okay, so nothing will happen inside the material. Okay, that means the input energy is equivalent to output energy in the linear optical phenomena. Okay, in the case of the nonlinear optical phenomena, here we check the quality of the material by the higher wavelength of the radiation. Okay, so that means the India laser and the India laser with the wavelength of 1060 4 nanometer. If we pass such a laser through the medium or material, so at that time that radiation interact with the material and then emit the different kinds of the radiation. So that kind of the process or phenomena is called the nonlinear optics. Okay, and then so based on that, based on the particular phenomena, here we have prepared the nonlinear optical crystal for optoelectronic and photonic applications here. Okay, here we have taken only the sulfamic acid single crystal. Okay, this crystal have grown by slow evaporation solution growth method. Okay, so based on the molarity ratio, we have taken the sulfamic acid material and then which is stirred in the deionized water after 3 hours, which was completely dissolved and then obtained the homogeneous saturated solution. So after getting the homogeneous saturated solution, which was filtered with the help of the Waterman filter paper, so doubly to remove the unwanted dust particle and impurity from the sulfamic acid material. So after that, so that material is poured in the petri dish and then kept unperturbed place for slow evaporation. So at the end of the 25th day, we harvested so pure, highly transparent the sulfamic acid crystal with the dimension of 12 into 7 into 4 millimeter cube. Okay, so and then prepared a doped material. So the magnesium sulfate is a compound have used to change the properties of the sulfamic acid material. So here we have taken the two different concentration. One is 1 mole molarity of the concentration, and the second one is the 2 molarity of the concentration. Okay, to improve the quality of the pure sulfamic acid material. Okay, so here the calculated amount of the 1 molarity magnesium sulfate have taken and then added in the pure sulfamic acid saturated solution, so and then stirred. Okay, so continuously after that we got the saturated homogeneous solution. Okay, then it was filtered with the same filter paper, that is a Wattman filter paper. So and then kept in the unperturbed place. Okay, so at the end of so that is the 25th day, we have obtained the two kinds of well clear, transparent, quality 1 molarity, 1 mole percentage of Mg2 plus ion doped sulfamic acid material and 2 mole percentage of Mg2 plus ion doped sulfamic acid material with the different dimension. So the 40 into 26 and 12 millimeter cube, 1 mole percentage of Mg2 plus ion doped material, and then the 2 mole percentage of so Mg2 plus doped sulfamic acid material. So there are 3 kinds of the material we have obtained. Okay, and then checked so their properties. Okay, so there are so many properties we have okay carried out to check the material whether it may be quality or not. Okay, so the first one is structural properties. Okay, structural property, here the powder X-ray diffraction study is an important study. By using the study, we have to check whether the grown material is crystalline nature or not. Okay, so after that we check the exact the crystal system and the space group of the particular material. Okay, so after that we can easily able to determine so the crystallized size of the material and then dislocation density and etc. Okay, so these are the parameter how to that is the find, so that is the from the powder X-ray diffraction studies. Okay, so there are so many sharp peaks are there. Okay, these sharp peaks are in the X-ray diffraction study, so clearly confirms that the grown material having high crystalline nature. Okay, so after that, so that graph was indexed, okay, and then find, so that their lattice parameters value with the single crystal XRD with the source of molybdenum K alpha. Okay, so and then that particular value is verified with reported values. Okay, these lattice parameters value clearly confirm that the grown material so belongs to the category of orthorhombic in nature. Okay, so all the doped crystals peaks are slightly varied, but the crystal system not altered. Okay, so the crystal size of the particular material, so the pure sulfamic acid 1 mole percentage and 2 mole percentage of the material is also increased. Okay, and then that is the so the concentration of that increases due to the concentration of Mg2 plus ion in the pure sulfuric acid crystal. So and also we have determined dislocation density of the dislocation density of the material of 2 mole percentage Mg2 plus ion doped material is very low compared to the pure material. Okay, so that's why we confirmed that the grown the 2 mole percentage of sulfuric acid material have so the better quality than that means pure and 1 mole percentage. Okay, therefore the defects of this material is very less compared to this material. Okay, so these are the important the property have analyzed from the X-ray diffraction studies. So the another one is the EDAX analysis, energy dispersive X-ray analysis. So this is the very important the analysis. So from this analysis, we can easily able to find the presence of the element in the particular compound. Okay, so that is the based on this study. So there are that is the many elements. Okay, the based on the molecular formula, nitrogen, oxygen, sulfur, so and other dopant also present in the particular crystal. So that means 1 mole percentage and 2 mole percentage the crystals. Okay, so the another study is UV visible analysis. So this is the very important studies for nonlinear optical crystal. So by using this study, we can easily find the exact value of the absorption and transmittance of the grown material. Okay, and also we determine so the cutoff wavelength of the material and then energy band gap, so the refractive index and then etc. But there are so many parameters how to determine by using UV visible analysis. Okay, here, so that is this is the UV visible absorption analysis. Here the graphs drawn between the wavelength and absorption. Okay, so in this graph, so that is the cutoff wavelength of all the three kinds of the material where so that is the found. Okay, so that is the 202 is for 2 mole percentage, 208, so that is the 6 for 1 mole, and then 210 for the pure. But the cutoff wavelength of the material is varied due to so that is the inclusion of the magnesium ion in this pure sulfuric acid material. Okay, so and also we found the exact transmittance of the material. The transmittance of so that is the 2 mole percentage is very more compared to the that means some 1 mole percentage and pure material, which shows clearly so the 2 mole percentage of the Mg2 plus ion doped sulfuric acid is well quality, so the clear transparent than so that means another material. Okay, so and also determined the energy band gap of the material, okay, by the tau flat. Okay, the energy band gap values of the pure 1 mole and 2 mole percentage are so 5.91, 6.02 and then 6.14 electron volt. That means the band gap of so the grown material increases while we increasing the concentration of the dopant in the pure material. This shows the grown material belongs to the category of the insulating nature. So this value is also compared with so this theoretical value. Okay, so these two are so very good agreement with each other. Okay, so this is the very important study. The another study is thermal analysis. So thermal analysis is important. By using this study, we can easily able to check the thermal stability of the particular material. Okay, so that means so at which temperature the material get that is the thermally stands. Okay, up here this is the pure material. Okay, the pure material is thermally stable up to 212 degrees Celsius. And the another one is the 1 mole percentage of Mg2 plus ion doped material. So that material is thermally stable up to 216 degrees Celsius. And then the third one is, so that is the 2 mole percentage doped material. This is the thermally stable up to 270 degrees Celsius. That means what I say, the thermal stability of the grown material are increases while we increasing the concentration of the dopant. So, okay, so not only the thermal stability increases, but also so the corresponding to the melting point of the material is also increases. That means the melting point of the pure is 229 and the another one is the 230 and third one is the 232. Okay, the melting point is also increases. Okay, therefore, so if we increase the concentration to the pure material, at the time the corresponding to the thermal stability and melting point of the material is also increases. That means what I say, the quality of the material will that means improved. And also, so the peak nature of the material is also varied. So which shows that means the crystalline will be increasing the concentration. Okay, that means the concentration, okay, is main material is mainly the nature of the material. Okay, the another one is the mechanical properties. The first one structural property, and second one is the so elemental analysis, and third one is the optical property. So this fourth one is the mechanical property. Here we are going to check the mechanical stability of the material. Okay, here so the grown material have taken and then polished, washed and kept in the index, and then applying the load, okay, from 20 kilogram to the so 200 kilogram. Okay, so and also measure, so that is the hardness number by increasing the applied load on the surface of the material. Okay, so while we increasing the load on the surface of the particular material, at the time the corresponding to the hardness number of the material increases. Okay, so beyond the 200 gram of the load on the surface of the material, the crack was developed on the surface. That means what I say, so this is the material which is very useful to use in the particular device application only below 200 kilogram of the load. Okay, and also checked, so the corresponding to the hardness number of the material is increases while we increasing the concentration of the dopant. Okay, so that is the nature of the material. And also, so that is the drawn the graph between, so that is a logarithmic value of the load and then logarithmic value of, so that is the D, that means hardness number. Here, so that is the hardness number is increases, and from this particular graph we have estimated the work hardening coefficient of the material, okay, by taking the plot. Okay, that means by taking the slope, okay, so the inverse square of the slope, so clearly express, so the n values. The n is the work hardening value. Okay, the work hardening value of the grown material is 2.018, 2.029, and 2.123. Okay, so these are the values. So these values are clearly expressed that the grown material belongs to the nature of the soft in nature. Okay, by that is the concept of anstitch. Okay, suppose if the n values lies between 1 and 6, so at the time we say the grown material belongs to the category of hard in nature. Suppose if the value is greater than 1.6 means, so at the time we clearly express that the grown material is soft in nature. Therefore, from this concept, we confirmed that the grown material values above the 1.6 value. Therefore, we conclude that the grown material belongs to the category of soft in nature. Okay, here this is the very, very important property for NLO material. Okay, the another one is the photoconductivity study. So this is the very, very important study. So by using this study, okay, we can estimate, so that is the photosensitivity value of the particular material. Here we have used the halogen source to determine, so that is the photosensitivity value. The photosensitivity value determined by using this formula, the difference of, so that is the darkened photocurrent and divided by the dark current. That means what I say, so the photosensitivity is defined as, so the ratio between the difference of the two currents, that means darkened photocurrent and the dark current. Okay, here the load is applied on the surface of the material, and then the determine the corresponding the current generation. Okay, so the current generation is increases while we increasing the load on the surface of the material. Okay, so there are two currents have determined. One is the photocurrent and another one is the dark current. The dark current is linearly increasing than the photocurrent. So, and also estimated, okay, so in the case of 1 mole percentage and 2 mole percentage, okay, so the 2 mole percentage nature is so very, very that is the more than some other 1 mole percentage and 2 mole percentage of the material. Okay, so the calculated the photosensitivity value of the pure and 1 mole percentage, 2 mole percentage of Mg2 plus ion doped materials are 0.10, 0.471, 47 and 0.71. So this is very more. So therefore we conclude that this is the quality material. Okay, but that means that the concentration of the dopant increase it's the quality of the material. Okay, the another study is the very, very important, the confirmation study. So that is the third harmonic generation, that is Z-scan studies. By using the studies, we can easily estimate so the nonlinear refractive index of the material, nonlinear absorption coefficient, nonlinear susceptibility. Okay, so these three are important parameters how determined by using the Z-scan instrument. Okay, so here, so these are the graph and position value. All those things are varied while we increasing or changing the concentration of the dopant. Okay, so here we determined the values of susceptibility. So this is the susceptibility value. The susceptibility value of so the doped material, that means 2 mole percentage of the ion concentration is very more compared to the previous one. Okay, and also the nonlinear absorption values and the nonlinear refractive index value. Okay, so everything were varied, okay, while varying the values of the dopant in the pure parent material. So this is another important property. Okay, so this is also the LDDT analysis. So laser damage threshold analysis. So this is very, very, very important analysis. by using the analysis, we can easily check the optical stability of the particular material. Okay, so that is the based on the industrial application and laser material fabrication, we can easily express the important value as that is the stability value, okay, of the grown material. Okay, here if we pass so that is the radiation on the particular material, so the grown sulfamic acid and 1 mole percentage doped sulfamic acid and 2 mole percentage sulfamic acid, at the time we estimated, so that is the LDDT value, laser damage threshold value of this material. That material value is compared with so KDP value, so that value is very more, that means increased, so that is the that means the LDT value have the greater than so that is the KDP value. So these are the estimated value. So that is 17.72, 27.42, and 55.16, 57.32. Okay, that means KDP and pure and 1 mole percentage and 2 mole percentage of so sulfamic acid material. Compared to the KDP, so this material value is very higher. Okay, and then especially the 2 mole percentage doped material is very more compared to the so previous one. Okay, that means so 1 mole and pure material. Okay, so this is these are the applications. Okay, the NLO material used in the various fields of application, we know already. So without crystal, there is no industry. So without crystal, there is no any kind of the industry. That means if there is no electronic crystal, there is no electronic industry. If there is no, so that is the laser crystal, there is no laser industry. Okay, so there is no the optical crystal, there is no optical industry. Okay, all the industries is fully depends upon the crystalline material. Okay, so the crystalline material decides the applications. Okay, based on that, here I am going to concentrate only the optical applications. Okay, so what are the optical application? Okay, so there are so many crystals are having a second harmonic generation. That is the second harmonic generation of the material is efficiency of the material is very more. Okay, based on that, okay, the second harmonic generation efficiency crystal is mainly used in laser pointer. Okay, that means solid state frequency doubled. Okay, medical scanning technique, that is the endocardial detection, wavelength and frequency conversion laser system. Okay, so and so this is the laser pointer. Okay, laser pointer, the green laser pointer here. So that is this is the construction of the green laser pointer. So in this particular point, the peoples are using the KDP or YAK, the crystal for second harm, that is the frequency doubling. That means increase the radiation energy and also lower, that is the wavelength of the material. So this is the important of non-linear optical crystal. Okay, the another one is the third harmonic generation crystal. Okay, here the peoples are using only titanium sapphire laser. So with the wavelength range between 920 and 960 nanometer, so which will be tripled, okay, by using this laser. So that kind of the material is mainly used. Okay, ozone sensing between so 308 and 320 nanometer, and OH and SO2 sensing between 308 nanometer and 300 nanometer, and biological detection, okay, about in the order of 290 nanometers. So these are only the specific application for frequency doubling and frequency tripling applications. Okay, so these are the things. Okay, so therefore we conclude that so that is the non-linear optical material play a vital role in various fields of applications, that is optoelectronic and photonic device applications. Okay, so thank you for giving this wonderful opportunity. Thank you. Hello.
Sir?
Madam,
thank you, sir. Sharp.
within half an hour.
கரெக்டா ஷார்ப்பா டைம் பார்த்துட்டே முடிச்சிட்டீங்களா?
முடிச்சிட்டீங்க மேடம். ஓகே.
Thank you, sir.
Okay, okay. Thank you,
for your
madam.
informative speech, sir. Sir.
Okay, ma'am. Thank you, madam.
Okay, sir. Thank you, sir. Thank you, sir. Any questions, dear participants? Any questions? ஸ்டூடண்ட்ஸ் எல்லாம் அந்த யூடியூப் லிங்க்ல இருக்கிறதுனால அங்க இருக்காங்க சார். மெயில் ஐடி அப்படியே டிஸ்ப்ளே பண்ணிருக்கேன் சார்.
Okay.
அவங்க ஏதாவதுனா இது
Okay, okay. Thank you, madam. Thank you. Okay.
Okay.
So you can proceed.
Okay, sir. Thank you, sir.
Thank you for giving this wonderful opportunity to share my views and ideas. Thank you.
Thank you.
Thank you, madam.
Sir, please join in the validatory function, sir.
Okay, okay, madam. Professor Venkatram Reddy, vanakkam. Sir, vanakkam. How are you?
Sir, dear Professor Venkatram Reddy, sir. Good afternoon, sir.
Hello. Please unmute yourself. Professor. Yeah. How are you, sir?
Yeah, good afternoon, sir.
Good afternoon, sir. Vanakkam.
Namaste.
Sir.
Sir, good afternoon, sir.
I am very much happy
very good
to
afternoon,
see.
madam. Yeah.
Good afternoon, sir. How are you, sir?
Fine, madam.
Okay, sir. Thank you, sir. Sir, shall we start, sir?
Sure, go ahead. No problem.
Okay, sir. Okay, sir.
Good afternoon to one and all. If you are working on something exciting that you really care about, you don't have to be pushed. Your vision will push you. Here, with a fabulous personality, the most respected Dr. Venkatram Reddy Baidu sir from Kakatiya University, Warangal, whose vision is on the synthesis, evaluation of molecular structure from torsional scans and study of molecular characteristics using spectroscopic and DFT methods of some thiosemicarbonzones and investigation of their anti-cancer activity. Now, I call upon Mrs. P. Vijayalakshmi ma'am, Assistant Professor, to introduce our eminent professor. Thank you.
Good evening to one and all present here. First of all, I convey my heartfelt thanks to our department to giving this chance to talk about Professor Bairu Venkatram Reddy sir. He was born in 20th October 1966. Professor Bairu Venkatram Reddy sir have been completed BSc in Osmania University and followed by completed MSc in Kakatiya University in 1989. He has been completed BEd from Kakatiya University and followed by PhD also completed in Kakatiya University in 1992. He has the 32 years experience in teaching and research. He is interested in domain of molecular spectroscopy, DFT computations and material science. He also published 40 research papers, that is 35 international journals and 5 national journals. Totally 6 candidates doing PhD under the guidance of Professor Bairu Venkatram Reddy sir. Professor Bairu Venkatram Reddy sir is reviewer for repeated journals like RSC Advances, Elsevier Publishers, Taylor and Francis Springers. He has attended 46 conferences and seminars. He have been completed one project is vibrational and spectroscopy investigations and density, which is funded by UGC. The cost of project is 11.45 lakhs. He got the award in ISPA Dr. Gunasekaran Sir Award 2020 from Indian Spectrophysicist Association, Chennai, India. Recognized as outstanding reviewer by Elsevier Publishers for J molecular structure, and he is a free membership in ACS Publishers. Thank you, one and all.
Okay. Now I invite Dr. Venkatrami Reddy sir to deliver his talk.
Okay. So good afternoon, one and all. Most respected.
Sir, you are.
Yeah. Am I audible to you?
Yes, sir. Yes, sir.
Okay. Now I am sharing my screen.
Sir.
So just a minute.
Yes, sir. Yes, sir.
Is it visible?
Yes, sir. Visible, sir.
My PowerPoint presentation is visible to you?
Sir, visible, sir.
Okay.
Visible,
Right.
sir.
Right.
Sir, please enlarge your.
Yeah, I'm doing that.
Okay, okay. Sir.
Is it okay now?
Yes, sir. Okay, sir. Okay, sir.
Right.
Nice, sir.
So good afternoon, one and all. Most respected conference president and ISPA founder president, Dean Research Council, Professor Gunasekaran Garu, and convener of this international virtual conference on physics of emerging materials and molecules, Dr. Arvi Selvi, and management of SVM College, Utangarai, respected invited speakers and participants of this conference. Good afternoon, one and all. So let me thank Dr. Gunasekaran and the organizers of this conference for having given this opportunity to interact with you all this afternoon. And I also thank for giving me an opportunity to deliver a talk on the molecules which have been carried out at our lab, and also take this opportunity to convey my warm greetings to the awardee of Lifetime Achievement Award, Dr. Dhananjaya Garu, Vice Chancellor, St. Peter University, and ISPA Gunasekaran awardee. So I congratulate both of these awardees from bottom of my heart. And earlier talks I have heard before this, the talks were on materials. So my talk deals with synthesis, molecular structure from torsional scans, study of vibrational molecular characteristics using spectroscopic and DFT methods of some thiosemicarbozones and investigation of their anti-cancer activity. So before going to details of this talk, let me tell my outline of this talk goes this way. So I would like to talk upon the spectroscopic techniques, computational methods, biomolecules investigated so far in our lab. So the present study, what we are dealing and what I am presenting in this session, and synthesis, experimental details, computational details, geometry optimization, analysis of NMR spectra, and molecular characteristics of the human molecules, anti-cancer activity, vibrational assignments, and acknowledgements. So before going to into details of this talk, if you look at the previous days or previous years, when we work on a certain molecule and to make vibration analysis, we used to depend on the experimental aspects. But as emphasized by Führer et al., the assignment of vibrational frequencies should at least be assisted by some computational techniques. So there are continuous work and research is going on to explore a better method for making this vibrational assignment on theoretical basis. So in that attempt, so during the past 4 decades, the quantum chemists have been trying hard to develop a priori method of predicting the vibrational frequencies of a given molecule. So in this process, 2 different and distinct methods have been explored, namely experimental and theoretical have been developed. So in experimental approach, we have, just a second, I'm moving this. Okay, yeah. So in computational methods, we have 2 approaches. In experimental approach, which was derived from classical mechanics, follows the overlay technique, wherein a set of molecules is treated together by solving inverse vibrational problem. Whereas in theoretical approach, which comprises of ab initio computations refined to include density functional theory. So DFT is being paid much attention by many quantum chemists, and much effort has been devoted to refine the methodology and exploring its applicability. However, the vibrational frequencies that are computed in ab initio calculations are higher than the corresponding experimental frequencies, especially when we deal with the relatively big molecules. So this overestimation is due to the use of finite basis set, incomplete implementation of the electronic correlation, and the neglect of unharmonicity effects. So let me tell what is the basis set, which we frequently come across this basis set when we are doing computations in DFT. So a basis set is a set of functions centered on atoms used to create the molecular orbitals. But in finite basis set, these functions can't represent exactly the atomic orbitals, since they are approximated and simplified from analytical formulae only. Smallest basis set, that is minimal basis set, uses a single basis function on each atom in the molecule in Hartree-Fock calculations. So the functions that we deal in these computations are split valence, polarization, diffusion, etc. So what do you mean by electron correlation? Because this is one of the cause or the reason to have much difference between the experimental and the calculated values. The electron correlation is the interaction between the electrons in the electronic structure of a quantum system. The correlation energy is a measure of the movement of one electron under the influence of all other electrons in that system. So in Hartree-Fock calculations, the antisymmetric wave function is approximated by a single slat determinant which cannot take Coulomb correlation into account. So this is the main reason why the electron correlation causes to have more difference between the experimental and calculated values, because in this approximation the Coulomb repulsion or Coulomb correlation will not be taken into account, so which lead to total electronic energy different from the exact solution. Hence Hartree-Fock limit is always above the exact energy. So this difference is called the correlation energy. So if we look at this picture, we have a correlation energy which is drawn along the y-axis as relativistic energy, exact solution of non-relativistic Schrodinger equation, post-Hartree-Fock methods, Hartree-Fock limit, and Hartree-Fock energy. So what I mean to say is the electron correlation energy is nothing but the difference between the Hartree-Fock limit and exact solution. So when we look at the exact solution from which we get the energy of the electrons will be lower than the Hartree-Fock limit. So when the Coulomb interaction is also taken into consideration, then the Hartree-Fock limit will be the above the value of the exact energy which has been computed using this non-relativistic Schrodinger equation. And another reason that introduces the error between the experimental and the calculated values is the unharmonicity effects. So if we see the potential energy versus intermolecular distance, so there are two curves which will be understood that one is the molecules are too close or too far away, they experience a restoring force. This restoring force will always try to bring the molecules together when they are separated, such that they bring back to its potential energy, that is U naught. And here the blue curve is close in shape to the molecule's actual potential well, whereas the red curve, which is appeared to be parabola, is a good approximation for small oscillations. So when we consider that the oscillations are the vibrations of a molecule to the smaller amplitude, then we can approximate that potential well will be a harmonic oscillator which appears to be a square well potential. The red approximation treats the molecule as an harmonic oscillator because the restoring force is minus V dash U is linear with respect to the displacement. So if we look at the variation of this potential energy as a function of displacement, the variation will be linear. That's why for small oscillations, we can consider that the potential energy curve is a harmonic oscillator. So these three, one is basis set, second one is electron correlation, and third one is unharmonicity effect. If these three reasons are taken into consideration, by introducing some other methods incorporating into the ab initio calculations in the way that DFT computations have improved such that the difference between the experimental values and the calculated values are to be small. So when these three effects have been taken care, that difference was taken to smaller values. And DFT calculations incorporated into ab initio method have shown that the computed vibrational spectra and their intensities of many organic molecules agree reasonably well with experimental results in scaling. So in scaling process, the ab initio force fields are scaled using spectroscopic data by scaled quantum mechanical procedure proposed by Poulet and modified by Sundis with his Molvi program for getting better agreement between the observed and calculated frequency. So as I told you that when these three basis set, finite basis set, electron correlation and unharnessed effects were taken into consideration, accordingly, the Poulet has proposed a procedure based on the scaled quantum mechanical process, and that theory was coded by a program by Sundis with his Molvi program. So when we run this Molvi program, we can scale these vibrational frequencies and we can bring or we can make the difference between observed and the calculated values to be within the limit, and we can see in the literature when we are dealing with the DFT calculations, the difference between the observed and calculated frequencies will be not more than 10 wave numbers. That happened because of this development of computational methods which have been incorporated into DFT calculations by following the procedure adopted proposed by Poulet, and program has been designed by Sundis so that we can able to have the smaller difference between the two values. And here the significance and what is the impact of DFT computations, we can realize in the literature that DFT is presently the most successful and also most promising approach to compute the electronic structure of matter. Its applicability ranges from atoms, molecules, and to solids. DFT predicts a great variety of molecular characteristics like molecular structure, vibrational frequencies, atomization energies, ionization energies, electric and magnetic properties, NLO behavior, homolume energy, thermodynamic parameters, NBO energy. So all these vibrational and molecular characteristics can be studied for a given molecule by applying the DFT at different functionals and at different basis sets. So we choose a particular basis set of a particular functional depending on the molecule that we are going to deal with them, whether it's a smaller molecule or a big molecule. Big molecule means whether the molecule contains a large number of atoms. So likewise, we can choose the most optimum, most appropriate functional group, most appropriate basis set, which is much suitable for the given molecule which is under investigation. And the molecule that we have investigated so far in our lab at our university, we have carried out the research, and they were published in good reputed international journals like Journal of Molecular Structure, Molecular Simulation, and most of the work has been published in elsewhere publishers, particularly Journal of Molecular Structure. And molecules that we dealt so far are dihydroxytoluenes, dimethyl bipyridines, biphenyl carboxyaldehydes, bipyridine dicarboxylic acids, pentafluoro and pentabromophenol, pentachloro-pentachlorothiophenols, pyridyl acetonitriles, picolinic and isotonic acids, halogenated acido phenylethanons, bipyridines, pyridine carboxylic acid. So these are some molecules which have been investigated in our laboratory applying the DFT computations. And with the motivation attained from these computations or calculations, now we thought it worthwhile to extend the same investigation to two more heterocyclic thiosemi-carboxysomes, namely 2-aminopyridine 3L methylene hydrogen carbothioamide, and the second one is 2,2-aminopyridine 3L methylene N-methyl hydrogen carbothioamide. So results of these two molecules are now being presented in this talk. And the molecule that we have chosen, and among these two molecules, the first one was synthesized in our group. Particularly, we have a collaborator in NIT Warangal. So our collaborator have synthesized these molecules, and these are the molecules which are synthesized, and we can see that the pyridine group or pyridine ring has been added with some chain like NH2, CH, N15, N16, H7 like that. So we have these two molecules which have been carried out for their vibrational characteristics, for their molecular structure, and for their molecular characteristics. And these results have been communicated, and we soon this paper be published in a reputed journal in a week or so. And it is under revision, final revision, and we may get this as a publication very shortly. And the significance of these molecules, these heterocyclic thiosemicarbozones are known for their therapeutic value and biological activity, such as anti-tumor, anti-convulsant, antifungal, anti-inflammatory, antibacterial, anti-tuberculosis, antiviral, analgesic, and HIV/TB co-infection effects. And they also found to inhibit a host of viral infections such as adenovirus, rhinovirus, herpes virus, poliovirus, and RNA tumor virus. So these are very significant in anti-cancer activities or biological activities. They are very significant. And objectives of this present work that we have carried out, they have been chosen to synthesize and to make elemental analysis and record proton and carbon spectra, carbon NMR spectra, to measure UV visual spectra, and to measure anti-cancer activity, and also to make DFT analysis for both molecules in order to make torsional potential scans to get preliminary values of dihedral angles around rotating bonds, make geometry optimization, simulate UV visual spectra to compare them with the corresponding experimental spectra to find the nonlinear optical properties, frontier molecular orbital parameters, and natural bond orbital characteristics. In the previous two lectures, our eminent speakers have spoke on the nonlinear optical properties which have been dealt by them experimentally, and my talk deals with the study of nonlinear optical properties theoretically. So when compare the results of a nonlinear optical study of any property, any material or molecule, they can be compared by theoretical approach and as well as experimental approach. But we are confined to do only theoretical approach for this molecule which is under investigation, and that can also be compared with the experimental values. So that those who are doing the study or the investigation of nonlinear optical properties of some materials or molecules, they can correlate those results, those experimental results with the theoretical results that have been obtained by the DFT computations. And the molecule that has been synthesized goes in this way. So here the equimolar ethyl solutions of thiosemicarbazide and 2 amino nicotinoid were mixed together, and 2 ml glacial acetic acid was added to act as a catalyst, and entire mixture was heated at 70 degrees under reflux for 1 hour. The precipitate, yellow in color, was separated by filtration, washed with cold ethanol, and dried under vacuum. So the compound was purified by recrystallization. The yield was about 90%. It melted at 184 degrees centigrade as determined with STUT SMP 30 melting point apparatus. And the experimental details of this work goes like this. In order to ascertain the formation of required compound, elemental analysis was made using Carlo-Erba model EA1108 analytical unit, and NMR spectra was recorded for its proton and carbon on Bruker Avance 400 MHz at room temperature with the NMR instrument using deuterated dimethyl sulfoxide as a solvent and tetramethylsilane as internal standard. And UV visible heater were obtained at room temperature in the range 200 to 400 nanometer in a solution of DMSO D6 with 1 centimeter quartz cell using Perkin-Elmer UV visible lambda double beam spectrometer. And in vitro cancer anti-cancer activity was evaluated against the human cancer cell lines using HEP-G2 for hepatocellular liver carcinoma cell line, Colo 205 colorectal carcinoma cell line, and NC1H46 lung carcinoma cell line provided by National Center for Cell Sciences, Pune, India. And the computational details of the work that has been carried out for these two molecules or the required calculations were made using the Gaussian 09 program for applying to DFT program package. DFT with Becker's 3-parameter hybrid exchange functional B3 in conjunction with Lee-Yong part correlation functional using enlarged basis set 6311 plus GDP was employed for the purpose of this DFT computations for investigating the chosen two molecules. And the important and the starting point for any research work of this type is to obtain the geometry optimization of the given molecule. So this is the starting point for any type of investigation for vibrational or molecular characteristics. One has to get first the geometry optimization or molecular structure of the given molecule. So in order to get chemically meaningful results, DFT geometry optimization should be initiated with the experimental structure data if available or a structure obtained by using theoretical methods. For the first molecule, experimental information is not available. Hence, we have done the torsional potential energy scans or needed to estimate around rotating bonds to get preliminary values of diagonal angles. So if we look at the molecule here. So here the first molecule is basically a pyridine ring to which some functional groups are added. So we have 5 bonds which can be easily rotated. So this is
Sir,
one
excuse
bond.
me, sir.
Yes?
Sorry for the interrupt, sir. Sir,
Yes?
next speaker is waiting, sir.
Okay.
Okay, sir.
So shall I go a little fast?
Okay, sir. Okay. Just to take 5 to 10 minutes, sir, to complete
Right,
the
sure. So this is the first geometry optimization is the starting point for carrying out this type of investigations. So first we need to optimize the structure of the given molecule. So geometry optimization was done initially for the two molecules. So for that we need to calculate the potential energy as a function of diagonal angle. So for this here we have 5 bonds, 5 rotating bonds, and we can take first any 2 bonds and one will be fixed for say 10 degrees and other one will be rotated in the steps of 10 degrees from 0 to 180 degrees. So like that, if I fix one bond at 0 degrees and this bond can be rotated in steps of 10 degrees from 0 to 180 degrees, like that I get 18 values for potential energy, and again then I increase this bond to 20 degrees, 10 degrees. So likewise, we have 5 free rotation bonds. Like this, we can calculate the potential energy as a function of diagonal angle, and the structure with which we have the lowest minimum energy or minimum energy for the molecule will be the most optimized molecular structure for that particular molecule. So likewise, we can ascertain the molecular structure of the molecule for which it has the lowest energy will be the optimized molecular structure. So that is being done by scanning potential energy curves which can be drawn between potential energy versus diagonal angle. And so these are the curves that have been drawn for different bonds of the two molecules. And here this is energy, relative energy, and this is diagonal angle. So if we look at here, so the minimum energy is obtained at around 0 or 180, and here it is around 180 degrees, and here 160 degrees. So like that, for different bonds at different diagonal angles, we get the minimum energy, and all together we get the molecular structure in optimization or geometrical optimization that has the more stable structure for the given molecule. And after optimization, we get the structure of the two molecules like this. And once the structure is optimized, then we go for other calculations for either vibrational characteristics or vibrational frequencies or molecular characteristics like FMO, that is frontier molecular orbitals, which means that HOMO and LUMO energy, NLO properties, NBO analysis, and etc. can be obtained from this optimized molecular structure. And from the analysis of NMR spectra to analyze its elements, we have taken the protein NMR spectra and as well as carbon NMR spectrum for the both molecules to ascertain the elements that are present in the synthesized molecule. And here two signals which are deviated, which are away from the regular values of the elements of carbon, sorry, a proton. We have got 3.426 and 2.562 ppm. These two values belong to the chemical shifts of hydrogen atoms present in DMSO solvent, and they are not at all, they won't belong to the synthesized molecule. And this carbon NMR spectra of the molecule, and it's also important to study the hydrogen bonding among the different hydrogens and nitrogen, etc., etc. So these hydrogen bonding were also evaluated, and they were compared with the existing values in the literature, and they are found to be very close to the experimental values that have been available in the literature. And this is another important molecular characteristic of the molecules, that is NLO behavior. So NLO behavior of any molecule can also be studied theoretically just by DFT computations, and that can be obtained. So the behavior of a molecule, whether they are suitable or whether they are applicable for growing the NLO crystals, can be investigated by determining the molecular dipole moment and also mean first order hyperposolability. If we are able to determine these two values by taking the values of these two for the each molecule and then comparing with the values of urea, and if the values of this dipole moment and first order hyperpolarity values greater than the standard values of urea, then we can say that the particular molecule can be grown to apply for NLO crystals or NLO materials. So the theoretical approach says that if we are able to find the dipole moment and first order hyperpolarity, if these two values are greater than the standard values of urea, then we can say that the particular molecule can be suitable for growing NLO crystals or NLO materials. And this is U visible spectra and frontier molecular orbitals, and you know that HOMO and LUMO, highest occupied molecular orbital and lowest unoccupied molecular orbital. The difference of these two molecular orbitals will give us an important information regarding their chemical stability, etc., etc. And these values have been calculated and also investigated what type of electronic transition has been taken place. We have got two absorptions at 355 and 299 nanometers, and these two absorption lines are due to the electron transitions that belong to N2 pi star and pi 2 pi star excitations. And chemical reactivity can also be studied from the frontier molecular orbitals, that is study of HOMO and LUMO energies. So the energy gap between HOMO and LUMO orbital energy is estimated as 2.0267 electron volt in both molecules. So these comparatively low values are the characteristic feature of conjugated molecules, which causes high chemical reactivity as it is energetically favorable to accumulate electrons in high-lying LUMO by exciting electrons from low-lying HOMO. Moreover, a molecule with small frontier orbital gap is easily polarizable and usually shows high chemical reactivity and low kinetic stability. Further, this chemical potential for the molecules being studied is negative, hence the two molecules are stable also. So anti-cancer activity of the two molecules which have been synthesized in the lab, they are in vitro percentage cell viability in APHT and APMHT compared with that of standard cisplatin. So cisplatin drug is taken as a standard. Whenever we study anti-cancer activity of a molecule or a compound, we will generally compare the activities of this with the cisplatin at various concentration for human carcinoma cell lines, that is HEPG2, Polo 205, and NCIH460. These four cell lines will be able to understand whether they act against cancer or not. So the linear regression curves have been drawn using the software, and we have found that the two molecules are acting as anti-cancer activity, but the efficiency is not much greater than the standard cisplatin. But though they have ability to work against anti-cancer, but they are not, the efficiency is not more than the cisplatin. Yes, so I'm concluding, last one. 2 minutes.
Thank you, sir. Okay, sir. Thank you, sir.
So as per geometry optimization, both molecules fall under C1 point rule symmetry, and there are 60 and 69 vibrations. All these vibrations are active in both Raman and IR since the molecules possess C1 symmetry, and the measured IR Raman fundamentals corresponding to scaled and unscaled frequencies will be much small difference, and this has been made using the potential distribution. Vibration assignments in Wilson notation have been shown in the results, and these are IR and Raman spectra of both molecules. And so vibration assignment have been shown that the difference between the two will be very small, so that the structure that has been optimized is the reliable. And the conclusion is that molecular structure for both molecules has been suggested using potential scans. Barrier heights have been determined. Both the theoretical and experimental geometry parameters have been compared and they found good. Theory predicts that the existence of intermolecular hydrogen bonding, and both fall under C1 point rule symmetry. All fundamentals of both APHT and APMHT are assigned unambiguously, and there is a good agreement between the experimental and estimated frequencies. Both are good for nonlinear optical applications, and both molecules possess anti-cancer activity against human carcinoma cell lines, which is not as effective as that of standard drug cisplatin. However, both molecules is a better anti-cancer agent in comparison with APMHT. And my acknowledgement due to Professor Ramana Rao, who was my guru, and my collaborator, Professor Lakshma Reddy Garu, collaborator from NIT Varangal, and also acknowledge my research scholars, Dr. Ramaya, Sri Shalam, who made contribution in carrying out this research work. So thank you all for having this opportunity to present my talk on this international conference on physics of emerging materials and molecules. Thank you all.
Thank you, sir.
I invite any doubt and queries, let me answer for it.
Dear participants, if you have any doubt, please clarify.
Okay.
Okay, sir. Sir?
Yeah.
Excuse me, sir. Sir, if you are free, yes, can you join in the validatory function, sir?
By what time should I be there?
3:30, sir. Sharply 3:30 or 3:35.
I'll try.
Okay, sir. Okay, sir. Thank you, sir.
Okay.
Okay, sir. Thank you, sir.
Thank you so much.
Thank you, sir. Professor Suresh Shagadevan, sir. Good
Yes,
evening,
ma'am.
sir. Good evening, sir.
Good evening. How are you?
How are you, sir?
Yeah, I'm good. What about you?
Sir, I am good, sir.
Okay, sorry. Actually, I was busy with many meetings and lectures. I could not respond to you. Sorry.
Sir, no issue, sir. No issue.
Okay, thank you.
Okay, sir. Sir, shall I start, sir? Shall I start?
Yeah, sure.
Hey, sir. Welcome.
Hello, sir. How are you?
How are you?
Hello, Pandyan, sir. Yeah, very nice talk. அது ஆரம்பமே பயங்கரமா இருந்துச்சு. As usual.
Thank you, thank you, thank
Okay,
you.
thank you. Yeah. சார் எங்க இருக்காரு? குணசேகரன் சார்.
சார் இருக்காரு, லைன்ல இல்லன்னு நினைக்கிறேன்.
சார் இன்னும் சார் 2 minutesல ஜாயின் பண்ணிருப்பாரு சார்.
Okay, okay ma'am. Okay, no problem.
Sir is in traveling sir.
Okay.
The impact of nanotechnology is expected to exceed the impact that the electronics revolution has had on our lives. Now, in our last session, we have an eminent resource person, Dr. Suresh Sagadevan sir, University of Malaya, Malaysia, going to discuss about the metal oxide nanostructure for photocatalytic applications. Now, I call upon Dr. S. Cholan sir, Assistant Professor, to give short intro about the eminent professor.
I did not give my profile. Can you hear me?
All of you, good evening. I am happy to introduce the Dr. Suresh sir, currently working as a senior research fellow in Nanotechnology Catalyst and Research Center, University of Malaya. He has visiting professor in National Defense University of Malaysia and also the Department of Physics, the Bangladesh University of Engineering and Technology. He has written the 8 international books and also published more than 225 papers in the international reputed journal. His field of research is semiconductor material, crystal growth, thin film, and etc. He is the editorial board member, the review for the various journals. He was the award by optics in LCR journals. His Google citations, the 2092 H index value is 20, I-10 index is 62. Thank you, sir. Once again, the welcome you, sir.
Okay, thank you. Thank you for nice introduction about me. So can I?
Thank you, Dr. Cholan sir, for the introduction.
So
now I invite Dr. Suresh Sagadevan sir to deliver his talk.
Yeah. Can I share my slide? Screen share.
Sir?
Yeah. Your time. Yes, how can I share?
Sir, please.
Hello.
Sir?
Yeah, can you see my slides?
Yes, sir. Yes, sir.
It's visible?
Visible, sir. Visible, sir.
Okay.
Okay, sir. Okay.
Good afternoon, one and all. I'm very happy to join the International Virtual Conference on Physics of Emerging Materials and Molecules organized by PG and Research Department of Physics, Sri Vidya Mandir Arts and Science College, Uthangarai, Tamil Nadu, India, in collaboration with Indian Spectrophysics Association, Chennai. I would like to first congratulate the organizing team for the excellent arrangement for this international virtual conference. At the outset, I would like to thank the management, principal, convener, organizing secretary, committee members, faculty members from Department of Physics, Sri Vidya Mandiri Arts and Science College, for giving me the opportunity to deliver the talk in the international virtual conference. I must mention my deep sense of gratitude to Professor Dr. S. Gunasekharan sir, President of ISPA, Dean R&D, St. Peter's University, Avadi, for continuous support and advice, which have greatly helped me towards research and academic. I should thank to Professor Dr. S. Gunasekharan sir for his great support and giving this opportunity. I would like to recognize and respect all the professors, research scholars, students, and the participants from the various institutions to this occasion. I hope that the participants have benefited by attending all the section for the following 2 days of this international virtual conference. This is the final section of this 2 days international virtual conference. Today, I'm going to talk about metal oxide, especially cobalt oxide nanostructure for electrochemical and photocatalytic applications. Modern science and technology have made the life of human beings very comfortable, but at the same time, they have caused the demand for energy to increase. These issues have prompted the research for green and sustainable alternative energy conversion as well as energy storage devices. In the recent years, the increased interest with the nanostructure metal oxide due to their high surface areas which support different properties like thermal, mechanical, electrical, and optical, made them to include in the development of optical, electronic, and sensing devices. With that view, the transition metal oxide nanoparticle are found to be very efficient and among many different kinds. The cobalt oxide nanostructure exhibit interesting properties that can be suitable for lithium storage, gas sensing, and electrocatalysis. Previous lecture, Professor Jipan Podas explained, briefly explained about the cobalt oxide properties and applications. The most stable phase of cobalt oxide nanostructure with a direct band gap of 1.48 to 2.19 electron volt is used as a P-type semiconductor and received the considerable attention. The current scenario, depletion of non-renewable energy resource and pollutions. So need to utilize the renewable energy resource for greenery environment. So solar energy is the most powerful renewable energy resource. So photocatalysis is needed to harvest the solar energy. Therefore, the high performance of nanomaterials as a photocatalysis due to the increased surface area to volume ratio. Electrochemical applications. What is a sensor? A sensor is nothing but the device that detects and responds to some type of input from the physical environment. Sensor can be used for different applications, especially in industry. We focused on that electrochemical sensors. Electrochemical sensors are the detectors that measure the concentration of your target molecules by oxidizing or reducing them at an electrode surface and measuring the resulting current. You can see here the transducers. When you send that electrochemical signal, we can observe that any toxic gases or any toxicities. So we developed electrochemical sensor in our laboratory. There are two methods, the analytical approaches. One is a spectroscopic method, another one is electrochemical method. Here we chosen for the electrochemical method, we followed the following steps: sensitivity, selectivity, response time, and sensor size, and then inexpensive fabrication and operations. You can see the electrode material. Electrode material plays a vital role in different technological applications like electrochemical sensor, supercapacitors, fuel cell, lithium-ion batteries, solar cell, etc. There are two electrodes we used as a metal and metal oxide. This metal like gold, silver, platinum. Why? Because the reason is it is a sensitivity, stability, selectivity, high conductivity, and then high electrocatalytic activity. And metal oxide is like cobalt oxide, tin oxide, titanium oxide, iron oxide, nickel oxide, manganese oxide, zinc oxide. Because it's a low cost, facial synthesis, it is a durability, it has a diverse morphology, and also it can be used for multiple applications. Objectives of my talk to investigations optimize the parameter for synthesis of different morphology of metal oxide, cobalt oxide nanostructures. And the deposition of metal nanoparticle, the platinum, to deposit the metal nanoparticle on the surface of metal oxide to enhance the electrocatalytic performance of electrode materials. And then finally, electrochemical sensor application and photocatalytic activity application to investigate the performance of electrode material for this detection of target molecules. Why we chosen for cobalt oxide? What is the motivation for that? The reason is among us the laboratory of many metal oxide, which already have been exploited for sensing applications of cobalt oxide, attracted intensive interest of these researchers because the reason is diverse morphology and high theoretical capacity, simple preparation method, we can prepare a very simple technique, high catalytic activity, and applicability in electrocatalysis. That is our motivation. So how to prepare these cobalt oxide nanostructures? We used hydrothermal synthesis method. Generally, hydrothermal synthesis is highly prepared because of its potential advantage, such as it is a cost-effective, single-step and one-part method, highly crystalline to produce highly crystalline material and high yield. An appropriate amount of powder reagents and water are placed in the Teflon-lined autoclave. It can be heated without stirring from moderate to high temperatures and pressures for the desired time. Also, the problem of the impurities can be overcome by varying the ratios of precursors in the hydrothermal synthesis. So based on this hydrothermal synthesis, we used to prepare cobalt oxide nanostructures. One of my students synthesized the cobalt oxide nanostructure by single-step hydrothermal route. Initially, 100 ml of capacity of Teflon-lined stainless steel autoclave was used to prepare these all morphologies at different times, temperatures, and reducing agent. In the general synthesis procedure, we used as a cobalt acetate tetrahydrate as a precursor was dissolved in double distilled ionized water, followed by drop-wise addition of reducing agents such as ethanol, ammonia, urea, and sodium hydroxide under the constant stirring. The whole reactions mixture was maintained the 75 ml by adding double distilled water and kept under the constant stirring for 1 hour. The above mixture was then transferred into the Teflon-lined autoclave for the hydrothermal reactions at specified time and temperature. Here is very important is the pressure and temperature in this technique. So the precipitates were collected after the hydrothermal reaction and washed with the double distilled water and ethanol using a centrifuge followed by drying in a hot air oven at 60 degrees Celsius for 12 hours. You can see very quite interesting for this different morphologies observed at the different parameters. You can see here the concentration of cobalt precursor we use is constant 2 mm, but that reaction temperatures we varied. If you preparing for nano cubes, we used as a 180 degrees Celsius. The reaction time is 12 hours. We used as a capping agent. The reducing agent is 15 ml of ammonia. That means 6%. The shape of nano wires, the concentration is 2 mm, but reaction temperature is 150 degrees Celsius. The reaction time is 5 hours. So the 30 ml of ethanol we used and 3 mmol mole urea also we added. So we observed, we obtained the nano wires. And nano flakes we used as a temperature, the reaction temperature is 150 degrees Celsius, the reaction time 15 hours. So the 13 ml of NaOH solutions we added with the 2 ml of ammonia. Nanoflowers morphologies we observed at 180 degrees Celsius for 12 hours of reaction time. The 30 ml of ethanol and 50 ml of ammonia was used. So this work recently, last year we published in International Journal of Hydrogen Energy. Our approach is two different, different morphologies of cobalt oxide nanostructures synthesized by hydrothermal method, like nanocubes, nanowires, nanoflowers, nano bundles, nanoplates. After preparation of these different morphologies, and we characterize that FESM, HATM, XRD, Raman, and electrochemical application, and also photocatalytic activity. First, we done that X-ray diffraction for different morphology of cobalt oxide nanostructures, like nanocubes, nanowires, nanoflakes, and nanoflowers. You can see the figure. All the morphologies indicated well-defined diffraction peaks. Which means you see which could be attributed to the 200 plane, 311, 400, 422, 511, 440 lattice plane of the face-centered cubic cobalt oxide spinel space, and also you can see there is no extra peaks were observed, which means that cobalt oxide nanostructures were synthesized with high purity. All the nanostructures demonstrated well-defined peaks, which confirm that high crystalline nature. So the peak intensities which confirm that crystalline, purity of the sample, and the peak position is represent the crystal structure of this material. So from this X-ray diffractions, we observe that nanocube shows that better crystallinity and purity for compared to others, nanowires and nanoflower and nanoflakes. And then next we have performed this Raman analysis for the prepared sample. The Raman analysis is an important technique to most commonly used for confirm this formation of cobalt oxide nanostructures by different modes of vibrations from this Raman spectra. You can see the Raman figure spectrum, cobalt oxide nanostructures such as the nanocubes, nanowires, nanoflakes, and nanoflowers. From the figure, we can see the sharp and well-defined peaks were observed for all cobalt oxide nanostructures. You can see that EG mode at 195, and then F1 2G mode occurred at 483, and then F2 2G mode occurred at 522, and the sharp intensity peak occurred at A1G mode, respectively. So from this analysis, we confirm that cobalt oxide nanocubes showed that high intensity sharp peaks as compared to the rest of these nanostructures like nanowires, nanoflakes, and nanoflowers. When compared at the same intensity values, hence by confirming that the result were good agreement with the excited data. So you can see it's very quite interesting for the morphological characterization of these cobalt oxide nanostructures. We prepared the sample in different morphologies, nanocubes, nanowires, nanoflakes, and nanoflowers, which is confirmed by SEM analysis, FESM analysis. You can see the figure FESM image of prepared nanostructure of cobalt oxide at different morphologies. The cubical shape of cobalt oxide with uniform particle size, as you can see in the figure. During the hydrothermal synthesis, at the temperature of 180 degrees Celsius for 12 hours, cobalt 2 plus ion was oxidated to its oxidation states with the help of ammonia, which resulted in the cubical growth of the particles. So we, when you adding that ammonia, the formation of this cubicle. However, the nanowires of few hundred nanometer length were formed at lower time and temperature of 150 degrees Celsius and 5 hours as compared with this nanocube. And a few small size of cobalt oxide nanoparticle were also observed, which could be attributed to the initial nucleation of the nanoparticle in the solution phase. Flakes like morphologies were observed as a result of using sodium hydroxide and ammonia solutions under the hydrothermal treatment at 150 degrees Celsius. These nanoflakes were aligned vertically and formed flower-like morphologies when the ethanol and ammonia were used as a directing and reducing agents. So finally, the average diameter of flakes was found to be less than of 1.1 micrometer. You can see here that HRTM image of the nanocubes of cobalt oxide. You can clearly see in that nanocube shape. From this HRTM image, the particle size was calculated to be 22 nanometer using isolation software. And then next is the EDS mapping. You can see the EDS mapping of prepared cobalt oxide nanostructures. From this figure, clearly indicate that element mapping of result of cobalt oxide nanocubes. You can see here the presence of element, oxygen and cobalt. Here, blue color indicates that the presence of oxygen element, and the red indicates the cobalt. The yellow color is labeled as a substrate of which the sample was prepared. And the electrocatalytic reduction of oxygen, the electrocatalytic behavior of the prepared nanostructure for ORR, that means the oxygen reduction of reaction was evaluated in O2 saturated 0.5 mmol KOH using cyclic voltammetric at the scan rate of 50 millivolt per second. You can see the figure shows that CV response of cobalt oxide nanostructures, the modified glassy carbon electrode, GCE. All the cobalt oxide nanostructures modified GCE displayed excellent catalytic response for the ORR. The highest reduction peak current of minus 0.69 milliampere centimeter squared was observed for cobalt oxide nanocubes, followed by cobalt oxide nanowires, nanoflakes, and nanoflowers, which gave the peak current of minus 0.59, minus 0.52, minus 0.42 milliampere centimeter squared, respectively. So the high electrocatalytic response of cobalt oxide nanocube towards this ORR, that means oxygen reduction reactions was due to the smaller particle size and definite structure, which rendered its high surface area to volume ratio is compared to its counterparts. In addition, the highly crystalline nature of these cobalt oxide nanocubes was also responsible for the good catalytic activity. Based on these different morphologies of this CV curve, the nanocube shows that good catalytic activity. So a strong catalytic source is considered to be the spinel type of CO3O4, in which CO2 plus ion and CO3 plus ions occupy the tetrahedral and octahedral sites respectively. And then the electrocatalytic response of cobalt oxide nanocubes, nanocubes was also compared with those of bare glassy carbon electrode and commercially available platinum cathode catalysis. You can see the figure, the CV curves of bare GCE and cobalt oxide nanocubes and platinum cathode modified GCE. The scan rate of 50 millivolt per second as shown in the figure. From the figure, you can see the bare GCE showed a very low reduction peak. The current density at the potential of minus 0.45 due to its poor catalytic response. So, however, the commercial PTC, the platinum cathode modified GCE, give significantly higher peak current density at the potential of minus 0.45, which manifested its good catalytic activity towards the ORR. The highest peak current density of minus 0.69 millimeter of centimeter was observed for cobalt oxide nanocubes modified GCE that gave a higher peak current compared with this bare GCE. So it revealed that ORR was taking the place only in the presence of oxygen. Next, to evaluate the effect of different scan rate of the catalytic activity of cobalt oxide nanocubes, CV curves of cobalt oxide modified GCE were recorded at different scan rate, 25 to 250 millivolts per second in O2 saturated of 0.0 mol of KOAH. There are two figures. The one is the figure A shows that CV curves of cobalt oxide modified GCE at different scan rate, and obvious increase the cathodic peak current was observed with an increasing the scan rate. And the figure B shows the linear relations obtained between the cathodic peak current and the square root of the scan rate, which shows the linear relationship between the scan rate and reduction peak current. So we conclude that this suggests that the ORR of cobalt oxide modified GC is a diffusion control process. And then the selectivity of the fuel cell catalyst is highly important. It is very challenging task to design and select a catalyst having higher selectivity towards ORR. The tolerance of cathode material for methanol is particularly important ORR, and it is an area of great interest. So with methanol and without CH3OH. Therefore, the selectivity of catalysts is highly important for the stability and sustainability of this fuel cell. To evaluate the electrocatalytic tolerance towards the methanol, the CV curve of cobalt oxide modified GCE was recorded in the presence of high concentration of CH3OH in O2 saturated of 0.5 kOH, which is shown in the figure. For the comparison, the CV curves also obtain this absence of methanol and saturated to 0.5 mole of KOH. So from the figure, we observe that there is no significant difference in the both CV curves was observed, even at higher concentration of methanol, which reveal the excellent selectivity of cobalt oxide nanotubes towards the ORR. And the next is, you can see the figure, the current and time curves were recorded to evaluate the stability of as prepared cobalt oxide nanotubes for ORR. The current time curves were obtained, you can see from the figure, in 3000 seconds by applying corresponding to CV peak, the potential as applied of cobalt oxide nanocubes and PTC catalysis electrodes. The cobalt oxide nanocubes modified GC showed the stable current density even after this 3000 seconds. You can see the figure in black color, it is, with very small decreases in current densities, which is comparable to the commercially available platinum cathode catalysis. It is worth to mentioning that the cobalt oxide nanocubes as a semiconductor have performance comparable to high efficient platinum cathode catalysis in terms of stability. So you can from this study we conclude that this cobalt oxide nanocubes material can be explored as a good alternative for noble metal based on that cathode catalysis in the fuel cell reactions. Next, we done the photocatalytic studies for these cobalt oxide nanostructures. In order to test these cobalt oxide nanostructures, two different dyes we used. One is a crystal violet and another one is methyl violet under this visible light irradiation. First figure A and B shows the comparison of UV visible absorption spectrums of methyl violet and crystal violet as a function of irradiation time. From the figure, we observe that the increase of irradiation time from 0 to 45 minutes caused a gradual increases in the degradation as provided by the individual absorptions band and thereby suggesting for cobalt oxide mediated the photodegradation of CV and MU dyes on regular basis. From the figure, the decrease in the absorption intensity with the time for both dyes due to the change in the color of dye solution from blue to colorless with respect to increasing the absorption capacity for every 30 minutes and also indicating for the strong catalytic activity of cobalt oxide nanostructures. Further, we observed that the catalysis showing a linear increases in the absorption of CV and MV dyes under the UV irradiation, and this absorption is due to the smaller crystalline size and enhanced surface area. And the next figure, the photocatalytic degradation of CV and MV dye solution in the presence of cobalt oxide nanostructures were quantified by the ratio CT by C0. Here the CT and C0 is correspond to the initial and final concentration of CV and MV dye solutions. This figure shows that the comparison changes in the CT by C0 ratio as against to the irradiation time for 45 minutes over a period of 45 minutes. And from the graph, we observe that the ratio is getting decreases with regards to increasing the irradiation time. From this figure, we observe that the cobalt oxide nanostructures cause to total decrease of 92% of methyl violet and 64% of crystal violet dye within the first 45 minutes period under the identical conditions. And third figures, these are kinetic studies of CV and MV degradation. From this graph, we calculate the rate constant were determined from this graph R squared value calculated for CV and MV. CV R squared value for 0.9 R squared value is, crystal violet is 0.9959 and methyl violet R squared value is 0.994.
Excuse me, sir.
Yes.
Sir, only 5 minutes is there, sir.
Okay. I will go to conclusion. So the fourth figure shows the photocatalytic degradation efficiency of cobalt oxide nanostructures with changing the irradiation time following the exposure to the CV and the MU dye solution. From this figure indicates that degradation of efficiency of cobalt oxide nanostructures very high for MV dye and against to the CV dye. So finally, the high photocatalytic activity of these cobalt oxide nanostructures due to the recent of the electron that get moved from the valency band to the conduction band to create the hole in the conduction band, and further electron participates in the free radical oxidation reaction to degrade its color. So summary of the work, this study was successfully produced cobalt oxide with the different nanostructures and were tested as a cathode material for ORR, which was prepared by simple one-step hydrothermal method. Prepared cobalt oxide nanostructures were confirmed by IVCPEMM, XRD, Raman, and cobalt oxide nanocubes among the other nanostructures combining unique properties showed higher electrocatalytic activity. The electrocatalytic performance of cobalt oxide nanocubes also compared with that platinum cathode catalysis. It was observed that cobalt oxide nanocubes showed the higher catalytic performance. Based on the photocatalytic studies, which revealed that cobalt oxide nanostructures activity for the effective degradation of CV and MU dyes, the cobalt oxide nanostructures can be the excellent absorption for this degradation. I thank my collaborators. Once again, I thank to Professor Gunasegaran sir giving me the opportunity to share my experience in this electrochemical application of cobalt oxide nanostructures. Thank you.
Thank you, sir.
Thank you.
Thank you, Dr. Suresh Sagadevan.
Hello, sir. How are you?
For your fine, for your kind acceptance.
Yeah, thank you,
And
sir.
for
Sorry, sir.
having delivered excellent talk.
Sir, I was busy with many meetings and lectures, so I.
Oh, okay. No issue.
Okay, thank you, sir.
Professor Jaishankar also joined with us.
Yes, I know.
Yeah.
Hello, sir. Are you remember me? Jaishankar, sir.
Sir.
Yes, sir. I remember you, sir.
Thank you, sir.
The last year, 20th of February, we had been to UDC college, That's
Yes. No, that time I didn't meet him. I came to second day.
Oh, second day. Yeah.
How are you, sir? How is your
Fine, sir.
Okay. How is the situation in your place? Is okay?
That too we cannot say. COVID is COVID.
Okay. So next is validate, please. Okay.
Yeah. Suresh Sagadev join with us for validity function.
Yes, sure, sir.
Yeah.
Sure, sir.
Within 5 minutes, we are going to start validity function.
Okay.
Please wait for 5 minutes, sir.
Sagadev, when you are coming to India?
Next week, sir. I'm planning.
Oh, next week. Okay.
I will meet you
in the month of July.
Okay, sir.
We are planning to have one conference at St. Peter's.
Sure, sir.
We'll be sending the brochure shortly.
Yeah, sure.
To kindly participate and deliver a talk.
Sure, sir.
Yeah.
It's my pleasure.
And just 2 hours before, so we had a discussion with Jiban Podar also.
Okay.
He is very happy.
Okay.
He also deliver a talk here.
Okay, sir. Sure.
Yeah. Nice.
If you need any person from foreigners,
okay,
bring. No problem.
Okay. Definitely.
Sure, sir. We will discuss in person.
Okay. Nice.
How is your health, sir?
Health is okay. Health is normal now.
Okay.
I'm going for regular checkup.
Okay.
I'm taking medicine regularly.
Okay.
There won't
be careful, sir, during pandemic situation.
Yeah.
Be careful.
Yeah.
Okay.
Yeah.
Still, you are in university or at home, sir?
Oh, just I came from university just now, 10 minutes before.
Okay. Yeah.
Up to 3 p.m. I had been there.
Oh, okay.
And then now I am at home.
Okay, sir.
Yeah. Thanks. Last year in the month January end, we organized one conference at Ambedkar Government College.
Yes, sir. Last year, sir. Not this year.
Last year. Just
yeah.
before before the lockdown.
January and February. Yeah. UDC also.
UDC. February UDC. Yeah. Right.
Next June virtual conference or face to face, sir?
I think at present we are planning a virtual conference.
Okay.
Virtual conference only at present.
Okay.
Maybe depending upon the situation, we'll think it over.
Okay, sir.
We will give option for both virtual as well as online or offline.
Okay, sir.
Local people may be attending.
Okay.
And outside people, depending upon their risk and our risk.
Yeah. See. Okay, sir. Better.
That we can, because both online and offline.
Sir.
Only local people, domestic people will come.
Yes, sir.
And the people coming from outside of Chennai or outside of India are treated the same.
Oh, yeah. Definitely, sir. Correct. Yeah.
All depends upon the second. We don't know the
sir.
future depending upon the pandemic environment.
Yeah, sir. Correct.
And I am quite sure when hot summer, when temperature increases, this corona or something else may go down. That's what we are thinking.
Yeah.
But still, we have to prepare for any option.
Yeah. Correct. Regarding our Porchainudia days,
That
shall
is
we
fixed,
plan?
sir. His date of birth is fixed. His date of birth is fixed. So we are organizing on June 6th.
June 6th, online mode? Offline
Yeah,
mode,
online
sir.
mode only. Most
Online mode.
probably.
Okay, sir. Okay. Dr. Suresh Sagadevan, he has done a very good work when he was in Ahmed University.
Yes, sir. 2 years. Yeah.
He has organized so many events at that time.
Yeah.
I think last conference you attended, sir, organized by our Suresh Sagadevan at Ahmed.
Yes. CSIR sponsor.
Yeah, that period only we gave award to our
Portugal,
Portugal.
sir.
Yeah.
Sir, shall we start, sir?
Okay. We can start the proceedings. No problem.
Good evening, everyone. The end of his story is the new beginning for many others. On this note, let's conclude a remarkable, memorable, and knowledgeable valedictory session. On behalf of the institution, we sincerely thank the dignitaries for being with us, enlightening us with their enthusiastic remarks. We show us our heartfelt gratitude to the professors and everyone of SPM and ISPA family for their wholehearted support rendered in the success. A leader is someone who creates an event. Team members essentially bring life to it. No event can take shape without a hardworking leader. It was the dedication and enthusiasm hidden with her. Her determinations are commendable, and it is her hard work which made this international virtual conference a huge success. She is none other than Dr. R. Arivichandri Ma'am, Assistant Professor, Head, PhD and Research Department of Physics, Sri Vidya Mandir Arts and Science College. Now, I invite Dr. Arivichandri Ma'am to deliver her welcome address and conference report.
A very good evening to one and all present here. Giving everyone in a large gathering a red carpet welcome is a lengthy Indian tradition. Today, I feel very pleased to welcome all the dignitaries. First and foremost, I extend my heartfelt gratitude to our founder, Thiruvi Chandrasekharan sir, who has been by our side in all our positive efforts. It is a great honor and privilege to welcome Dr. S. Gunasekharan sir, Dean, Research and Development, St. Peter's University, Chennai, and the President of ISPA, who is a kind, great inspiration to all of our events. I welcome you, sir. It is also my due privilege to welcome most respected our Secretary, Thiru R.P. Raji sir, who is being with the greatest support of all of us, and their kind guidance moves us towards success. I welcome you, sir. I feel immense pleasure to invite Dr. C.K. Jayasankar sir, UGC BSR Faculty Fellow, Department of Physics, Sri Venkateshwara University, Tirupati. I welcome you, sir. And also, I extend my warm welcome to Dr. N. Gunasekharan sir, Vice Principal of our college. I welcome you, sir. I express my sincere appreciation of the resource person of this two-day International Virtual Conference 2021. I welcome all of you this valedictory function, sir. Above all, I enhance a warm welcome the heads of various departments of our college, professors, and research scholars from various educational institutions, students of our college and other colleges, media personnel, and each and everyone present over here. I welcome you wholeheartedly. The conference report. I am honored to present the conference report of the International Virtual Conference on Physics of Emerging Materials and Molecules as a convener of IVCPEMM 2021. First day in the inaugural program, myself unveiled the welcome address among the gathering. Dr. S. Suresh sir, our colleague COE, revealed the conference main theme to the participants. It continued with the valuable inaugural address by the conference president, Dean, Research and Development, St. Peter's University, Chennai, and founder president of ISPA, Dr. S. Gunasegaran sir, presented the marvelous and efficient inaugural address. The first copy of the proceedings as a CD of IVCPEMM 2021 was released by beloved Secretary Thiru R.P. Raju sir, and it was received by most respected our principal, Dr. T. Balasubramaniam sir. The hard copy of IVCPEMM 2021 proceedings was released by Honorable Vice Chancellor Dr. P. Dhananjayan sir, and it was received by the dynamic ISPA President Dr. S. Gunasegaran sir. It is followed by the award conferring session. The award of the lifetime achievement was bestowed to Dr. P. Dhananjayan sir, the Vice Chancellor St. Peter's University, and ISPA Dr. S. Gunasegaran award was granted to Dr. Senthil Kannan sir, Professor G.S. Pillai Arts and Science College, Nagapattinam, Thiru R.P. Raju sir, Secretary, and Thiru T. Balasubramaniam sir, Principal, and N. Gunasegaran sir, Vice Principal of our college, had felicitated the beautifulite gathering. Dr. M.N. Ponnusamy sir, Professor, Center of Advanced Studies, Biophysics and Crystallography, University of Madras, postulated the keynote address to this grand event. At the fair end of the first day, Professor K. Venkateshan registered his vote of thanks to the gathering. After the inaugural function, the first session of invited talk was engaged by Professor Dr. R. Jaivel sir from Anna University, who is discussed about the nanomaterials for energy and environmental applications. Professor Dr. M.N. Ponnusamy sir from the University of Madras discussed on biophysics and crystallography, in particularly tools for drug design. It was continued by oral presentation. Faculty and research scholars from various colleges and universities presented their research findings. The interaction of extreme laser radiation with radioactive hazardous material was discussed by Dr. P.M. Anbarasan sir from Department of Physics, Periyar University, Salem. The brief explanation of photofabricated zinc oxide and iron oxide nanoparticles of antibacterial drug delivery applications was communicated by Dr. S. Kumaresan sir from Government Arts College, JR. On the topic of recent development of high quality nonlinear optical and ferroelectric single crystals by SR, RSR and ISR methods for device applications of NLO materials was clearly explained by Dr. Muthu Senthil Pandiyan sir, research scientist, Department of Physics, SSN College, Chennai. In the first day, the last invited talk was given by Dr. M.V. Reddy sir, Hydrocubic Montreal, Canada, about the structural and physical properties of thin and bulk smart materials for energy storage and conversion. In the second day, the program was started by Emeritus Professor Dr. S. Gunasegaran sir, Dean Research and Development, St. Peter's University, delivered an invited talk about tribute to Sir C.V. Raman. The brief explanation of growth and characterization of NLO crystals grown by solution was communicated by Dr. S. Kalainathan sir, Professor and Director, V8 University, Vellore. Dr. C.K. Jayasankar sir from UGC BSR Faculty Fellow, Department of Physics, Sri Venkateshwara University, Tirupati, discussed on physics of emerging materials of rare earth doped glasses for photonic applications, science of Kabasura Kudineer and its role in the prevention of control of coronavirus disease COVID 2019 were clearly explained by Dr. C. Segar sir, Professor and Head, Department of Bioelectronics and Biosensors, Alagappa University, Karaikudi. It was continued by oral presentation. Faculty and research scholars from various colleges and university presented their work. Dr. Jiban Poder, Professor of Physics, Bangladesh University of Engineering and Technology, Bangladesh, delivered his talk on the synthesis and characterization of copper-doped nanostructured thin film via thermal spray pyrolysis for glucose sensor applications. Professor Dr. M. Selvapandiyan sir, Periyar University, Salem, pointed out the importance of properties and applications nanomaterial and introduction in his speech. Dr. Venkatrama Reddy Bairu, Professor, Department of Physics, Central Instrumentation Center, Warangal, explained about the synthesis, evaluation of molecular structures from torsional scans and study of molecular characteristics using spectroscopic and DFT method, some diosemic carbozones and investigations of their antibacterial activity. Dr. Suresh Sahadevan sir, Senior Research Fellow, Nanotechnology and Catalyze, Research Center, University of Malaya, Malaysia, gave special talk about metal oxide nanostructure for photocatalyte applications. In the afternoon session, the validity session was well begin with welcome address by myself and also had delivered the conference report to the gathering. The most valuable presidential address to be conveyed by the conference president and founder ISPA, Dr. S. Gunasegaran sir, Dean of Research, St. Peter's University, Dr. C.K. Jayasankar sir, UGC BSR Faculty Fellow, Department of Physics, Sri Venkateshwara University, Tirupati, who is going to convey the valedictory address of the International Conference 2021. Secretary Thiru R.P. Raji sir and Vice Principal Dr. N. Gunasegaran sir of the college are going to felicitate the gathering. Scholars and its participants will give their feedback and valuable suggestions at the conclusion of the meeting. I am happy to announce that we have total 107 abstracts from professors and scholars of various institutions in and around India. As the convener of IVCPEMM 2021, I can honestly state that this mega event was immensely helpful and offered a fabulous platform for the researchers and participants to share the knowledge. My special thank to Dr. M. Selvapandiyan sir, Associate Professor of Physics, Periyar University, PG and Research Department of Physics, Dharmaburi, and Dr. S. Jayakumar sir, Associate Professor of Physics, Ramakrishna Mission, Vivekananda College, Chennai, for their valuable action as a chairperson of the 2-day oral presentation, around 3.5 hours on the both of the days. I do want to express my deepest gratitude to the management, Principal sir and Vice Principal sir, especially ISPA President Dr. S. Gunasegaran sir, HODs of various departments and our department faculty members for their kind cooperations and suggestions for making IVCPEMM 2021 conference as a huge success. Thank you for giving this opportunity. Thank you.
It's the time for presidential address. Honorable Professor Dr. S. Gunasegaran sir. There is a saying that the fragrance of flowers spread only in the direction of the wind, but the goodness of a person spreads in all directions. We are delighted to have such a valuable personality, Honorable Professor Dr. S. Gunasegaran sir, Dean Research and Development, St. Peter's University, Chennai. Now, I humbly request you, sir, to deliver your presidential address.
Honorable Chief Guest of this function, validity function of this 2-day International Virtual Conference on Physics of Emerging Materials and Molecules. Professor Dr. C.K. Jayasankar sir, a most respected Secretary of this esteemed institution, the great Sri Vidya Mandir Arts and Science College, Thiru Raji sir, respected Vice Principal of this college, Dr. N. Gunasegaran, dynamic convener, young and dynamic active convener, Professor Dr. R. Arivichelvi, other members of the organizing committee, professors from the Department of Physics and other departments, Dr. Suresh Sagadevan from Malaysia. Good evening and welcome to one and all. But if you go through the report offered by our convener of this conference, head of the Department of Physics of this institution, Dr. Arivichelvi, really they have done a wonderful job. Even though it is a pandemic period, they have done a wonderful job. This 2-day seminar was well planned, well organized, and well executed. So using a single sentence, we can give this comment: well planned, well organized, and well executed. So on behalf of the Indian Spectrophysics Association, it is my bound duty to express my heartfelt thanks to the management, that is the Kalvi Pidamagan, our chairman of this institution, Thiru V. Chandrasekharan, Secretary Raji, and additional secretary, principal, vice principal, and other faculty members for having accepted to have this 2-day international virtual conference in this esteemed institution. In fact, we are really fortunate because an eminent person, simple person, man of simple word, man of simplicity, the man of few words, but eminent scientist in the field of laser spectroscopy and glassy materials. We are really fortunate because Professor C.K. Jayasankar has honored us by his valuable presence with this validity function of this 2-day international conference. We are really fortunate. Thank you, Professor C.K. Jayasankar, sir, for your kind acceptance.
Thank you very much, sir. It is my pleasure and honor, sir.
Okay, sir. In fact, the deliberations and discussions of this 2-day program offered by 14 eminent scientists in different areas of research. The deliberation discussions may be useful to the young budding researchers who have participated, who are present with this program, definitely. So the deliberation discussions of this 2-day event will take you further to do quality research work in your research area, in your higher education institution. At the same time, service motivation is very, very important thing. Sri Vidya Mandir College, our Honorable Chairman, Thiru P. Chandrasekharan, under the leadership of P. Chandrasekharan, Honorable Secretary and Joint Additional Secretary, Principal, Vice Principal, in particular, our dynamic convener, Dr. R. Arvichelvi, N. Suresh, R. Mugam, all other faculty members who are working here. They have done excellent service for promotion of research culture by way of organizing the national international conference more frequently, at least one event in one academic year. But important thing is to humble request to the delegates who have joined here. You are doing research for promotion of research, for promotion of our human beings on this earth planet. But service motivation is very important thing. I can give 3 observations from nature, because within 2 minutes, I will complete my president's address. Number 1, you take photons emitted by sun. Sun sheds its photon to each and every living system in the universe, in particular on the Earth's surface, without expecting anything in turn from us. This is one observation. The second one is, you take water resources in this globe, on this globe. Water resources give full of water molecules to each and everybody. For example, if you take a single person, one human being, he consumes nearly 68,000 liters of water from the water resource throughout his average life, 68 years. You want to arrange 10 lakhs of water molecules along a line side by side, which comes around only 1 millimeter. This is the size of the water molecule. 10 lakhs molecules are arranged along a line side by side, which comes around only 1 millimeter. How large amount of water molecules they consume from water resources? So water resources give full of water molecules, H2O molecules to each and everybody, not only human being, also aliment system and plant system, without expecting anything in turn from us. This is second observation. Third one is our atmosphere. If you take 1 cubic centimeter volume of air at NTP, normal temperature pressure, which has nearly 2.7 into 10 power 16 air molecules. These are data. Suppose if you remove 10,000 air molecules from this 1 cc volume of air per second, the time taken to exhaust all the air molecules from this 1 cc volume of air, if it is found to be nearly 8 lakhs and 40,000 years. This is the size of air molecules. Our atmosphere gives you full of O2 molecules to each and every body without expecting anything in turn from us. This is third observation. So from nature's observation, so they give some service without expecting anything from the society, from the human being, from the plant system, or from the animal system. So do research. That is my humble request to the all researchers who are gathered here. Do research. Do research. By way of doing research, do something useful to the society without expecting anything in turn from the society, even appreciation and recognition. That is my request. Therefore, my dear young budding scientists, get ready, go ahead, kindly participate, again demonstrate your brain management, time management, and human resource management to provide quality research work in your higher education institution. Then with that, get awards and rewards. Wish you all good success. Thank you very much. Thanks a lot. Thank you. Thank you. Dr. Arviselli?
Yes, sir, it's audible.
Audible.
Now it is audible. Yeah.
Sir, yes, sir. Audible, sir.
Speak with honesty. Think with sincerity. Act with integrity. A fabulous inspirational personality with honesty, sincerity, and integrity, who is none other than our Honorable Professor Dr. C.K. Jayasankar, sir. Now, I humbly request you, sir, to deliver your valedictory address.
Good evening to, shall I go ahead?
Oh, what about Arviselli, the slide?
Sir, slide.
Excuse me, I don't have any slide.
Oh, okay.
No problem. No. Okay.
What?
Okay.
Oh, okay.
Thank you. So, good evening to everyone. I do agree with the earlier speakers. Dr. Arul Selvi reviewed the entire program. Respective people have given different field of research activities. And then finally, Professor S. Gunasekaran really fantastically reviewed. And I want to add one word because it is well planned and well executed. At the same time, it has been well fertilized. Is it no doubt well planned, well executed, but the result is enormous because people got benefited out of these talks, and that is what I can say. And also, you see, Professor Gunasekaran is telling that within India, Tamil Nadu is #1 in research activities. And that is just because people like him are organizing these type of conferences, because in Andhra Pradesh, I never seen such a person or any other state just having simple simplicity and motivating the students across the Tamil Nadu by inviting the speakers entire globally. You see, he is able to conduct the conference across the Tamil Nadu. At the same time, the speakers are coming from across the globe. And now I request the people who are attending this conference, who have been attending the conference, take this note. We should preserve and we have to maintain. Tamil Nadu should be always #1 in research activities. Not only researcher, because we are inspired by Sir C.V. Raman. He is the first Asian, first Indian, and first South Indian got Nobel Prize in Physics. So far, no one got Nobel Prize in Physics. Particularly, from India or in Tamil Nadu. So this tempo should continue, and this tempo should be an example for inspire the young minds. As he told, you see, the nature has given sunlight, I mean photons, and air, and the only thing is in your hand is nothing but you have to work very, very hard to make use of your valuable time, because you see, today we are enjoying the conference on virtual through internet. Similarly, if at all you want to get any field, what is the status of that field, what is the importance of the field, and what are the lagging in that field, you can get it through Google search. Because you go to Google, you will get vast information, advances in material science, because it is a material world. Selvasekar Pandian telling that the material is crystal. Yes, I agree. Not only crystal, it's a material world. And now think about this one. And material research is very, very important. And for this material science, physics and chemistry of the material is important. For that, innovation and creativity is number one. And I request all of you kindly go through the research activities and see that the Tamil Nadu should be always number one. And we are going to do, of course, we may not replace our C.V. Raman, but we have to do research exactly along with the international standards. That's what I agree. And now, the another important point I want to tell you is, someone is asking, how is your health? Professor Bangladesh speaker asked, what is the health condition of S. Gunasekar? When you do research, when you are doing active work, you feel like always young. So you want to, in order to be young, please don't be lazy. Keep create yourself something. Keep on working. That makes you young, energetic, and all other things will go out. And also, he has produced over, I think, 78 PhDs. And I pray God, and also I request all of you, one day we have to see that is the person going to produce 100 PhDs within a short time. And I'm quite sure the entire people will cooperate him and will take benefit of him, and we'll see that Tamil Nadu science will progress, and for which the spectra physics and this institute and all of you who are participating in this conference will contribute something, so that make in India, made in India, but made in Tamil Nadu. That is what I can say. And made in Tamil Nadu, made by Professor S. Gunasekaran and etc. team. I wish you all the best. And I'm quite sure this conference, like this conference, will continue forever. And for that, we should be part of it. And we are looking forward for the same. And I thank you very much for the organizers and also the ISPA for giving an opportunity to share my knowledge. I wish you all the best, and thank you very much.
Professor Jaishankar sir, in collaboration with Telugu states also.
In collaboration with?
Telugu states.
Telugu state.
Telugu states, AP and Telangana.
Okay, definitely. You see, automatically it will come, no problem. You see, automatically it will come. It is understood. South India, that is what I'm telling.
Yeah, exactly. Thank you, sir.
Thank you so much, sir, for your valuable speech. Feedback is a gift. Ideas are the currency of our processes. Feedback promotes personal and professional growth. It provides positive criticism and allows us to see what everyone can change to improve their focus and results. Now, I call upon Jenny from St. Peter's University to deliver.
Sir, Janani ma'am.
Yes, ma'am. Good evening, one and all. Can you hear me?
Yeah.
Thank you. Good evening, one and all. I'm Janani, scholar of Dr. S. Gunasekaran. I'm happy and proud to attend this international virtual conference on physics of emerging materials and molecules. It's fortunate to see all the wonderful emeritus professors around the world in a single platform, and that too on a Zoom platform from home itself. That's indeed a luckiest and fortunate thing for us. And I'm happy to hear various lectures from all the professors and gathered lot of information required for us, which we have missed in the past 1 year because of this pandemic period. It has been a communication to us after a very long time. So I feel again happy and proud to be here part of the conference. Thank you.
Thank you, ma'am. Now, I call upon Ms. Sarita from Thiagaraja College, Madurai, to deliver her.
Sangeeta ma'am. Okay, next.
Now, I call upon Lavanisa Devi from Sarada College for Women to deliver her feedback.
Good evening to all. Again, I'm at the College for Women. The International Visional Conference is well organized and is very informative. This conference helps to gain more knowledge related to research area. Thank you for the management for giving this opportunity. Thank you all.
Thank you, ma'am. Now, I call upon Sonia from deliver her feedback.
Yes. Ovia.
Ovia from GS.
Now, I call upon Maishwarya from Srimandir Arts and Science College to deliver her
Good evening to one and all present here. Today, the International Conference was very much to information for students like us, and it stimulates our research knowledge at high. We are now blessed by giving of the valuable presentations and ideas of eminent honorable professors. Thank you for your precious time to moderate us. And from paper conference, once again, thank you one and all.
Thank you so much for your feedback. It's time for felicitations. There is nothing stronger in the world than gentleness. Nothing so gentle as real strength. Nothing is so real as true gentleness. Nothing is so gentle as true strength. According to the sayings, here, thus we have our most respected secretary, Sir R.P. Rathi sir. I humbly request you to participate in their function.
நமது கல்லூரி நிறுவனர், இந்த கருத்தரங்கின் தலைவர் குணசேகரன் சார், டாக்டர் குணசேகரன் சார் மற்றும் வெங்கடேஸ்வரா இன்ஸ்டிடியூஷன் ஜெய்சங்கர் சார், 2 நாள் கருத்தரங்கில் பேருரையாற்றிய இயற்பியல் துறை வல்லுநர்கள், பிரின்சிபல், வைஸ் பிரின்சிபல், எங்கள் இயற்பியல் துறையின் தலைவர் அறிவிச்செல்வி மற்றும் துறை பேராசிரியர் பெருமக்கள், கருத்தரங்கில் பங்கு பெற்ற அனைவருக்கும் எனது மாலை வணக்கத்தை தெரிவித்துக் கொள்கிறேன். மிக சிறந்த ஒரு கருத்தரங்கம். உண்மையிலேயே எங்க கல்லூரிக்கு ரொம்ப பெருமையா இருக்கு. இஸ்பா நிறுவன தலைவர் அவர்கள் சொல்லியது போல மிக சிறந்த கருத்தரங்கை ஏற்பாடு செய்து மிக சிறந்த முறையில் நான் எங்கள் கல்லூரி செய்வதற்கு ஒத்துழைத்த அனைத்து பேராசிரியர் பெருமக்களுக்கும் முதற்கண் நன்றியை தெரிவித்துக் கொள்கிறேன். எங்களுடைய முழு மனதார நன்றியை இஸ்பா நிறுவன தலைவர் குணசேகரன் ஐயா அவர்களுக்கு மீண்டும் ஒருவர் தெரிவித்துக் கொள்ள மிக்க மகிழ்ச்சி. இது போல நிகழ்வுகளை இந்த கொரோனா பீரியடுக்கு பிறகு மிக சிறந்த முறையில் ஆஃப்லைனில், அதாவது எங்கள் கல்லூரியில் வந்து நீங்கள்லாம் செய்து கொடுத்து எங்களுக்கெல்லாம் பெருமை சேர்க்க வேண்டுமாய் கேட்டுக்கொள்கிறேன். இந்த சிறந்த கருத்தரங்கை மிக சிறந்த முறையில் ஏற்பாடு செய்த எங்கள் துறை தலைவர் அறிவிச்செல்வி அவர்களுக்கு மென்மேலும் ஒரு வாழ்த்துக்களை தெரிவித்துக் கொண்டு இதில் பங்கு பெற்ற அனைத்து மாணவ மாணவிகளும் மிக சிறந்த ஆராய்ச்சியாளர்களாக தங்களை மேம்படுத்திக் கொண்டு இது போன்ற கருத்தரங்களை மேலும் பங்கெடுத்து சிறந்த ஆராய்ச்சியாளர் கேட்டுக்கொண்டு நிறைவு விழாவில் கலந்து கொள்ள அனைவருக்கும் மீண்டும் ஒரு நன்றி தெரிவித்து வாய்ப்புக்கு நன்றி வணக்கம்.
Thank you so much, sir. The most respected Dr. N. Gunasekaran, sir, always murmurs that calmness is a human superpower. The ability to not overreact or to take things personally, keep your mind clear and your heart at peace. Now, I humbly invite our respected Vice Principal, Dr. N. Gunasekaran, sir, to felicitate the function.
Most venerable founder, most respected secretary and additional secretary, respected principal, most honorable and distinguished Professor Dr. S. Gunasekaran, and most respected special speakers of abroad and within India and within Tamil Nadu, and professors from various nations, scholars, and my beloved students. A pleasant good evening to one and all gathered in the webinar. So really, it's a great wonder that this 2 days international virtual conference on physics of emerging materials and molecules in association with the Indian Spectroscopy Association, ISPA, has achieved its success. It's a great wonder. Even during this pandemic situation, the overwhelming response from all the professors, scholars, and students to view this webinar, international webinar, through Zoom link and YouTube link, has created a much enthusiastic interest and enkindled the department head and team of staff members of physics of this college to do again and again such a wonderful conferences. It has created such a interest and enthusiasm among the team of staff members of this college to continue their contribution to this kind of conference. Because within this short span of period, around 107 paper presentation have been held through this webinar. In face-to-face means okay, of course, it may be a long, difficult term. They have to come over from various districts and states and countries. The difficulty here in webinar is also every one of us known that's joining the glitch in the internet, so many interruptions. In spite of all this, the pandemic and the internet glitches, the international conference has made us together to discuss and share our knowledge. Means it's really immense pleasure. And on behalf of the management, the founder, secretary, principal, and on my own behalf, and also on behalf of the Department of Physics, I would like to convey thanks to a hearty thanks to Dr. S. Gunasekaran, the ISPA, because without whom the conference might not be made a grand success. Even in this valedictory ceremony, his speech has left some of valuable and useful information to the scholars and students. I have heard so many times of his address. In each speech, he might have left something some information, useful information, and his talk would have made the students and scholars to think something. It induces the mind, young, enthusiastic minds, but particularly scholarly minds, to do something. Such a motivational speech yours is really, we feel wonder and amazing to have such a greatest scholarly professor like you. And on behalf, once again, I would like to convey hearty thanks on behalf of the management and the department and on my own behalf to you, sir. Thank you. And I would also like to convey thanks to Dr. M.V. Reddy from Canada, Dr. Jiban Border from Bangladesh, Dr. Suresh Sagadevan from Malaysia, and all the other distinguished speakers from various nations and states and in Tamil Nadu also. The list is vast, and it would take more than half an hour to read all those names and their interesting titles that they have given addresses for the past 2 days. Really, all these speech have enkindled the young minds and they have been benefited much. So once again, I convey thanks to all the speakers and professors and scholars, students for your enthusiastic and interesting contribution to this conference, international conference. Really, it is not us, but you speakers and scholars and professors and those who have contributed much only made this conference a grand success. Of course, the last, because I should not, as I am one among the member of this institution, instead of my prize, the prize, the admiration of Dr. S. Gunasthekaran and other dignitaries, that this international conference has been well planned, well organized, and well executed to hear their admiration from their mouth, their heart is really great honor to us. So once again, I convey thanks to all the contributors, all the speakers, all the participant professors and scholars and students. And like these programs, conferences, every time our management is generously ready to grant permission, and we will, I hope you all again and again contribute to us and share your contribution, and we will ready to organize these like conferences for the sake that the Tamil Nadu state must always stand unique and first in the field of research. And in our part of Sri Vidyamandir Science College, we also extend our cooperation and contribution to make the research event to be a great event. Thank you for the opportunity. Thank you, Arun.
Thank you for the valuable speech, sir. Last but not least, it's a time for vote of thanks. As we come to the close of our valedictory ceremony, I invite Dr. K. M. Prabhu to deliver his vote of thanks.
Most respected our founder of this college, respected principal, vice principal, secretary, and additional secretary, our most valuably eminent research person of the conference, respected organizing secretary of this conference, respected HOD, dear participants, and the rest. Very good evening to one and all. It's my great privilege to have been asked to propose a vote of thanks on this glorious occasion. People retired to take much needed rest, but it's highly abused for our most respected and beloved founder that there is no rest forever. It has been witnessed through decades that they always put forth his effort towards the growth and the welfare of the society. I am indeed grateful to our founder, sir, for his providing an inspirational presidential utterance during the inaugural function of this conference. On behalf of the organizing committee and the personal behalf, I may express deep gratitude to our principal sir and vice principal sir, who is the backbone and brain of this conference. Thank you so much, sir. Moreover, for inspiring mentorship, encouragement, and support towards organizing the event successfully. Without them, our college is incomplete. I thank you for our secretary, sir, Mr. R.P. Rajesh, sir, and our additional secretary, sir, Mr. P. Venkatachalam, sir. Thank you so much, sir. I thank the organizing secretary of the conference, Dr. T. Balasubramanian, sir, and Dr. N. Gunasegaran, sir, who has been materially planning each and every dimension of this conference, and also accept their previous effort indeed of the past 2 days to make this program a grand success. Thank you so much, sir. Then I thank our head and Department of Physics, Dr. R. IVCPEMM, for a coordinated welcome and conference report. I thank you so much, ma'am. And also thank you so much for our control of examination, Dr. S. Suresh, sir. I thank Professor Dr. Gunasegaran, sir, Dean ISPA, for his president address, and thank you so much, sir. Then I extremely grateful thank to Professor M.N. Ponusami, sir, Professor R. Jaivel, sir, Professor Jiban Bodar, sir, Professor S. Kalinandan, sir, Professor S. Kumresan, sir, Professor P.M. Anbarsan, sir, Professor C. Sagar, sir, Professor C.K. Jaisankar, sir, Professor M. Selupandin, sir, Professor Suresh Sagadevan, sir, Professor M.V. Reddy, sir, Professor Venkatraman Reddy, sir, Professor Muthusendra Pandin, sir, Professor Jaikumar, sir. Also thanks once again, sir. I am also thankful ISPA Group of Acquisition in general for providing us with all possible logistic support towards organizing this event. I acknowledge the unwavering support received from the various HODs and faculty members of our college and various college departments. I also extend my thanks to all people who have given their precious time. In particular, I would like to acknowledge the thanks organizing and comparing committee, our department faculties, N. Suresh, sir, or Dinesh, sir, D. Balaji, sir, J. Armugam, sir, and our colleagues season of this conference. Also, thanks to Mr. Saran and Mr. Subhas for managing this conference hall and its acquisition facilities. I also thanks to Miss Ilamverai and Kanimoli, her students volunteers for this conference. Also, thank to all research scholars who have great helpers in this organization, the conference. I thank all the office persons of this college for this great assistance in the organizing this conference. I once again thank everyone whose contributions have made this conference a grand success. Thank you so much, sir. Thank you, sir.
Now it's time for national anthem. I request everyone to stand up for national anthem.
जन गण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड़ उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्छल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जन गण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे
Sir, thank you, sir.
Grand success. Keep it up.
Thank you, sir.
See you
Thank
next
you.
time.
Okay, sir. Thank you, sir. Thank you very much, sir.
So congratulations, Gunashekaran sir, and all organizers also.
Thank you, sir.
Dr. Arvind Selvi.
Sir, vanakkam sir.
Thank you very much. Nicely concluded. Wish you all the best.
Thank you, sir. Thank you very much, sir.
All the best. All the best. All the best. Looking forward to see such events in future.
Okay, sir. Okay, sir. In offline mode, sir.
Okay.
Okay. Thank you, sir.
Ah.